Hello everyone, welcome to BYJU'S exam prep. Hope you guys are fine. So guys, good morning everyone. Good morning. Ready? Oh my god, I'm good Arun. I'm good. Good morning Prince, Arun, Alek, Akash, Padma, Banot, everybody good morning. Good morning everybody. So are you guys excited? Because today we'll be having a long day and that too by me only. I'll be the only one who will be taking the session. Good morning, good morning. So let's come on guys, join fast. Good morning Vipul, good morning everyone. So had your breakfast? Had your breakfast? I told you to have your breakfast and come so that you don't feel hungry. Good morning. Good morning. Good morning Pankaj. Okay, good. Good morning. At least girls listen to me. What about boys? Oh, boys also listen. Great. Okay guys. So you're ready with your pen, paper or copy and calculator? Ready? Good morning, Rishabh. Oh, we woke up. I thought that you will wake up late. Okay. See, some people who answer quite frequently, I just have their names like Rishabh, Arun. Abhi kar rahe hain breakfast. Okay, fine. So, guys. So just show me with a heart sign that you are ready so that without any delay we can start. Quick, 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 quick. Good morning, good morning. And one thing which you have to do is share with all of your friends, okay? Don't waste time. So this is a Maha Marathon. Let me tell you one more thing. That is, बिल्कुल शुरू करते हैं. बस quickly let me tell you some things, Pankaj, then we'll start. And see, the session will be in English, but anyway, you think that, ma'am, could you explain it in Hindi? Okay, I'm not able to connect it in English. So you're free to tell me that also. Okay, so mega workshop will be happening on 15th Jan at 12:30 p.m. That if you are a beginner and you are preparing for GATE 2024, what should be your strategy? And this Maha Marathon session will be going for 15 days. 90% scholarship. Paper is on 8th Jan. If you want, you can give this paper. And guys, I hope you have started to give the test series as well. Important. Okay. So last, my Telegram group and ebook is in the description, and this is the schedule. This is the schedule which I have given to you for the coming classes. Okay, so everybody is ready, I guess now. One more thing is I'll tell you. Last time शुद्ध हिंदी में पढ़ा दो चलेगा. शुद्ध हिंदी तो एकदम नहीं आती क्योंकि आप पूछोगे, but the session is in English. Okay, I know Pankaj is very good in English. Good morning, Tiksha. Okay, so guys, what else I wanted to say? Okay, the ma'am, आपका timetable अच्छा था. Okay, thank you. Share it. You guys were asking, that's why. Okay, so ready everybody? Ready? Yeah. The session will be in English version. I was saying to students that if anywhere anybody is facing problem, that ma'am, could you tell the same thing? Not for all the whole session in Hindi for that particular thing, then it's okay. You can ask to me like that. Okay? Should English mein padha do. Okay, fine, Pankaj. Great. Okay, sir. Fine. So it's how much? 10:04. So now we'll start. How's the Josh? And you, lastly, after this, we won't discuss any non-tech thing. At any point now you think that, ma'am, we are saturated and we want a break. So you guys can tell me so that on mutual discussion, we will take a break. I haven't planned any timing, but based on your request, I'll do that. Okay. So how's the Josh, guys? How's the Josh? Come on. Only one student's high. Speed will be high. Yeah. Okay then. Fine. So let's start the session. So right now we'll be starting from raw water engineering first. Raw water engineering, then wastewater, solid waste management, air pollution. Now when you talk about raw water, what do you mean by raw water? So when you collect any sample from natural sources like rivers, ponds or anything, it hasn't been interfered by the humans. That means the man-made interference should not be there. Okay, so that is known as raw water. That's why when you study the first part, it is treatment of raw water, sources of raw water. Okay, now the question comes, the whole process, this is the source, and from the source, the water is transported to the community. So the whole process from where the water gets transported from source to the community is known as raw water engineering. So it's very much important to understand what you mean by raw water. That is that sample which is collected and it is not treated because it may be pure. Okay, then no treatment is required, and if it is not pure, that we will check how much treatment is to be given. Now the next question comes. Tell me, is it possible, specifically in India, that whatever water you get from the source is pure? You don't need any treatment. Is it possible? I'm asking on majorly basis. Say yes or no. Yes or no. Is it possible that we get a water from the source which is 100% pure? Obviously no. Everybody knows. That is the reason. See, if you study something, you should know why we are studying it. So from the source, first you will check the quality of the water. Once you check the quality of the water, then you will go for the treatment of water. Okay, so that is the reason we study in this sequence. But the question comes, how much water is to be taken? Based on that, we will select the source. So first I want to know that how much water is the demand of the people. The demand of water I have to calculate. That is the reason the first chapter comes out to be water demand. Now quickly, this was the basics that source to community, the whole process. Quality of water, treatment, distribution, all these comes under raw water engineering. In that, first of all, when you select the source, you have to think that if I'm selecting this source, will it be able to fulfill the needs of the people? So first, you have to calculate the water demand. So the topic comes water demand. Now, before telling you the methods, there are very important things which you should know. Demand, in the case of water, demand and draft both are same. So generally till now they have asked questions long back in this topic, but you cannot say that they can't ask questions, because if you see the mechanical paper, they were asking questions last year from untouched topics. So similarly GATE can do for environmental, for civil engineering also. Okay, so annual draft, or you call it annual demand, it is the yearly water requirement for the whole year, for the 365 days. How much water is required in terms of volume? That is known as annual draft for the population P. Now, annual average daily demand. For that population P, how much will be the water demand for a single day? Daily means what? A day. So, if for P population, for 365 days, for P population, the demand is V. So, for one day, for P population, the demand will be how much? V by 365. Just applying the unitary method. Similarly, when you say annual average per capita daily demand, capita means person. They can give you per capita, per person, per head. All means the same. So, annual average per capita daily demand. That means one person on one day requires how much quantity of water, or what is the demand of it. So, one day, one person will require how much water? 365 into. Okay, so that is the reason the per capita consumption comes out to be V upon 365 into P. V is the annual demand of the population P. V by 365 is the total demand of the population for a single day, and you divide it by the population, you will get the demand for a single day for a single person. Just like whenever you basically, when you take milk, you say that 1 liter milk, 2 liter milk. When you take rice, you say 1 kg, 10 kgs, quintals, tons. Similarly, when you want to report water demand, you report it in terms of LPCD, liters per capita per day. Okay, so this is, in short, we say LPCD. This is the official denotions. Okay, so that is what is written here. Total yearly water requirement, this will be in liters. 365, 365, that is when you divide it by 365, you will get for 1 day. And when you divide it by the population, you will get for per person. So per capita consumption is reported in terms of LPCD. Okay, now let's be quick. These are the demands, have not been asked, but they can ask you in terms of statement wise questions, or they can ask you in match the following questions. Domestic water demand, the water which is required for drinking, cooking, washing, this is known as domestic water demand. It varies from 135 LPCD to 225 LPCD. Let me tell you one thing. 135 LPCD is for low income group, and 225 LPCD is for high income group. So we say LIG and HIG. Okay, why I'm telling you these basics things? Because in MSQ, generally they ask you statement wise questions. So you should know this. Then industrial water demand, it varies from 50 to 450. Now you can ask me, ma'am, why there is a huge gap in the range? Because it depends upon the extent of industrialization. Smaller industries, bigger industries, some industries require more water, some industries require less water. So it depends upon that. Institutional water demand, like coaching centers, you can say schools, hospitals. So they require 20 to 50 LPCD as the water. Now you will say that, ma'am, it is mandatory that 20 or 50, this will be the range. No, it can be greater than this. It can be lesser than this. Okay. Water for public use, that is 10 to 20 LPCD. Then coming to the important one, water for public use, if you want to know, like when you wash the roads and all, for that purposes also water is needed in public parks and all, for basically watering the plants and all. So for that purpose, water is needed. So that is the reason 10 to 20 LPCD. Now fire demand, important. Fire demand is if certainly a fire breaks out in your city. So you will be like, okay, fine, we'll open the tap and we'll bring the water. No, it's practically not feasible. You have to store a certain amount of water. So the amount of water needed for fire demand is very minimum, that is 1 LPCD. Now you will say, ma'am, such a less quantity of water. You're telling domestic demand is this much, industrial demand is this much, and fire demand is so less. 1 LPCD, can you believe 1 LPCD? Yes, because the outbreak of fire does not happen every time. Okay, that's the reason you should know. But there are empirical formulas which they can basically they can give you which are the formula to be used for fire demand, and these are empirical formulas. Whenever I say empirical means units, observation based formulas, and units has to be taken care of. So first is Kuchling's formula. Q is equal to 3182 root P. Let's be quick in this. Everywhere the discharge which you will get will be in liters per minute. The population will be in thousands. Don't worry, we'll do a numerical also. Population in thousands. So guys, let's be quick. If the population is, let us suppose 2 lakhs. So what you will substitute here? If you don't mind, last words are not visible. Where should I shift? If I'll shift here. Okay. Now is it visible? Let me check it out first. 200. How? I did opposite. P is 2 into 10 raised to power 5 divided by 1000. So this will become 200. Okay, so you have to substitute here 200. So everywhere in all the formulas you have to do this. Now one doubt which you guys have is population in thousands. Yeah, already substituted. Fine. Now the one question which I wanted to ask you and basically tell you, basically in some books you find they write it as 1135 P by 5 plus 10. Sometimes they write 1136 P by 5 plus 10. See, this is observation based, so ambiguity will be there. But generally when you use 1135.5, then you use P by 5. General basis, when you take 1136, you write P by 10 plus 10. So actually many students ask me the same thing, so I have confirmed it right now. Okay. Q is liters per minute, P is in population in thousands. Everywhere you will get the same thing. National Board of Underwriters formula, this Alek I'll tell you, this is written 4637 root P 1 minus 0.01 root P. Okay, but remember, again a statement wise question, or they can judge you also. This formula is applicable only when the population is less than or equal to 2 lakhs. If the population is greater than 2 lakhs, you cannot apply this formula. For that, they have generally given you the provision that 54,600 600 liters per minute will be there. That will be the demand for fire. Additional 9100 liters per minute to 36,400 liters per minute will be there in case an outbreak of second fire takes place. Okay, again a statement wise thing they can ask you guys. Okay, now Buston's formula 5663 root P, where discharge is in liters per minute, P is the population in thousands. Last, this is important one. If you go through the Indian standard codes, the fire demand which you get is in kiloliters. Remember this. Never ever they have asked till now. So if in books, if you see the old books, they have written 97 root P. This was prior to 2012. As per the modified version, now you get 100 root P. So if you study from the old books, gets your facts checked better, because now it is modified. So as per IS code, the fire demand comes out to be 100 root P. Here, the fire demand you will get it in kiloliters and the population will be in thousands. Okay, Jabalpur formula. Okay, fine. So till here, any doubts? Now, this is a very important thing. I am talking about designing of raw water scheme. Fine. So let me tell you some things. Like if I talk about generally, if I talk about if this is the discharge and this is the time. So it's, let us suppose it's morning 12 to 6, 6 to 12, then 12 to 6 p.m., then 6 to 12 p.m. and so on. So generally your water demand will be like this time it will be more, then this is the time, this is more and so on. And this varies from person to person. This varies from person to person. Now I believe that you guys take a bath in winter season. Okay, specifically boys, because generally boys don't take a bath in winter season, is it? Arun and everybody. So you are saving the water. I know that. So actually the water demand varies from person to person. Okay. So now the question comes, if for one person the demand is varying, what will happen to the entire? Ma'am, for hospitals there will be no water demand. If there means how much? Sach bol diya. I said this water demand beta, this is for institutional commercial. Fixed value, how much it is there, because if you see the code, it is written for hospitals. If you're asking na 50 beds, 100 beds. So if you see the code in detail, it has given for how many beds which are there in hospital, based on that the water demand. I have just given you a range of it. Okay. If you see the codes, I don't think you need to learn the whole code, but yeah, you can go ahead. Okay, सच बोल दिया मैंने विशाल. 8 बाल्टी से. Oh my God, Arun. Now you wasted the water. Okay. So now the question comes. The demand for a single person fluctuate. Like you guys for today marathon, I also woke up early. Otherwise, I wake up at 9. Okay. So what will happen? My water demand will start from 9 a.m. If Arun wakes up at 7, his water demand will start from 7 a.m. So person to person water demand is varying, and person to person the peak demand also varies. But if I consider a single person, it will not be possible for me to design the raw water scheme. Now you will come, ma'am, designing? Yes. If you see, there is a source. From the source, there is a pipe which takes to pumps and canals. From here, it goes to the water treatment plant. From water treatment plant, it goes to the service reservoir, that is pani ki tanki in your locality. and from service reservoir, it goes into the distribution system. So technically, guys, you need to design it for all these components. It's not randomly we can use it. No, we have to design it. So this is pipe 1. Pipe 1. So even the capacity of pipes and all this you have to design. You have seen those nowadays that concrete sewer pipes are also being installed and the normal laying of pipes. So everything is to be designed. Okay. So, thoda right. Okay, fine. I'll do right. Is it okay? Fine. So now the question comes, when you design the source, now is it visible? Okay, fine. So the source, pumps, water treatment, service reservoir, everything is to be designed. So there are terms which you should know. This is the whole raw water. This whole process from the source to the community distribution system, that is to your homes. This exactly is the whole raw water engineering. Now comes the question. There are two terms which you need to know: maximum daily demand and maximum hourly demand. Maximum daily demand means out of the 365 days, there will be a day where the demand of water will be maximum. It might be a day of Holi, it might be the day of anything like Diwali, or any day it can be there where the demand of water will be maximum. So that is known as maximum daily demand. Let us suppose today is what? 6th January. So let us suppose the demand on 6th January is the maximum. So what I can write? 1.8 annual average daily demand. Annual average daily demand is means for the whole population P, what is the water demand for a single day? So if you say for one person if the demand is X, so for the whole population P, the demand will be how much? P into X. Okay. Now, one thing which is very important you should know, you will ask me that, ma'am, from where this 1.8 is coming? This 1.8 is observation based. Okay. Now, maximum hourly demand, I told you don't make this mistake if they give you also. Remember, maximum hourly demand does not mean that out of 365 into 24 hours, which will be the 1 hour when the demand will be maximum. No, this is a wrong concept. It means that let us suppose if 6th January water demand is maximum, on 6th January there will be 1 hour when the water demand will be maximum. So I'm talking about that hour of 6th January. So generally in books you will see they write MHD, MHD, MHD. You learn it maximum hourly demand, maximum hourly demand. But they don't mention because they assume that you understood maximum hourly demand of maximum day. Okay, so which is equal to 1.5 average hourly demand of maximum day. And average hourly demand, how you calculate? You do what? You add all the hours water demand. So it will come out to be maximum daily demand divided by 24 because you need it average. Fine. So when you substitute in place of maximum daily demand, you can substitute 1.8. I'll write it annual average daily demand. In short, I'm writing it 24. So this comes out to be, this 1.5 into 1.8 will come out to be 2.7 and this will come out to be annual average hourly demand of maximum. Okay. So this you should know. Correct. 2.7. Now, again one question generally they have asked in EAC and your state level questions. Still now they haven't asked in GATE. Fluctuations. This word fluctuations, let me tell you. Fluctuation means any parameter. Let us take P. So in our case, fluctuation is for water demand. So it is the ratio of maximum to average. How many times maximum water demand is more than the average? Or you can say how many times average water demand is more than the minimum. So this is known as the fluctuations. Right now not asked in GATE. Again telling you, asked in your state level examination, AE, JE papers and your ESC. So fluctuations in daily demand is 1.8. Fluctuations in hourly demand is 2.7. Important. Okay. And the hourly variation factor, it is 1.5. Statement wise they can ask you. Clear? So this you should know. Now comes the question, ma'am. So source we design for how many years and for maximum daily demand or maximum hourly demand? So let's check it out first. So source, we design it for 50 years. Pipes, we design it for 30 years. First question which comes into picture, why is source designed for maximum number of years? Come on guys, answer me. Why source is designed for maximum number of years? Why? Come on. I want the answer. Why source is designed for maximum? Arun, Pankaj, everybody has to serve MVS. Anything else? See, this whole treatment units are based on the source. Long-term purpose use. Yeah, huge investment is there. Moreover, these pumps, this pipes, water treatment, everything is basically dependent on the source. That's why source is designed for maximum number of hours. We don't construct source, we construct intake structures for it. Okay, so that's the reason it is designed for 50 years. Pipes are designed for 30 years. Distribution systems are designed for 30 years. Pumps, water treatment units, service reservoir are designed for 15 years. Now again comes the questions, why they are designed for lesser number of time? Reason, just like your mobile phone. Serviceability, all sessions require, whole syllabus will be covered in this session. Yes. Now, just like this mobile phone, like Apple, every year it launches a new thing with new camera, with new, you can say new features in it. So what happens? You feel like, now I should sell one of my kidney and buy another one. Just kidding. But you get tempted, right? So the question comes, there is a technical updation which takes place. Similarly, in the case of pumps, water treatment, service reservoir, there is an updation techniques, new techniques comes. So what, ma'am? Let us construct a bigger one. We will use it for 30 years. If you are doing that, you are investing large amount of money now. And if you are investing large amount of money now, for a longer period of time, you have to use the outdated technology. Clear? That is the reason this is designed for lesser number of years. The question. Now, one thing, pumps and canals, this is very important. This is very, very important, specifically when you study it in irrigation engineering also, and if any question comes in your environmental engineering. Pumps and canals generally does not operate for 24 hours. Okay, MDD you say it, but generally it's not MDD also. Why? Because it does not operate for 24 hours. Remember this. Why, ma'am? Why pumps will not operate for 24 hours? Beta ji, you have to give electricity bill also. Okay, that's the reason I tell you. You tell me one thing. One is 240 liters. You need 240 liters. So you will design or you will take a pump which has 240 liters of pumping capacity, or you will take it for 420 liters. Come on guys. Based on your knowledge, tell me. You need 240 liters of water per day. So you will take a pump of 240 liters or 420 liters? 240, 420. Fast, fast, fast. 420. Why? Because if I need 240 liters per day, I have to pump for 24 hours. But if I need I have basically purchased 420 liters pump capacity, so I will operate for 12 hours. So what, ma'am? You spended the money for 420 liters. That pump would have been costly, yes. But initial investment cost is more, but operation cost is less. Remember these technical terms. Initial cost is less for this one. Initial cost is less, but operation cost is more because the pump will be operating for 24 hours. To 420 liters, initial cost is more, operation cost is less because I will be operating only for 12 hours. So generally in environment and irrigation, whenever they'll give you questions, maximum number of times they'll specify the pump is operating for 8 hours, the pump is operating for 10 hours. And why you want to get that example? Take it in your home. We say na pani chadha rahe. In Hindi you say that, mummy pani khatam ho gaya, pani chadha rahe. Switch on the pump. There is no water. So do you operate the pump for 24 hours? No, you don't do that. Okay, because it requires electricity. That is the reason. Clear? Now, next comes pipe and distribution system. They are designed for maximum hourly demand or maximum daily demand plus fire demand. This is known as coincident draft. In some cases, in many exams they have asked actually, coincident draft is MDD plus fire demand. Remember, sometimes they ask you coincident draft, sometimes they ask you distribution system is designed for. Both are different. Now, one question maximum students get confused. In your AE exams, in your ESE exams, in your GATE examination, it has been asked. Sometimes what they say, distribution system is designed for. They write MDD, they write MHD, they write this fire demand, they will write MDD, and they will write the fourth option, maximum of, this is A, B, C, D. Maximum of A and B. If this question comes, you mark it at T. Now let us suppose secondary format they judge you is they write only MDD, MHD, and they write any other things also. Let us suppose fire demand, and they will write none of these. So in this case, if they give you option like this, suppose if such option comes in your exams, so generally the answer which they take is maximum hourly demand. Okay, so based on the options, you have to do what? You have to modify your answers. Okay. Now, let me tell you, 95% of the times in numericals which is being asked, maximum daily demand plus fire demand comes out to be maximum. Okay, wherever if you are giving the test series and all, 95% of the time MDD plus fire demand comes out to be maximum. But that doesn't mean in the examination you won't calculate MHD. Don't do this mistake. They can set the data in such a format that maximum hourly demand will come out to be maximum. Okay, so that is the reason calculate MHD, calculate coincident draft, which of the maximum will come, do that. Okay, take that into account. So don't be in overconfidence. Okay, so till here, any doubt guys? Enjoying the session? Rishabh, everybody's speed is okay? Fast. Actually, there's 20 seconds lag in YouTube. So whatsoever I say, it reaches to you after 20 seconds. Okay. Ayan, it's right. Fine. So this is the question for you. The population is given to you. Average water consumption is given. You have to calculate the fire demand in MLD and the capacity of the distribution system in MLD. Come on guys. Faster. Population is 3 lakh. Buston's formula. Population in thousands. So 3 into 10 raised to the power 5 divided by 1000. First, you will get the answer in liters per minute. After that, you have to convert it into liters per day. Get me this answer in liters per day. That will be better. Calculate. On MLD also. Come on guys. First, liters per minute it will come. How much it is coming? Anybody? Liters per minute. So if you want to convert it into days, multiply 24 into 60. It will be 1 upon. So it goes into the multiplication side. Okay. And for MLD, divide by 10 raised to power 6. How much it will come? I am asking in MLD. Just check it out. I might write wrong also. Calculations, you have to check it out. So this is the Buston's fire demand which you are getting. 140. Correct, Girish. Okay. So this is the by Buston's formula. This is the fire demand. Now if you want to know the capacity of distribution system. So you have to calculate MDD also. You have to calculate MHD also. So MDD is what? 1.8 times annual average daily demand. So one person requirement is 335 liters per day. How much will be required by 3 lakhs? Calculate it in MLD. Divide by 10 raised to power 6 and tell me. This is maximum daily demand. Now if you talk about maximum hourly demand, that will be 1.5 times of maximum daily demand. One 141.24, that I got it. This one, how much it will come? 180.9. Okay. And this one? Or I have to calculate. 1.5 into 180.9 million liters. So distribution system will be what? Maximum of MDD plus fire demand and MHD. How much it is coming? MDD plus fire demand. It is going above my head or what? MDD plus fire demand. 180.9. Fire demand is how much? 141.24. How much it is coming? How much it is coming? 180.9. 141.24. This comes out to be 322.14 mld. So the distribution system is designed for 322.14 mld. Why? Because MHD is 271.35. So maximum of 322.14 and 271.3. Clear? 331 it is coming. 322 it is there. Dinesh, beta, check it out once again. Okay. So this is the simple questions which they can ask. Fine. So now, coming further, the population forecasting methods. Population forecasting methods. Why? Because you need to forecast the population. Now, before that, the population depends upon many factors, like it depends upon the birth rate. You know that, right? There's the population, we are second and we are proud in India, okay, out of the whole country. After China, we are the second in producing the population. So birth rate, it affects the population. Death rate, it affects the population. Nowadays, death rate has reduced also, you can say, and you can say increased also. Now you say, ma'am, increased and reduced both, because nowadays there are new types of diseases which are coming which you have never ever heard of. Okay. Secondly, reduced because we have now, everybody has money and we have latest technological advancement in the medical science also. So death rate is reduced because of that. Then there is migration. Migration, there is a word which again they haven't asked in statement wise questions, but they can ask you is positive migration and negative migration. Positive migration, if you shift from a place, let us suppose I am living in Bhilai and I want to shift to Noida. So from here I am shifting to Noida. So Noida there will be a positive migration, but in Bhilai there will be a negative migration. Okay, because the population is what? Reduced, because I along with my family shifted to Noida. Okay, so this is migration. Then there is one more thing, increase due to annexation. Now what you mean by annexation means in Hindi we say kabja karna. Let us suppose if we do annexation of any nearby country. I won't take the name, otherwise there will be a case on me also that I am planning it. So if I want to basically annexate any of the neighboring countries, so what will happen is the population will eventually increase. Okay, so there are n number of factors like pandemic and epidemic. I guess you know the difference between pandemic and epidemic. Okay, like COVID came, lots and lots of people died. So that is what it happens 1 in 100 years. So because of that, the population exponentially decreased. So that can also be a reason. Okay, so now when you forecast the population, there is no, every city is not similar. You know, some cities are very old, some cities are now only formed. So that is the reason population forecasting methods varies. It is not at all necessary that in the gate examination they will give you which method to apply. They can give you certain sentences based on that which you have to apply your brain, whether to go by arithmetic, geometric or whatsoever methods are there. So this is the first arithmetic increase method. What happens in this? You assume that the growth of population is constant. It is constant. That is dp by dt is constant. Okay. So the formula for forecasting comes out to be Pn is equal to P naught plus Nx bar. This formula derivation is there, but that's not at all required. Pn is the population after, let us suppose 2010 was the last population, you know, as per the census. You know, census in Hindi we call it as Janganna. So they come to your home, how many are males, how many are females, how much they are educated. So everything is mentioned, basically taken the data and it is mentioned in the census. So every 10 years the census is being taken. So 2010, if let us suppose, was the last recorded census and you need to forecast or predict the population in 2030. Now first question comes, ma'am, why do we need to forecast the population? Because if you design the water pumps and canals or service reservoir for present condition, your whole this equipments will fail. Because obviously it is by default true that next time the population will increase. Worst cases happens like COVID and all, then only the population will decrease. Otherwise 100% chances are there that it will increase. Okay. So that is the reason we design it. We forecast this. Like suppose if we design it for 50 years, after 50 years, whatsoever is the population, keeping that in mind, we are designing it today. Okay, so that is the thing. So 2010 is the last known population, so it will be P naught. 2030 is the decade for which we need the population, so it is Pn. The difference between these two is 20 years, so N is 2. And X bar is how much increase in population on average basis has taken place. Just like China, Russia, yeah, that's true. Okay, so this is the arithmetic increase population. You use it for old cities nowadays, or in the examination they will say compute the population in this method. In this method, what is assumed? Rate of growth of population is assumed to be constant. They will not mention arithmetic increase method. They will mention assume rate of growth of population is as a constant. If they mention like this, remember this is practically not true. But in arithmetic increase method, this assumption is taken, and if in the question they mention this line, you have to go for arithmetic increase method. Okay. So now let's solve this question. Let's solve this question first. Come on. This is the question. Similar pattern of question has been asked in your gate examination also. This was a good question. Same question, ditto same question. Right now they told you assume an arithmetic rate of population growth. Ditto they can ask you for geometric rate also. Okay, I'll tell you where the difference will come. First let us study geometric rate also, then I can tell you where the difference will come. Okay, because right now they have asked for arithmetic, now they can ask for geometric also. So geometric, I'll tell you, geometric increase method, uniform increase method, compounding method. All these three means the same. In the arithmetic method, dp by dt was constant. In this, percentage rate of growth of population is constant. So again, if they want, they can write this and they will say compute the population, forecast the population. So you have to apply your brain that this time it is asking to calculate by geometric increase method. So percentage R will be rate of growth is assumed to be constant. So here Pn is equal to P naught 1 plus R to the power 100. Now very important thing. Pn is same. Population after n decades. P naught is the last known population. You remember Arun and everybody, you remember once I told you that formula revision of environmental engineering, that there everybody made a mistake. I told you arithmetic increase method, geometric increase method. But for calculation of R, if you want to calculation of R, that is percentage rate of growth, there are two methods. One is arithmetic method, and that is R1 plus R2 plus R3 dash dash n. Remember, this n is not number of decades. This is number of rates. Ma'am, what do you mean by number of rates? If R is 4, you write it 4. Like if 4R you have taken, write it 4. If 5R you have taken, write it 5. Okay, so this is arithmetic mean method for calculating R. Geometric mean method R is R1, R2, Rn 1 by n. This is geometric mean method. Very important. Again, I'm telling you a statement wise thing. If in examination they are not telling you how to calculate R, go by geometric mean method, because as per your code it has told to take the R value as geometric mean method. If you go in the field and all, or if any interview question comes, there generally maximum times the engineer takes this value to calculate. Now you will say, ma'am, it is cheating. In the code it is telling you to do by geometric mean method. You taught us this, but when we went to the field it is telling us to go by arithmetic mean method. What is this discrimination? Reason is, by arithmetic mean method you get more value of R. More value of R means more value of the predicted population. Everybody wants to be on the safe side. The engineer in charge who is doing all this calculation also wants to be on the safe side. So he forecast more population. That's it. Okay. So these are the method of calculating. If not mentioned, go for geometric mean method. For calculating R, remember, arithmetic increase method, geometric increase method are method for population forecasting. Arithmetic mean method and geometric mean method are method for calculating percentage rate of growth, that is R. So there is a difference between the two things. Don't get confused, because you guys got confused in formula revision also. Now, let's talk about this question. First, I will tell you by arithmetic, and I'll tell you where the changes will be there if same question is asked by geometric method. The present population of a community is 38,000. Okay, fine. And average water consumption is 5,700 meter cube per day. Now, the water consumption is 5,700 meter cube per day, but the plant has a design capacity of 7,500 meter cube per day. And it is expected that the population will increase to 54,000. So right now, if the population is 38,000, it will increase to 54,000 in the next 20 years. So let us suppose Pn is equal to P naught plus Nx bar. In the question, it is giving me that 54,000 and here it is 38,000. And it will increase in next 20 years. 20 years means 2 decades, because 1 decade is equal to 10 years. So can you calculate, guys, and tell me what will be the X bar? What will be the X bar? Yeah, arithmetic mean is greater than. What will be the X bar, guys? Faster, faster. $8,000. So 8,000 per decade. Now in the question, it is not asking me X bar. It is asking me the number of years from now, that is from 38,000 population, what will be the number of years when the plant will reach its design capacity. So Pn is equal to P naught plus Nx bar. P naught I know, 38,000. Number of decades I need to calculate. X bar I already know, 8,000 per decade. So let us suppose right now, if 5,700 meter cube per day is the demand and 38,000 is the people, what will be the demand of one person? So 5,700 meter cube, that is 10 raised to power 3 liters per day, divided by 38,000. This will give me the demand currently for one person one day. It comes out to be 150 LPCD. Now, if 150 liters is the demand for one person, for 7,500 meter cube per day of demand, how many people's demand is there? Or you can say, how much population has to be there such that the demand becomes 7,500 meter cube per day. So you can calculate this. Just reverse it. How you reverse it? 7500 into 10 raised to power 3 liters per day divided by 150 LPCD. Go through the units. This will tell you how many population is there. Tell me. Calculate. 7 50,000. 2, 3, 4. So you will solve it. This will come out to be how much? 1.5 decades. That is 15 years. Okay. If you want similar question, they can ask you. Only difference will come. They will tell you geometric method. This will remain same. This will remain same. Only change will be done is Pn is equal to P naught 1 plus R into N. Okay. In this question, this will be 54,000. This is 38,000. This will be 38,000. Okay. You need to calculate R and this is 2. Okay. So from here, you will calculate R. If this question would have been in geometric increase method. So with the help of it, you will calculate R here. And again, you will use this formula Pn is equal to P naught 1 plus R in N. Okay. And here, you will substitute 50,000 as it came. 38,000 1 plus R to the power N. R you already calculated, you will get N. But this time you have to use log for calculating the value of N. So everything concept will remain the same, only the formula will change. Clear everybody? Understood? MVS, everybody understood? And one more thing. Ma'am, but in many books they write it as, they write like this. If they write like this, you have to substitute R in percentage. If they write like this, you have to substitute R in decimal sign. Okay, so this you should. This is geometric increase method. This is used for young cities, or you can say rapidly growing cities. Remember. Okay. Now, coming to incremental increase method. Always remember, geometric increase method gives you a higher value of population forecasting. Arithmetic increase method gives you a lower value of population forecasting. But incremental increase method gives you a moderate value of population forecasting. Okay. If you remember, there was one question asked in GATE examination where they didn't mention which method to use. Okay. And generally it was done by incremental increase method. But don't worry, nowadays they won't ask such sort of questions with you. So Pn population after n decades, P naught last known population, n is number of decades, x bar is, as already told you, how much on an average basis population is increased. So average increase in population, and y bar is how much increase in average has taken place. So incremental increase in population. Clear? This is incremental increase method. Okay. So this was till here. Now talking about decreased rate growth method. This is very important because what is happening? Let us suppose I give you this example. Let us suppose initially Girish example I take. Okay. Girish used to eat two chapatis. Then I said, Girish, I am cooking food for you. You are my good student. You topped the examination. Treat it on my side. So fine. We went to the hotel because Girish scored AIR rank 1. And I told him that order. So Girish told that, ma'am, my diet is 2 chapatis. I will say, no, today is your day. Eat 4 chapatis. So he ate 4 chapatis. Then Prince also said, bhai, today is your day. Eat 1 more chapati. So then he ate 5 chapatis. So initially Girish diet increased to how much percentage? 50%. And then from 4 to 5, the Girish diet increased to how much percentage? 1 by 4 into 100, that is 25%, right? So what is happening? The diet of Girish is increasing, but the percentage at which its diet is increasing is decreasing. Getting it? Obviously, you can see 2, 4, 5. The chapatis which he is eating is increasing, but the percentage is decreasing. Similarly, when you talk about decreased rate of growth method, the population increases, but the percentage at which the population increases is decreasing. Clear? Clear? Understood what I meant to say? Guys, faster, faster. You can give a thumbs up. Don't need to write heavy statements and all. Clear? Clear, Girish, Prince, everybody? Okay. So now, this method is trickier. There's one difficult formula. I didn't wrote it also, and I don't want you to remember that formula also, because in civil engineering, a number of formulas are there. Don't remember that formula for decreased growth rate method. I'll tell you a simple method to solve it. Simple method to solve it. How? Let's talk about it. 2020 year, the population is given to you and it is asking you in 2040. Okay, now see. I have taken a blank slide because I want to make columns and all also. 1980 till 2020. Okay. 1980, 1990, 2000, 2010, 2020. What is the population? 40,000, 46,000, 40,000, 46,000. If you don't remember the formula, that will be good only, because obviously in your brain lots of more formulas are there. So why to waste time? 60,000, 68,000. 60,000, 68,000. Okay. So this is the population. This is the year. Now how to calculate? First you will calculate the percentage rate of growth. How much growth has taken place? How you will calculate? Come on guys, ready with your calculator. Arun, MVS, everybody. 40,000 divided by 40,000 into 100. How much it is coming? Similarly, 54,000 minus 46,000 divided by 46,000 into 100. 54,000. Similarly, calculate everything and be fast. 15% is for the first one. Then 17.39. Then 11 point. Tell me first, second, third, na. Otherwise, how come I'll know? 11.11%. And last one, it is coming how much? 8,000 into 100 divided by 60,000. 13.33%. Right? Okay. This is percentage rate of growth. Now, how much decrease is taking place? Decrease in percentage rate of growth. So, this will be 15. I'll take other color pen. If any color pen you're having problem, then let me know that also. Huh? 15 minus 17.39. How much it is coming? How much decrease it is coming? 15 minus 17.39 minus 2.39. Then again 17.39 minus 11.11. How much it is coming? 17.39 minus. Anyway, if you do the formula also, you have to do this. So don't think that if you do the formula, you don't have to calculate. Then also you have to calculate. 6.28%. Then 11.11 minus 13 point. It was 33 na? 33. Plus 2.39. No beta, no plus. No. That's the wrong thing, Bhanod. Always from this to this. Whenever, everywhere you used to do from the higher one to the lower one. Okay. Or from the current one to the previous one. But remember, when you calculate decrease, I will do from the initial to the final. Okay. So this will come out to be how much? minus 2.22 percentage. Okay, so from here, if you want to calculate R, that will come out to be minus 2.39 plus 6.28. You have to take the sign also into consideration. Divided by 3. How much you are getting? How much you are getting? 2 point minus you are getting. Just let me take it out. 0.566. Yeah. 1.67. How come? Divide by 3. You guys have done it? Yes, Devanshu and I got the same answer. 0.556 per decade. Now remember, that means in this there is no direct formula. If you go through the method of formulas also, you have to calculate. If it has asked you 2040, then also first you have to calculate for 2030. It is mandatory, you have to go here in sequence format. That means the percentage is decreasing. If in 2020 the percentage is 33.3, the percentage will reduce. That's why it is decreased rate of growth method. So it will be how much? 13.33 minus 0.556. So this will come out to be 12.774 percentage. So that means the population in 2030, although it has not been asked, but you have to calculate, it will be 68,000 plus 12.774 percentage of 68,000. Guys, calculate and tell me fast. I don't have the answer with me. 76686.32. 76686.32. Now talking about 2040. Similarly, if for 2030 the percentage rate of growth was 12.774, if you subtract minus 0.556, you will get it. So this will come out to be 12.774 minus 0.556. This comes out to be 12.218 percentage. So the population in 240 which is asked in the question will be population in 2030 plus 12.21 percentage of population in 2030. Now guys, tell me the answer. In this manner you will proceed. Clear? How much it is coming? Calculate and tell me fast. 86055.85. So this will be the answer. So if you go through the formula or any method, you have to go like this only. So better don't go through the formula, go through the logic. Calculate the decrease in percentage, okay, and then subtract it. Now, one mistake, don't do it. Some people do the wrong method. They say that if you want to calculate for 2040, do what? 13.33 minus 2 times of 0.556 and then do 68,000 plus how much it comes. That is the wrong approach. Don't go by that method. Okay. Everybody is getting different. Arun, you are getting different answer beta. Just check it everybody. $86055. Arun, wrong answer beta. Fine. Clear? This method is clear everybody. Deepak, Girish, Tiksha, everybody it is clear? So this is the method. Now talking about simple graphical method. Mistake. Okay, fine. Do mistakes here, not in your gate exam. Now simple graphical method, not used. Basic. It is based upon the experience and intelligence of the designer. Now let us suppose in 1931 you know the population, in 1941 you know the population, 1951 you know the population, 61, 71, 81 you know the population. After that you want to compute the population for 2011. Okay, for 10 years it happens. 1981 was the last population you know, and let us suppose 2011 you want to know the population. Based on the pattern, the engineer, the designer will extend this graph. Okay, will extend this graph. Now what will happen? Let us suppose if this is the graph, what will happen if he has extended the graph like this? So what he will do, he will draw a line parallel to the y-axis from 2011. The point it will touch the curve, from that point it will draw a line parallel to x-axis. The point at which it will cut the graph on the y-axis, that will be the population. Simple as that. But how the curve is extended, that depends upon the experience of the designer. Okay, so this you should know. Okay, fine. So this is the thing which you should know. Okay, practice session. Okay. So this is simple graphical method, not used that much, but if it comes, so I told you, it depends upon the intelligence and experience of the design. This is the comparative graphical method or comparative graphical method which is used. Now what happens here? What happens here is, basically, let us suppose this is used because the new city is developing in a similar manner as compared to the previous city. Let us suppose, if you talk about in my area, New Raipur is developed. Now, New Raipur is developing in similar manner like New Delhi, like New Chandigarh, like New Bhopal. Okay. So now what happens for city A, for which I need to forecast the population, I came to know that city B, city C, city D and city E are developing in the similar manner. Of course, the year will be different, but yeah, they have developed in the similar manner. Like, I'll read you. 1970, what was the population in city A? Similar was for city B, 1930. Similar population was there for city C in 1925. Similar was the population for city D in 1935. And similar was the population for city D in 1920. So what they will do is, the curve for every other is given to you. Okay, based on those, what you will do, you know the population for 1980, what will be the population, that will be the same population for city B in 1940, 1935 for city C and so on. So you will add the population for those cities, divided by 4 because you have taken 4 cities, and you will plot it. Then you will plot it. Then you will plot it. So this is simple. Okay, simple but yet logical. Why? Because it is not based upon the experience of the designer that he can extend. This is purely logical. Why? Because you have selected those cities which have developed in the similar manner as compared to the city for which you are forecasting the population. So this is because you are doing a comparison. This is known as comparative graphical method. Clear, everybody? Last method, second last method, not last. This is the master plan method or zoning method. Master plan zoning method. If you are living in a, let us suppose, a municipal corporation area, Nagar Nigam which we call it, you just type it in Google, the zone plan of your city, you will get it. Remember, have you guys ever repeat what, Sashi? Have you guys ever thought or you have read it in the papers, सरकारी जमीन पर कब्जा करके लोगों को लूटा? Basically what they have done, they have taken the government land and these contractors and all sold that land. You guys have read it. Okay, you guys have read that. So basically what is happening, and the question comes, why they know that it was a government building or government, you can say that land, because when the city was being constructed, it was said that this is railways property, this is state government's property and so on. Okay, so that is the master plan of that city. So let us suppose if it is saying that this area is residential area, this area is industrial area, this is commercial area or any other area. So mention that densities also. Like if let us suppose like 50 kilometers square area is there. Okay. So let us suppose 100 people are required per kilometer. If 100 people are there per kilometer square, and let us suppose 50 kilometer square area is there. So how much people will be there? 5,000. Similarly, industrial area, it is telling you, let us suppose 20 people are there per kilometer square and 100 kilometer square area is there. So how much people will be there here? 2000. So in this manner, you will add all of them and you will get how much is the population there. So this is also the method. Okay. Simple graphical method is beta. If let us suppose you know last population of 1981. So you extended this curve. Okay. Now from 2011 you want to get the population. So you have drawn a line perpendicular, or basically first parallel to y-axis. It will touch the graph at a certain point. From this point, draw a line parallel to x-axis. The place at which it touches the y-axis, you will get the population. Clear? So from here, you will get the population of 2011. Last method, logistic curve method. Remember, this method you will able to apply only when T2 is twice of T1. All calculations are done from the base year. Now you will tell me, already told you, 1990, 2010, 2050. Can you apply logistic curve method here? Can you apply logistic curve method here? Yes or no? Fast. I want the answer fast. Fast, fast. Arun, everybody. Alek. No, you cannot. I told you all calculations are done from the base year. 1990 is the base year. What you guys thought, let me tell you. 1990 to 2010, it is 20. And from 2010 to 2050, it is 40. 2010 to 2020, 30, 40, 50. So you thought we can apply. No. Why? I'll tell you. Because 1990 to 2010, it is 20. 1990 to 2050. How many decades? How many decades? 2000, 2010, 2020, 30, 40, 50. 2 decades. This is 6 decades. Can you apply? T2 is not equal to 2T1. All calculations are done from the base year. I'll write it also so that you don't. I just shout and shout, but again you do the same mistake. All calculations are done from base year. Okay, now tell me this one, 1990, 2010, 2030. Now tell me, Tiksha, everybody, Sashi, can I apply? Yes or no? Yes. Why? Because 1990 to 2010, 2 decades, 1990 to 2030, 4 decades. So you can see T2 is twice of T1. So yes, here you can apply logistic curve method. Okay. Generally, when you see the variation of population with respect to time, you get a S curve. Like you can see it here. It appears like S. So you call it as logistic curve. You call it as autocatalytic curve. You call it as S curve. Now, you know this word saturated. I'm done. I'm saturated. This is over. So I'm saturated. Similarly, when the city has reached to its maximum, now more than that, it cannot accommodate. So that is the saturation population. That is the saturation population. Let us suppose at T0 the population was P0. At T1 the population is P1 and at T2 the population is P2. Now you want to calculate, let us suppose at P, at any basically at any time T, what will be the population P. So we will go by logistic curve method. Now this method is generally asked in your ESE conventional. This is purely formula based. They can ask you in GATE examination for 1 mark to check out whether you know the formula or not. Okay, so this is the formula for this. First, you need to calculate the saturation population, which is 2 P0 P1 P2 minus P1 square P0 plus P2 P naught P2 minus P1 square. I know this is tough, but do 2-3 questions, you'll remember this. At T is equal to 0, P is equal to P naught. At T is equal to T1, P is equal to P1. At T is equal to T2, P is equal to P2. Okay, so this you should not remember. This you can apply only when T2 is twice of T1. So for this, in 1 marks, they can ask you what is the saturation population. If they want you to predict the population, forecast the population, so it is P is equal to PS 1 plus M e to the power nt. Okay, and M and N, again formula you need to know. M is PS minus P naught, the population of the base year. Okay, remember this you can do it in any manner. N value you can do it for log base 10, just multiply 2.3, or if you want natural log, you can do it like this. But when you substitute T1, beta, always from base year. Always from base year. Otherwise, your whole calculation will be gone. Okay. This formula, with the help of it, you can calculate the population. This is an important one. This is an important one. Okay. So, this completes your first water demand. Any doubt? Any doubt? Guys, so many people right now I saw and so less likes. Not fair. Not at all fair. You guys becoming miser nowadays. Okay. Clear everybody? Okay. So now, ready for the next chapter? Ready? Important chapter. Schedule once again shown to you, and guys, tomorrow you will be having the geotechnical marathon by Abhinav sir, 10 a.m. tomorrow. Complete soil and foundation link has already been given. You can set a reminder. Okay, so problem on last method. Problem on last method if you want. Fine, I'll do it. Well, it was not given because it's just a calculation method, but if you want, I will give you. Just wait a second. Huh? Basically, they can ask you to calculate saturation population and all only. Okay, they can ask you to calculate saturation population and all. Have it. I'll give you from here. Population of a city in 3 consecutive years. 3 consecutive years, that is 1991, 2001 and 2011. The population is given to you as 80,000, 2,50,000 and 4,80,000. Okay, and it is asking you first to calculate the saturation population. First, it is asking you to calculate the saturation population. If such question comes, first you have to check it whether logistic curve is applied or not. Check it out. From here to here it is 1 decade. From here to here it is 2 decades. Yes, you can apply it. Use the formula, calculate the saturation population. Five minutes break. Let us do Roshit quality of water, then a break. Previous year question has not been asked from this topic. Come on guys. This is P0. This is P1. This is P2. You have to calculate saturation population. No. Not on GATE. So you guys can solve it. In GATE they have not asked. In ESE conventional and all questions has been there from this topic. Solve it. I know it is. It takes time. So better take out the zeros to be common. Well, I have the answer for this one. The saturation population comes out to be 655,602. So just check it out. Huh? Just check it out. So they can ask you in 1 marks these questions. Okay. So guys, first we will do quality of water, then a break if you guys want. Otherwise, I thought of having it at 2 o'clock. Okay. So fine. So now talking about quality of water. When you talk about quality of water, the aim of quality of water is to add desirable quality if it is not there. See, certain minerals are required by your body, but if it is not there, it is added. But if certain minerals are there more than which is required by your body, that has to be taken out. Okay, so add desirable quality and to remove undesirable quality. This is the function, this is the aim of the quality of water. Fine. Now, the question comes, there are three parameters: physical parameters, chemical parameters, biological parameters. Now, today I'll be showing you experiments also, the things which we can do it. Now, when you talk about parameters and physical parameters, physical is something which you can touch, feel, and see. Now, when you talk about suspended solids, the suspended solids, if you talk about the source can be organic. Generally, we say organic, organic vegetables are coming nowadays. Or like we say, if you have the standard people, no, I don't take normal sugar, I take organic sugar, I prefer organic rice, those kind of people. So, organic is where you get carbon in that. Okay, and organic particles are there, or inorganic like sand silts are there. Okay, now let's do it. I have a glass of water with me right now. Okay, for showing it I have taken a glass and I have some, is it visible or not? Okay, actually in my phone it is going 2 minutes slow, so I need to, fine. Now I can show you in the camera. I guess you can see some sand silts particles are there. So I will pour this now. Let me stir it also now. So a water, initially it was a clear water. Okay. Now this is the water. Will you drink this water, guys? Will you have this water? Come on, Arun, Spike, everybody. Will you have it? Handshake. Yeah. Why? If I would have told you that this is Jaljeera, then you guys would have it. Suspended solids. Organic, source is organic and inorganic. Now tell me the impact. The first impact which came right now is psychological impact. The moment you saw it, you felt, I can't have it. Disgusting. This is psychological impact. Okay, so this is because it doesn't look good. We say in Hindi, दिखने में अच्छा नहीं है तो हम नहीं पी रहे. The thing which doesn't looks good, we have that perception that it won't be good. Okay, so this is because it is aesthetically displeasing or unpleasing to our eyes. So we won't drink this. Okay, I'll use this for turbidity also. Wait. Okay, so this is for suspended solids. Now, what happened? What happened in this organic and inorganic are there? Now comes the question. In this, what was happening? If you see, some solids are dissolved. You can see the color. I'm putting it in front of camera. You can see some solids have settled down, which you guys won't be able to see, I guess. If you can see, the solids have settled down also. Okay, and some solids are dissolved also, which you can see it here. Okay, so that suspended solids, or basically first the total solids can be suspended or it can be dissolved. So the total solids which you have, the total solids, it is suspended and dissolved solids. Now, for this gate examination question has been asked. In gate examination, question has been asked from this topic. So let's talk about it. I'll tell you the whole procedure. You have to solve the question. Okay. Now, total solids, suspended solid, dissolved solids. In gate examination, never ever they mention what is total solids, what is suspended solids. They will tell you the procedure and they will ask you based on your knowledge what is total solids and what is suspended solids or what is dissolved solids. So it is very, very important that you should know the procedure. Now, remember, total solids. If you want to calculate total solids, no need of any brain. In this, suspended solids will be there, dissolved solids will be there. Settleable solids I will talk about in the case of Jalapati, in the case of wastewater, sewage. Because that time I'll be telling you about the hem of cone also. Okay, right now we'll talk about suspended and dissolved only. Fine. So this is the total solids. You will do what? You will take this, heat it at 104 degrees Celsius for 24 hours. Directly just measure the weight. So the technique by which you calculate the solids weights and all, this is graviometric technique. Graviometric because you are measuring the weight. Okay. So 104 degrees Celsius for 24 hours. This will give you, you can calculate the weight. And let us suppose if I took 1 liter of the sample. So total solids weight will be in mg and the concentration will be mg per liter. Remember, why I am telling you? Because in the question they will directly tell you that the sample was there, it is heated. If it is telling you, remember it is talking about the total solids. Now, next what they can do is, if they are telling you that the solids were there or basically the sample was there, it is pour it through the filter paper. Okay, and then if it is pour it through the filter paper, the suspended solids will retain, the dissolved solids will go. So these suspended solids will again be heated for 104 degrees Celsius for 24 hours and then we will measure the weight if it comes out to be x mg. So you will say the concentration of suspended solids will be x mg per liter because the sample was 1 liter. Okay. Similarly, dissolved solids have pour out from the filter paper. So you will measure the weight and you will say this is, let us suppose if Ymg is there. So Ymg per liter. Again, you will heat it at 104 degrees Celsius for 24 hours and from here you will get dissolved solids. So ma'am, how come we will know that whether it is suspended or dissolved? In the question it will mention you. It will not mention you this is suspended or dissolved, but it will mention you the procedure that it is poured through a filter paper or basically it is heated, the sample is directly heated and all. So with the help of that you will get whether it is total solids, suspended solids or dissolved solids. Clear? Now, the next thing which comes is in the suspended solids. In the suspended solids, there is another category if you know. Let me tell you. Total solids, there is organic solids and inorganic solids. Shall I go in the detail? Yes or no? If you want, I will go. I'll add an extra slide. If you want, I'll go. Otherwise, I won't. That's why I'm asking you. Okay, fine. Because they can ask you and they have asked questions from it, Diksha. That's why I have to go it actually. So, total solids, they have asked question actually from this in your gate examination. It is an organic and inorganic. Okay, that means suspended solids can be inorganic, organic, dissolved solids can be inorganic and organic. Remember, organic solids, it's not necessary in the question. The best way to complete E in one day is to follow Richa Gupta's Maha Marathon. Okay, so organic solids is also known as volatile solids. Remember, no, not necessary. They will ask you what is the organic solids. Inorganic solids, they write it as fixed solids. or they write it as non-volatile solids. All the name you should remember, otherwise you will get confused in the examination. Okay? Now, listen to me very carefully. Let us suppose if total solids is there, it can be organic, means there can be carbon present in it. It can be inorganic also. So there is, again, this is 1 marks question. There is a special furnace known as muffled furnace. Now, what is the speciality? In this, you supply high heat of 600 to 650 degrees Celsius. So you take the total solids, which you have done what? You have taken here, you have measured the total solids. You will take this, okay? You will place it in a muffled furnace for 600 to 650 degrees Celsius temperature for 1 to 3 hours. What will happen? The organic solids has the tendency to vaporize. So they will vaporize. The things which will remain will be the non-volatile solids or the inorganic solids. So total solids is equal to this. They can ask you, remember, organic total solids plus inorganic total solids. So what will happen? Total solids value you already calculated. Organic has been what? Vaporized. Inorganic will remain here. So you will measure the weight of inorganic. Total solids you know. So with this you will get organic total solids. This will be total solids minus inorganic total solids. Because such question has asked been in your GATE examination. They write non-volatile, volatile, sometimes they write the fixed solids concentration. That is the reason you should know this. Okay. So total solids, organic total solids. Inorganic already mentioned. Now organic total solids is organic suspended solids or it can be organic dissolved solids. So what you can do is, you can take the suspended solids which you have measured, put it in a muffled furnace. So again what you will get? Suspended solids you already know. Inorganic suspended solids will settle. Similar procedure, not to repeat again and again. Inorganic suspended solids will settle. You will get organic suspended solids. Simple. Suspended solids minus inorganic. So from here you will get organic. From here you will get organic dissolved solids. As simple as that. Okay. So in such manner you can get organic suspended solids, inorganic suspended solids, organic dissolved solids, inorganic dissolved solids. Is it clear? Clear everybody? So this is the whole procedure. Tell me Vishal, everybody, Gargi, Girish, everybody clear? This I'll write it in box or mark it in box. Okay. Now, talking about turbidity. Okay. Now, let me tell you few things first. In the code, there is no limit mentioned for suspended solids. No limit mentioned for suspended solids. Limit has been mentioned for dissolved solids. Okay, limit has been mentioned for dissolved solids. No limit has been mentioned for suspended solids. Firstly. Secondly, if I talk about turbidity, turbidity is also, you can say, the more amount of suspended solids, the more amount of turbidity. But remember, you cannot measure turbidity by gravimetric technique because there are two things that you should know. I won't repeat it again, so I'm telling you in detail right now. Qualitative and quantitative. Okay, more the suspended solids, more the turbidity. But if 10 mg per liter is the suspended solids, 10 mg per liter will be the turbidity? No. Okay, amount you cannot say. Quantitative analysis you cannot do. Qualitative, it is true that more the suspended solids, more the turbidity. Okay, now turbidity means what? Now let's understand it with the help of an experiment. Again, I have done it in Sandeka Funda also. Okay, this is the glass. I guess you can see it. I have to check it myself. Could you read it? What is written? Oh, bigger one. I take it. Okay, this is the glass. Can you see what is there behind it? I don't know in the camera which is. I think you should read it because I'll be able to read. Can you guys can see it? Can you mention in the comment what is written? Actually, you should. And there's problem right now. Oh my god, what is that? दिख रहा है. Okay, fine. You can see it basically it's written art line, but I can see it clearly, but because of the lights you cannot right now. Okay, otherwise we can see it clearly. Now what is happening? Now somewhat you can see, but if I'm taking a sample which has suspended solids in this and I'm taking it, can you see anything? Can you see anything? Yes or no? You cannot see anything at all. This is turbidity. It is basically what is at अभी नहीं दिख रहा. अब तो और नहीं दिख रहा basically. You cannot see it. So what is happening? Turbidity is the extent to which light is either scattered or reflected. So in this water, at least you were able to see that something was written. But when I took this water, which has suspended solids in it also, then you cannot see anything. Why? Because the light was not able to reach to you. So this was turbidity. Understood with the example? Something seen before but now nothing. Yeah, that's what is turbidity. That is what is turbidity. Clear? Clear? I was not talking about the soil particle. That was soil particles. Turbidity was there. If you see it here, the turbidity I created. Here I created the turbidity. Okay? Anything you cannot see. Fine. So now turbidity is the extent to which light is either scattered or absorbed by the water sample. Now, turbidity, I say it is due to what? It is due to suspended solids. So, all the impacts, everything of suspended solids is the same. But there are few things which you need to know regarding the measurement. One thing, first measurement is by turbidity rod. This is a field method. Again, a question for 1 marks. Field method is only turbidity rod. Now, you can see it here is, this is a rod. Okay, there is a platinum needle. In your state level examinations, you know, they ask you this basic terms. The needle which is of turbidity rod made of platinum, aluminum, nickel, such sort of things, but not in GATE. Till now, if they want, they can ask you in MSQ statement wise questions. So platinum needle which is given, you can see it 1 mm diameter, 25 mm long, and this is the nickel ring. What you will do? Inside there will be a needle. You will insert it in the field water, you can see the needle. Insert it, you can see the needle. The moment when you are dipping it deep and the moment when you are unable to see this needle, stop that, measure the reading. Okay, let us suppose this will be the reading. So here it will be 10 mg per liter. Now you will say, ma'am, we directly got the turbidity, right? I'll say right. But you would say, ma'am, this rod should give me the height. But this is giving me the turbidity. How come? Means any magic is there or what? So what is happening is there is a calibration done. Calibration means when you relate two unknown parameters. I measured the height, but I got the turbidity. So ma'am, how come you did this calibration? Initially, this was a simple rod. What I did, I myself created turbidity and inserted the rod. And the moment I saw, okay, for this turbidity, this one will be the reading. For this turbidity. Second question, ma'am, how you created that turbidity? Let us suppose if I add 5 milligram of silica in the form of silica dioxide in 1 liter of pure water or distilled water, I call it as 5 STU. STU stands for silica turbidity unit. So in this manner, since right now also you can see I created the turbidity. So I poured silica, I made the turbidity, let us suppose for 5 TCU, 5 mg per liter, the depth comes out to be 11 centimeter. So when 11 mm. So when 11 mm will be the depth, the turbidity will be 5 mg per liter. So in this manner, what I did is I created the turbidity. Similar you can do by, there is another method, that is Jackson's turbidity method. Simple. There will be same method is there. There will be a measuring glass will be there and all, and there will be a candle flame. Again, you will pour the water. You can see the flame of the candle. You will pour the water. You will see the flame of the candle. The moment the flame of the candle you cannot see is, you will note the reading. Here also you can get the unit as JTU, Jackson's turbidity unit, and STU, silica turbidity unit. If they have written in the question STU, JTU, mg per liter, ppm, and they'll ask you which of the following is correct, appropriate, you will write STU. Technically, for writing purpose, everything means same. Okay, but we take STU. Why? Because the principle involved is of silica. Clear? Moreover, we don't use Jackson's turbidity meter because it gives turbidity more than 25 units. Okay, and turbidity of about 5 units, we can see it by naked eye only. So you can use it for large water bodies, but for drinking water, we don't use Jackson's turbidity meter. Okay, now talking about Bailey's turbidity meter. Bailey's turbidity meter is based on, initially it is based on color matching technique. Color matching technique. So what do you see it here? Generally there is a blue cobalt glass plate which is attached first, and there is a two test tubes. Okay, two test tubes which you can see it here. You can see it in this perspective view also. So what you will see that basically there will be a test sample and there will be a standard sample. Standard sample is that sample which you have prepared. Okay, and test sample is that sample where you need to find turbidity. So what you did was, you opened, basically switched on the electric bulb. There is blue cobalt glass plate. The light will reflect and it will reach to your eyes. If you see in both the samples, you get the same colors, same intensity of light scattered, you will say the turbidity is same of test sample as that of standard sample. If it is not, what you have to do? You have to change the standard sample. But this method we generally don't use it because you don't have that super eyes, divya shakti wali aankhein nahi hai aapke paas. Like if it is 3.8 mg per liter of the test sample and standard sample it is 4 mg per liter, for you will you be able to detect it? No. For you it comes out to be the same. Or if the test sample it is 4.2 mg per liter also, then also you will say that it is 4 mg per liter. So what happens? You cannot predict accurately. So that's why we go for nephelometers, and nephelometers are based on current matching technique. Nephelometers are based on, I'll write it here, spaces then first. Nephelometers are based on current matching technique. Now let me tell you, this is very important. First of all, nowadays if you go it in the experiments and all, you will see nephelometers only. Photometers. Photometers is a semiconductor device. As soon as light is incident on this photometer, it produces current. So as soon as the light is incident on it, photometers will produce the current. So now what happens? There is a test sample and there is a standard sample. So what you do, when Bailey's turbidity meter was there, you place the photometer behind it and this bulb was there. So what used to be there, when you scatter, this light comes, a part of it used to get scattered and a part of it used to get absorbed. Okay, so that's why again a question asks, Bailey's turbidity meter is based on absorption principle. Similarly, nephelometers, again photometers was there. But ma'am, how you measured the turbidity? See, when the light got struck in this photometer, current was produced. If the current in standard sample and test sample is same, then whatsoever is the turbidity of standard sample, that will be the turbidity of test sample. Okay. Secondly, if it was the case of nephelometers, you place them at 90 degrees. So what does nephelometers do? It measures the current which is incident on it at 90 degrees. So nephelometers measure the scattered light. So nephelometers is based on scattering principle. Oh my god, it is gone out. Something is touched by my... No. It is based on scattering principle. And Bailey's turbidity is based on absorption principle. Now, one thing asked in your gate examination, that is NTU and FTU. NTU means nephelometer turbidity unit. FTU means formazine turbidity unit. If they give you 1 mg per liter, 1 ppm, 1 NTU, 1 FTU. This was asked in GATE, asked in your polytechnic lecture, AE, ESC, every examination they have asked you. FTU will be the correct answer. Ma'am, but all are equal? Yes, beta. But when you basically make standard sample in the case of nephelometers, you don't use silica dioxide. You use formazine. Ma'am, why we used formazine? Because it gives better results as compared to silica dioxide. So when you add 1 milligram of formazine in 1 liter of water, you will get 1 FTU. If you add 5 milligram of formazine in 1 liter of pure water, you will get 5 FTU. So FTU will be the correct answer. Nephelometers. Prashant, what I did for the case of nephelometers, I placed the photometers at 90 degree. So when the light came, it scattered. Okay, and this scattered light was incident on the photometers. So photometers current was produced due to the scattered light. So if the current in standard sample and test sample is the same, you will say that standard sample and test sample both have the same turbidity. Okay, clear? STU and FTU both are given. STU, no, STU is different. STU is silica turbidity unit. If you want to compare MJ, this was the question which was asked in GATE examination. And maximum students wrote NTU. Why? Because as per the codal provisions, they have given NTU as the limits. But if they ask you the appropriate one, you will write FTU. Okay, if STU and FTU both are given, they can't give it. Why? Because for comparison, you need a common parameter, right? Okay. So this was, any doubts till here? Any doubts, Prashant? Clear? Any doubts, anybody? So nephelometers, right now we use it. And if you talk about two limits are also there in this. One is acceptable limit. Another one is cause for rejection limit. Why only 90 degrees? Because it has been like this only for nephelometers. You can arrange it at any other degree also which you want. Yes, correct, Vishal. Correct. Okay. What is the acceptable limit and cause for rejection limit? Just tell me. 1 NTU, 5 NTU? Is it? So remember, if it calls for rejection limit when there is no alternate source available, then we go for cause for rejection limit. And it doesn't mean it should be 5 NTU. This is the wrong concept asked in interview questions also. It means up to 5 NTU. It can be 2, it can be 3, it can be 4. Up to 5 NTU it is talking about. Okay, so this you should know. Okay, now talking about color. Okay, fine. So let's make it exciting. Pure water. You can see it? Come on, guys. So don't see what I'm adding. Don't see. Close your eyes. Let's make it colorful. In exam, FTU is more preferable. Yes, it is more preferable because the principle involved in this is it has more density. So guys, this is standard ruabza with fruit pulp and all in it. Will you drink it? Don't see what I have added. Colorful. Come on. Diksha, everybody, Girish, Prashant. Mango pulp and all is also there. Strawberry pulp. Strawberry pulp. Blood. This is my equipment which I have added. No, right? Why? If it had been क्या mix किया है? This is my secret recipe. Arun? Suspended particles, that is pulp. That is pulp. Fruit pulp. Secret recipe. Will you eat? Drink, basically, no. Ink juice. Ah, so this is color. If I would have been given you any soft drinks, you would have taken it. Why? Because you already have tasted it. You might taste this also. See, this I did in front of you. If I wouldn't, you would have tasted it once and you would have spitted it out. Okay. So what happens is that Diksha, when you make cocktails and mocktails, it also looks like same color, blue lagoon and all those things. Huh? So what happens is color is basically due to dissolved solids. There are two types of color. One is true color and one is the apparent color. True color is due to dissolved solids, while apparent color is due to total solids. Can you tell me whether it is true color or apparent color? Can you tell me whether this is true color or apparent color? True color, apparent color. You can see it and tell me fast. True color, apparent color. Apparent color. Why? Because your suspended solids are also there. Okay? Suspended solids are also there. So this you should know. Now, if you talk about it, basically color we measure the unit of it comes out to be true color unit. What you do, you take a test sample and you take a standard sample. This is not total solids and dissolved solids. This is test sample and this is standard sample. What you do, standard sample is something which you make it. If you put, let us suppose 5 mg of platinum in the form of chloroplatinate ion. Chloro, it has so strong smell now. Oh my god, this ink. In 1 liter of distilled water. In 1 liter of distilled water, you will call it as 5 TCU. So this sample you made it, so you know it. If the color produced in both the sample is same, you will say test sample also has the color of 5 TCU. Generally, this gives only yellow color. So, but colors can be any other. So, there is advanced technique known as spectrophotometer technique for the measurement of color. Okay, acceptable limit is 5 TCU. Up to 5 TCU color is permitted. Cause for rejection value is 25 TCU. Generally, the color and all, you can see that yellowish tincture specifically during rainy season. You guys would have seen that yellowish tincture and all color. So that is also permissible up to 5 TCU. Okay, that is also permissible up to 5 TCU. Now coming up further, we have taste and odor. This question has been asked in your examination regarding taste and odor. So when you want to measure taste and odor, why we take it, these two are different parameters. These two are different physical parameters. Okay, is it measured by tintometers and Nessler tubes? As per 105002012, I am talking. Is it? Yeah. Yes. Who is there? Is TCU equal to? No, we don't take equal to ppm. We don't take equal to ppm. And what else was that there? Yeah. So tintometers, where it has gone? Press something, it is gone. Standard sample. These tubes are known as Nessler tubes. And this equipment is known as tintometers. Okay. Now, when you talk about taste and odor, the measurement of taste and odor, if you talk about, this is done by osmoscope. The measurement is done by osmoscope. There is an equipment like this. Okay. And there is a place to insert your nose. Now, what happens in this? What happens in this is, as per the code, A plus B is mentioned as 200 ml. Now, you will say, ma'am, what is A, what is B? A is the raw water sample. B is the sample when what you will do, you will add distilled water. You keep on adding till the time you see that no smell is there. So A plus B divided by A, this will give you threshold odor number. TON stands for threshold odor number. Now what happens is, not what happens is, in this case you take 10 sets of noses. 10 sets of noses means you will take 10 people who will smell it. If any one of the 10 people say that smell is there, you will add more water. But you have to take it in such a manner that A plus B has to be 200. Let us suppose initially A is 10 ml, B is 190 ml. So the dilution factor which we call, it comes out to be 200 by 10, 20. Because dilution factor is A plus B by A. But still one of the person like Ayan said that ma'am smell is still coming. So what I will take? I will take 5 ml as the raw water sample and I will take 195 ml as the water. Then I will say that 20 people again, 10 people will again come and they will smell it. So what will happen? If again nobody said that any smell is coming, so I will say 40 is the dilution factor and I will do the treatment based on this. Okay, so osmoscope is used and 10 sets of noses are taken for checking it if any smell is there or not. Okay, and A is the volume of raw water, B is the volume of distilled water. Clear? Now, last, temperature. Temperature is basically very simple. It affects taste and odor. If you talk about the limits, initially it was 1 TON and 3 TON cause for rejection limit. Now, if you take the code, they have written it there acceptable. Okay, that means basically they have written acceptable, or you can say they have written it there agreeable. So that one which agreeable means basically they don't allow any taste and odor in the water. Okay, now when you talk about temperature, obviously you can feel it and you can see it affects the chemical and biological activity. If 10 degrees Celsius you increase the temperature, almost the biological activity will double it. 1 TON, 3 TON was there, Ashish, but if you check it now, they have written it agreeable there. Okay, so this you have to check it out. Now, talking about chemical water quality parameters, chemical dissolved solids is there. Dissolved solids, already I told you the measurement technique in suspended solids. But there is one more method, that is an approximate method. What you do? Let us suppose, you know what is cathode and anode? You know cathode and anode? Guys, cathode is positive or negative? Positive electrode. Anode is negative electrode. Yes or no? And you have ions present here. Cations, positively charged ions. Anions, negatively charged ions. So now what will happen? When you put this water here and when you measure the electrical conductivity, the positive opposites attract. So the positive charge ions which are present in the water. Remember, pure water is a bad conductor of electricity. But if in that water ions are there, if you take distilled water, it will not conduct electricity because it is just 2 moles of hydrogen, 1 mole of oxygen. Cations, positive charge, will go and deposit on the anode, negatively charged electrode. Anions will go and deposit on the positively charged electrode. That is cathode. When they will go, the movement will be recorded. The movement will be there, due to which current will be produced. Okay, ammeter will be there. So current will be produced. You will measure that current. Okay, and that current is further calibrated to total dissolved solids. So that's the reason total dissolved solids is equal to electrical conductivity in micromole per centimeter at 25 degrees Celsius. Ma'am, why it is necessary to measure the temperature? Because the conductivity changes. Dissolved solids will remain same, but the conductivity changes as the temperature changes. And that's why a factor known as 0.65 is also introduced. But this is an approximate method. Reason. Pure water is exactly pH 7. Yes. Or you can say 2 moles of hydrogen, 1 moles of oxygen. But it is an approximate method. Why? Because all dissolved solids are not ions. All ions are dissolved solids, but all dissolved solids are not ions. And this will give me only the ions concentration technically. That's the reason this is an approximate method. Any doubt till here? You can measure it. Any doubt till here, guys? Faster, faster. Any doubt? Shall I increase the speed little? Arun, Vishal, everybody. Okay, fine. No doubt. Okay. So, let's talk about pH. pH is the scale approximately analysis. I already told you. If you want to measure the exact one, then I already told you take the sample which is poured through the filter paper. That sample 104 degrees Celsius, you will get the exact value. This is the approximate one. But they can ask you, that is the reason. Speed, okay. I was asking to increase a little if you guys permit. So pH is the scale of pH is there, so that is minus log base 10 H plus. Remember, this H plus is in moles per liter. Very, very important. मैं करा दूंगी पंकज. Okay, this is the pH. Now talking about pOH, this is the basic formulas is only needed in this. OH minus ion. Okay, and this also, this is the only thing which you need to know, that the concentration here is in moles per liter. Now pH plus pOH is equal to 40. H plus into OH minus is equal to 10 raised to power minus 40. Now gate question was being asked. I'll tell you. If they say in the question there is linear variation in the pH at t is equal to 0, let us suppose a pH was given to you at t is equal to 24. Very important, guys, listen to it very carefully. pH is given to you and it is telling you linear variation of pH is there. What you have to do? Just add both of them. If it is in the question, it is written linear variation of pH is there. But if in the question it is telling you linear variation in the hydrogen ion concentration or H plus ion concentration is there, don't go by this method. No, it will be wrong. What you have to do in that case, is first at t is equal to 0, you have to measure H plus ion concentration. At t is equal to 24 hours, you have to measure H plus ion concentration. Then you will calculate the H mean, H plus at 0 hour, H plus at 24 hours divided by 2, and then you will measure pH. So that's the reason, understands the wording. अच्छे से समझाइए. हाँ, वो अच्छे से समझा दूंगी पंकज. मेरी गंदी अरुण, ये बोल रहे हो? So pH is this manner you have to calculate. Okay, H plus is when it is telling linear variation in H plus, go by this method. If it is telling you linear variation in pH, go by this method. Okay, this you should know. Very, very, very important. Okay, now one question is there. I'll mark it for you guys. One question is there which I'll mark it for you guys. You guys should do it. This is a very good question and this is of your gate question. Okay, I have it. This question was there. Wastewater sample simple data, I'll write it. You guys will have it. 2008 IISc Bangalore question. 5.6 millimoles per liter is there. It is asking you the pH. Calculate. मैं एक ही स्पीड से पढ़ाती हूँ क्योंकि एक ही स्पीड से अच्छा लगता है सबको. बोलोगे तो बढ़ा कम कर दूंगी. Okay, pH. Now in this question, guys, 10 minus 5.6, first of all millimole is written, so you have to take it as moles per liter. So this will be 10 raised to power minus 8.6 moles per liter. This is the concentration. It is asking you pH. How you will calculate? In the option it is given me 8.6, 8.4, 5.6, 5.4. It is asking me pH. Calculate pH, and it is given me what? A water sample. This is OH minus ion concentration. Solve it. OH minus ion concentration is given to me. How can you do? OH minus first you will calculate POH. That will come out to be how much? 8.6. pH plus POH is equal to 14. So it will come out to be how much? pH will come out to be 14 minus 8.6. It will come out to be how much? 5.4. As simple. One last question. This is a very important question. Guys, when you go, just prepare this question and go. Water sample pH is given to you as 9.25 and it is asking you OH minus ion concentration. Options I'll give you. This is a good question. 10 raised to power minus 2.5, 9.25 moles per liter. B is 10 raised to power minus 4.75. C is 0.302 mg per liter. And D is 3.020 mg per liter. Come on guys. Solve this. Good question. Solve this. Thank you so much, Prateek sir. Come on, guys. This you should know. pH is given to you 9.25. pH is given to you 9.25. If you need OH minus ion, what will happen? I'll take other color pen. This is an important one. This will clear your concept of molarity. No, wrong. Everybody giving the wrong answer, guys. Wrong answer. Wrong. See, nobody gave the right answer. Come on, Arun, Sagar, everybody give me the correct answer. Now see this question. First, let me calculate POH. pH plus POH is equal to 14. So what will be POH? That will be 14 minus 9.25. How much it will come? 14 minus 9.25. 4.75. Guys, if you check it out, it is written millimoles is written. So technically, you know what it is written? 10 raised to power minus 4.75 into 10 raised to power minus 3. So it is written moles per liter. This is written in the question. So is it coming? No. It is not coming. This is the POH, and if you mention minus log base 10 OH minus ion, this is practice this question before you go for the gate examination. This has already been asked. No option like this is being given in the question. So just check it out. Unit 3 दिख रहा था. Millimoles per liter. तो ये भी गलत. This is wrong. This is wrong. Now comes the next one. Just check it out. You know that molarity means number of moles per liter. Okay, so number of moles means given weight upon molecular weight, liters. So if I multiply with the molecular weight of OH is oxygen 16 and H plus is 17. Okay, this will come out to be in gram per liter. For getting it in milligram, I will multiply by 10 raised to power 3. What you will get? 0.302 mg per liter. So option C will be the right answer. Clear? Those who were telling the wrong answer, Prashant MVS was telling it correct. Clear? So this question, practice it and go. Clear, Tiksha? Okay. So these are the questions regarding pH which you need to know. 17 को रट्टा मार ले. 17 को रट्टा मार ले. अच्छा. Beware of trap. Correct आया. Okay. So now coming to alkalinity. Now what is alkalinity? Alkalinity is basically, we say there are certain ions which are present in the water which neutralizes the H plus ions. Okay, or you can say H plus ions means what? These are the acids. So in water, there should be some other elements which should be present, which should neutralize acids. Now, if the carbonate ions are present and it neutralizes acids, so alkalinity due to carbonate ion is known as carbonate alkalinity. Alkalinity due to bicarbonate ion is known as bicarbonate alkalinity. Alkalinity due to caustic ion is known as hydroxyl or caustic alkalinity. Okay, there are more alkalinity also like HPO4 2 minus, H2PO4 minus, biborate ions, sulfide ions, and number of ions are there. Remember, very, very important thing I am telling you. If in the question, wait, I'll explain you molarity, normality, Prashant Pranu, I'll explain you right after this. If in the question, it is not telling you to take the minor alkalinity, don't take it. Don't take it until and unless mentioned. If they have mentioned in the question and they're telling you neglect the effect of it, neglect it. But if they haven't mentioned anything, then you have to consider it. This happened in the case of hardness. Maximum students did it wrong. That's what I'm telling you. If any other alkalinity is mentioned you in the question and it has not written anywhere, neglect the effect of it. You have to consider it. Don't say that, ma'am, you told it is minor alkalinity. Of course it is minor. But if in the question it is asking you to consider it, you have to consider it. Okay, this. Now comes next. If you want to calculate alkalinity, generally it is due to bicarbonate, carbonate and OH minus ion. The best way is concentration, take it in mg per liter. Okay, take it in mg per liter. Equivalent weight of calcium carbonate divided by the equivalent weight. Now, I have to tell you few things before we move towards this. Now, everybody was telling me, let me tell you. First of all, let me tell you number of moles quickly. Number of moles, if you want to calculate, this is given weight by molecular weight. Molecular weight in the question, they will give you the atomic weight, so generally don't worry. Now, if you talk about another thing, that is molarity. Molarity, generally in the questions, you will see they will denote it by capital M. Molarity is number of moles present in 1 liter of the solution. So, I have done this only. Normality, if you talk about, before that you have to understand one thing, gram equivalents. Now what is gram equivalents? That is equal to given weight by equivalent weight. Now what is equivalent weight? Equivalent weight is molecular weight by valency. You guys know this, otherwise if you don't, then I'll deal it in slide detail. So equivalent weight is molecular weight by valency. Valency means combining power of an element. Example, if sodium chloride is there, sodium will give its 1 electron to achieve the octet. Chloride will take 1 electron to achieve its octet. So the valency of NaCl will come out to be 1. Similarly, remember, you don't need to mug up for everything. Only 3. Carbonate valency is 1. Bicarbonate valency is 1. Okay, carbonate valency is 2 and caustic valency is 1. So you don't need to remember for every other thing. Now, there is one concept which you need to know. It is not possible. See, when you add two things, if you want to add kg and milligram, or if you want to add rupees and dollars, either you have to convert dollars into rupees or rupees into dollar. So what happens is you have to make it in a common parameter. Similarly, if you want to add HCO3 minus, CO32 minus, OH minus, you cannot add it directly. So what we do, we take the help of calcium carbonate. Why? Because there is a funda, 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. So how many gram equivalents of HCO3 minus will be there? That much gram equivalents of calcium carbonate will be there. How many gram equivalents of CO32 minus will be there? That much gram equivalents of calcium carbonate will be there. So in this manner, what we do, we report every alkalinity in terms of calcium carbonate. Now you will say, ma'am, why calcium carbonate? Because its molecular weight is 100. It is easy to use. That's the only logic. So first we calculated the gram equivalents. So SCO3 minus divided by equivalent weight. This will give me the gram equivalents of SCO3 minus. Then I will multiply by the equivalent weight for getting the concentration of CaCO3 alkylate. That's very much simple. If you want, I can tell you gram equivalents, common sense. Gram equivalents of HCO3 minus is equal to gram equivalents of calcium carbonate. So what I did, I calculated the gram equivalents. This is the gram equivalents. This divided by this will give me the gram equivalents. So here, I don't want the gram equivalents of calcium carbonate. I want the concentration. So if I want the concentration, I just gram equivalents of HCO3 minus whatever I got. I multiplied with the equivalent weight of calcium carbonate for getting the concentration. That's simple as that. So how many gram equivalents was there? That much gram equivalents of calcium carbonate was there. But in the question, it doesn't ask me in gram equivalents of calcium carbonate. So I multiply with the equivalent weight of calcium carbonate. Clear? Understood? Prashant, Banod, understood molarity and everything? If not, tell me fast. Understood? If in the question any of the alkalinity is not given, don't consider it yourself. Take it as 0. Take it as 0. As simple as that. Okay. Now, acceptable limit and cause for rejection limit, if I talk about, this is also as calcium carbonate. As calcium carbonate. Now, अरुण हर्ट भी करते हो, प्यार भी करते हो, ये कैसा प्यार है बताओ तुम्हारा? Okay, just kidding. Acceptable limit up to 200 mg per liter, it is acceptable, and cause for rejection limit when there is no alternate source available up to 600 mg per liter is the cause for rejection limit. Okay, पोल दिखा रहा है, किस चीज का पोल दिख रहा है? ठीक है, so this is the cause for rejection limit. Okay, so this you should know, and let me talk about hardness, then we will deal the question simultaneously. Now, hardness is due to presence of multivalent cations. This is Sosham, like and like. पोल दिख रहा है? अच्छा, तुम लोग ने लाइक्स नहीं किया ना सेशन को, बताओ इतने सारे लोग बैठे हो 70 प्लस और उसके बाद भी तुम लोग ने सेशन को लाइक नहीं किया, इसलिए बोल रहे होंगे ऑपरेटर ने। अब तुम लोग नहीं कर रहे हो, कर दो। प्यार ही नहीं करते हो मेरे से, अब मैं क्या बोलूं? ठीक है, हार्डनेस की बात करती हूँ। मेरी तरफ से आ रहा है, आपकी तरफ से आ रहा है मैम? मैं तो कुछ भी नहीं कर रही हूँ यार, तो तुम लोग देखो। चलो, हार्डनेस क्या होता है? हार्डनेस क्या होता है कि हार्डनेस क्या होता है कि जब भी वी हैव टू टॉक इट इन इंग्लिश। तुम लोग हिंदी में कमेंट्स लिखते हो तो मैं हिंदी में बोलना चालू कर देती हूँ। हार्डनेस इज whenever multivalent cations is present. Multivalent means, cations means, remember this is very important, I'll tell you where you guys will make mistake. Cations means positively charged ions. Positively charged ions. Multivalent means valency more than 1. So those cations which have a valency more than 1, they will impart hardness. Firstly. Secondly, hardness is what? Hardness is whenever you say that the water is hard and when you rub the soap, it doesn't produce foam, rather than it produces precipitate. Okay, so you say hardness is what? It destroyed the ability of water to destroy the surfactant property of soap. This is a technical definition. Ability of water to destroy the surfactant property of soap. Surfactant property means, generally you know, the water when it should be rubbed with a soap, it should produce foam. But when it is not producing, it means that the water is hard. So ability of water to destroy the surfactant property of soap, that is known as hardness. And how hardness is caused? Hardness is caused due to the presence of multivalent cations, those positively charged ions whose valency is more than 1. That means you will say, ma'am, calcium, magnesium, aluminium, etc. all will impart hardness. Yes, everybody, but majorly basis calcium and magnesium. Again, this question has been asked in your gate. In the gate question, generally every time calcium, magnesium, you will give the test series, you get calcium and magnesium only. But in that year paper, aluminium was also given. And maximum students didn't consider it. Clear? But you have to consider it, although you know that the concentration is negligible. But if in the question it has not mentioned neglect the effect of it, you have to consider it. Okay, so that is the reason you have to consider it. Now there is a one term pseudo hardness. There is a term pseudo hardness. Technically, let me tell you, there is nothing like pseudo hardness. But what the generally in books what is written, I'll tell you. The elements which does not impart hardness, they impart pseudo hardness. Any common sense? Like sodium, potassium. Why? Although they are cations, but they are univalent because they have one valency. So those elements which does not impart hardness, they impart pseudo hardness. That's it. No other logic than that. Okay. So this you should know. Now in hardness also we have two types. One is what? Carbonate hardness. Another one is non-carbonate hardness. Carbonate hardness is known as temporary hardness. Why? Because by simple boiling or you add lime, they are being reduced. So simple boiling, no need to apply more brain. Simple boiling or by addition of lime, they are being removed. Okay. Now, if any carbonates, now this is the thing maximum students get confused. I'll tell you one thing, and this I'll explain you with the help of a numerical also, because I know whenever I ask this in offline and online, maximum students make mistakes. That's why I'm stretching this out. Remember, every time this should go in your head, hardness is always and always due to multivalent cations. If the suffix of it, calcium and magnesium are the one which will impart hardness. But if the suffix of it is bicarbonate or carbonate, then you will call it as carbonate hardness. But that doesn't mean that hardness is due to carbonate and bicarbonate. Never, never, never. Hardness is due to multivalent cation, that is calcium and magnesium. Clear? So this you should know. Now, if I talk about non-carbonate, and you can see it also. If you want, you can see it also. Calcium bicarbonate, heat it, you will get calcium carbonate, carbon dioxide, water. Calcium bicarbonate, you will put lime in this, calcium hydroxide, you will get calcium carbonate. So in this manner, either add lime. Okay, we have added here. It is slaked lime or quick lime, guys? Is it slaked lime or quick lime? Slaked or quick? Because in the examination, they won't give you calcium hydroxide, calcium oxide. Slaked or quick? Come on faster. This is slaked lime or quick lime? Calcium hydroxide. Slaked lime. So remember that. They won't give you in the question calcium hydroxide and calcium oxide. Okay. Fine. So now, talking about non-carbonate hardness. If chlorides, sulfates, nitrates are there, then you will call it non-carbonate hardness, or you call it as permanent hardness, because if you do boiling also or you add lime also, it won't be removed. So special techniques are being used, like zeolite method, demineralization methods are being used. Now let me tell you, actually why I'm telling you is because in the questions, this tabular format questions are there, they write like this: chlorides, sulfates, and HCO3 minus, let us suppose. They write calcium, magnesium. You won't believe what students do it. Let us suppose it is written mg per liter, concentration is there 0.5, and this is 8, this is 10. People say, let me tell you one thing, 0 to 5, 5 mg per liter, okay, and this is 5 to 8, 3 mg per liter. They write non-carbonate hardness is 8 mg per liter. Let me write sodium also here. How come you can say? How do you know that chloride will combine only with calcium or it will combine with magnesium? It cannot combine with sodium. This is a wrong concept. Wrong concept. Okay, that's why I'm telling you here again. Okay, so Chloride, sulfates, again the hardness will be due to calcium and on only. But in the suffix, if chloride, sulfates are there, then you call it as non-carbonate hardness. That's it. Okay. So, and one more thing. Hardness is also reported as calcium chloride only, as calcium carbonate only. Here also calculate the gram equivalents of calcium, calculate the gram equivalents of magnesium. You want to get it in mg per liter, just multiply with the equivalent weight of calcium carbonate. As simple as that. Nothing you need to do. Limits exactly same. Limits exactly same as you get for alkalinity. Here also 200 mg per liter and 600 mg per liter. Okay. Lastly, you should know that total hardness is carbonate hardness plus non-carbonate hardness, and carbonate hardness is minimum of total hardness and alkalinity. So you have to calculate total hardness and alkalinity, then you can check it out. And non-carbonate hardness will become how much? Total hardness minus carbonate hardness. You cannot calculate non-carbonate hardness directly. Like if you think you can calculate non-carbonate hardness like this, you are wrong. Remember this is very important. You have to go through this procedure for calculating non-carbonate hardness. Okay, lastly talking about measurement, because a question in GATE 2021 has been asked from this for 1 mark. Simple theoretical question. Let me talk about it in measurement part. This is the burette. You guys would have seen it. A burette is there. Okay. So what is happening? You are putting it a titrant. Titrant is that which reacts with the unknown parameters present in the water sample. First of all, the titrant used for the measurement of hardness is EDTA, ethylene diamine tetraacetic acid. Now what you do, this is the sample. Generally, you just measure calcium and magnesium because they are present in predominant form. Before starting the experiment, you will add EBT, that is Eriochrome black tea. Okay. Now what will happen when you will add EBT? What will be the color of it? What will be the color of it? EBT is blue black. What will be the color of it? When you will add it, it will become wine red. Okay, generally you know in chemistry we enhance the color, greenish pink, yellowish orange, we say like that. Okay. Now what will happen? After this you will turn the burette on. EDTA will pour, you properly mix it. Okay. The moment what will happen, EDTA will break this complex and it will form a complex with calcium and magnesium. This will be colorless and EBT will be again there present separately blue-black. So technically the sample will become blue-black. So the question in GATE was asked the change of color. So the change of color becomes from wine red, because before the experiment the sample was wine red. After the experiment the color became blue-black. So this was being asked in examination. Okay. So remember EDTA is being used. EBT is the indicator which is used. Color change is from wine red to blue black. Clear? So these three things which you should know it. Limits already I told you. Any doubts till here? If there is no doubts, so let's be quick and solve one question. Sodium 56 mg per liter, calcium 40, Mg2 plus 30 mg per liter, aluminium 3 mg per liter, HCO3 minus 190 mg per liter, and Cl minus is 165 mg per liter. And it is asking you firstly to calculate total hardness and the second is non-carbonate hardness. Come on guys. Solve this. Total hardness and non-carbonate hardness. Total hardness, that is, it is asking you to calculate magnesium will be there, calcium will be there, aluminium. Why? Because in the question nowhere it is given. Very good. So the total hardness will be 30 mg divided by the equivalent weight. I'll tell you one more thing beta. Magnesium, firstly the equivalent weight is 12. If it is written like this, 30 mg divided by 12, this you call it as milli equivalents per liter. Remember this. and then you multiply with the equivalent weight of calcium carbonate. This equivalents and equivalents will get cancelled out. You get it as mg per liter. Clear? Then I have multiplied it separately, but take it common and multiply it at the last. 40 divided by 20 is the equivalent weight of calcium, 50. 3. Equivalent weight of aluminium is 9. Why? Because the molecular weight is 27, the valency is 3. So 9 into 50. How much it is coming? 241.66 mg per liter. Why mistake again? Both Ankit and you are getting 241, it is getting. Alek, Ankit, beta, no calculation mistakes. So approximately 242 mg per liter. Next, it has asked you non-carbonate hardness. Non-carbonate hardness is total hardness minus carbonate hardness. Carbonate hardness you cannot calculate directly. You have to first calculate alkalinity. Alkalinity only one is given, HCO3 minus. Take that. HCO3 minus 190 divided by 61 is the equivalent weight into 50. How much it is coming? 190 into 50 divided by 61. This comes out to be 155.73 mg per liter. So what will be the carbonate hardness? This is total hardness. This is alkalinity. The minimum is how much? 155.73. So this will be the carbonate hardness. So total hardness is 242 and this is 155.73. 85.93 mg per liter, approximately 86. This will be the answer. Okay. One last question of milliequivalents per liter I will tell you. That is also required. That's it. Then we'll move further. Milliequivalents per liter. Okay. So 0, 2.65, 4.10. This is very quick. You don't have to waste a lot of time. 6.35, 6.85. This is 0. .90, 3.30. Just tell me the total hardness. Just tell me the total hardness. That's it. Just tell me the total hardness. I have taken the weight as 12.5. Will it be wrong? It will be wrong if they have mentioned you in the question atomic weight as 24. Just check it out, the atomic weight. If the atomic weight in the question is given you 24, okay, then you have to take is 12. If they are giving you another atomic weight and based on that if it is coming 12.5, no issue. So just check it out. Here they have given you in milliequivalents per liter. That means milliequivalents per liter is given. That means this value is directly given to you. So just check it out in the questions whether it is in mg per liter or milliequivalents per liter. Since it is in milliequivalents per liter, calcium 0, 2.65. Magnesium will be how much? 4.10, because here to here it is 4.10 minus 2.65. Just multiply by 50. That's it. How much it is coming? 205 mg per liter. So this is the thing which you need to check it out. Okay, fine. Now talking about chloride content. Chloride content, if it is present in excess, that means that water has been polluted. Either industrial waste is there or sewage is there. The technique of measurement, that is known as Morse method. So you should know the indicator, the name of it. So what is happening? In the burette, you have to take a solution, that is silver nitrate solution is to be there. What you will do? You will take the sample and you will add indicator, that is K2CrO4. When you will add it, before that you won't start the experiment. You will add it. Now what will happen? Here chloride is present. So AgNO3 will pour, it will react and you will see eventually this whole water will become white. This whole water will become white. That means the whole chloride is exhausted. After the whole chloride is exhausted, even a single drop of silver nitrate you will pour, you will see red color on this. So imagine this white color is there, and if you pour red color, it will automatically, it will be visible. Okay, so now you will say, ma'am, initially also K2CrO4 was present. Why AgNO3 is reacting now? Because the affinity of AgNO3 was more for chloride rather than for K2CrO4. Okay, so this experiment you guys would have done it in college also. This is clearly, you can see this. So this is AgCl is the white precipitate. The moment it is purely exhausted, even a single droplet you will add, you will get red brown color. So you will close the burette. So you will take the reading. If it is 100 and here this is 100 minus V. So how much is the titrant used? If VmL of titrant is used, you will say how much is the gram equivalents of AgNO3 used, that much gram equivalents of silver chloride will be present. Basically that much amount of chloride will be present. हिंदी में क्लास नहीं चलती है बिल्कुल चलती है. Okay, so this is chloride content limits, acceptable limit up to 200 mg per liter, cause for rejection limit 1000 mg per liter. ठीक है. Lastly, second last basically, nitrogen content is there. Again, one basic formula, basic thing they ask you. Firstly, nitrogen may be in free ammonia, organic ammonia, nitrite, nitrate. Okay, the summation of free ammonia and organic ammonia is known as what? Don't look at here. Nitrogen or algae, this is known as you want anything K Jalal, nitrogen. Okay, albuminoid nitrogen. This is wrong. You should tell me, ma'am, this you have written wrong. Why? Because organic ammonia is known as albuminoid nitrogen. Remember this, maximum students get confused. That's why I have written. Organic ammonia is known as albuminoid nitrogen. But summation of both of them, that is free ammonia plus albuminoid nitrogen, or you can say organic ammonia, is known as K-Jalal nitrogen. Okay, so don't get confused in this. Okay, I have written the wrong spelling also. Fine. Nitrite, nitrate. Free ammonia, organic ammonia, nitrite means partial decomposition of organic matter is going on, right? That means you cannot use that water. That's why the limit is mentioned to you nil. Nitrate means oxidation is completed. But again, tell me the prominent name. Asked in all of the examination, blue baby disease, or we call it as methanoglobomania. So if the concentration exceeds by 45 mg per liter, here cause for rejection limit and acceptable limit is same. That means there is no relaxation. If you live in that place where there is no alternate source available, then also you have to follow this limit. It means no relaxation. So if concentration is more than 45 mg per liter, you will get those blue baby disease, which will be happen to the infants, not to you guys. Okay, so that is blue baby disease. Now, one more thing, how to measure it. Free ammonia, just boil the sample. NH3 will be liberated, distillation, you will get the value. Organic ammonia, can anybody tell me how we'll get organic ammonia? Organic ammonia, you Neela bacha. It's like blue baby disease, the color of the blood becomes like that. Okay, next, talking about next is organic ammonia. Already boiled sample is taken. Add a oxidizing agent, again boil the sample. Why? Because organic ammonia consists of complex organic matters. If you will heat once, it won't go. So that is the reason what you have to do. You have to heat it again by adding oxidizing agent. So that is organic ammonia. While you talk about nitrite and nitrate, you can measure them by color matching technique. That's it. Any doubts till here? Boiling plus KMNO4. You can add KMNO4, you can add oxidizing agent or any other strong oxidizing agent also you can use. Clear? Tell me fast, any doubts? And if you want, I can write it. For nitrite, it is sulfonic acid plus naphthamine, color matching technique, plus naphthamine. Okay. Clear na? And nitrite also, this is phenol disulfonic acid. They haven't asked till now, but if they will, phenol disulfonic acid plus potassium hydroxide. Clear? So this is the nitrogen content that you should know. Now lastly, everybody knows about ma'am albuminite and JIA once again. Organic ammonia is known as albuminide. Okay. So generally students get confused. That's why I wrote it like this. And this is free ammonia is different. When you add both of them, you will get it KGL nitrogen. Clear, Prashant? Clear? So, now, last, this is there, then we have MPN, I guess. Yeah. Fluoride content. Fluoride content up to 1 mg per liter, it is good. Why? Because it helps to prevent from dental cavities and helps in the permanent growth of teeth. Permanent growth of teeth. And if you have permanent growth of teeth, today this pen is, my writing is becoming bad in this. Permanent growth of teeth. Now after 1.5 mg per liter, what will happen? Decolorization. You will see in the teeth brown precipitates are there. So decolorization of teeth, or you call it as mottling of teeth, is there. So generally this cavities thing, I already told you. It's not that if you don't brush your teeth and if you eat chocolates and all, and you will say that ma'am, in my water fluoride is not there, so don't like this. But generally you will see in cities and all, maximum students have the problem. Maximum students or what? Maximum people have the problem of cavities. One of the reason for this can be that in your water fluoride content is not there proper. And if you can see in the toothpaste and also it's written with added fluoride content, with added fluorine, so that generally the cavities which is present on the top of the teeth, okay, not in between two teeth. I asked my dentist because I just wanted to know it. So if the cavities is present on the front, on the top of the teeth, that is due to fluorosis. Okay, so if fluoride content, and that's why the doctor advises you to have that toothpaste which consists of fluoride. Okay, so that is the reason. If it is not there, dental cavities, if it is present in excess, like you would have seen it in villages and all, because they use the underground water, in that fluoride content is more. That case, adult not affected by mottling of teeth. We are affected. We are affected. Mottling means what? Galna. Okay, we are affected. So decolorize, but generally in cities you don't find it. Why in such in cities you don't find it? Because we take water from rivers and all, and surface water does not have excess quantity of fluoride. In maximum cases they have deficient of fluoride. Generally you will find this in villages and all, because there they take out the underground water, okay, subsurface water, so there dissolved solids is more. So decolorization, mottling, you go get it there, and that is known as fluorosis. And if more than 5 mg per liter is there, so what you will get? You will get bone fluorosis. That is known as deformation of bones. This also generally you would have seen it in villages when the bones are not proper, they are just deformed here and there. So that is also risky. So I guess now you guys understood why the fluoride content, you know, the most trickiest of all the parameter. Nalgonda technique is used if excess of fluoride is there. Was developed in the village, that's why. Now let me tell you one thing. That's the reason. It's not like a moral science chapter which I'm doing, but that's the fact. Generally in villages you get more fluoride because of the subsurface water. Check it out. If you are facing the problem of cavities like this on the teeth above it, the chances that the fluoride content in your water is less. So you can go for the fluoride toothpaste also. Okay. And ma'am, how we measure? So there is a color matching technique, zirconium iron and alizarin. This you have to use. Okay. Fine. Whew. Shall we start biological water quality parameter before 2040? Rajasthan session found bone fluorosis. Acha, derivation. Okay. So now biological water quality parameter. First we will go for MPN test, most probable test. This is very quick, I'll tell you, but very important things. What happens? There is a sample of water. This test is practically obsolete, but gate people ask questions from this test. That's why I'm telling you. That's it. Now what will happen? You will take 5 tubes. Uh, I'll take just a minute. I'll add some slides in this. Hmm. And let me tell you that practically if you will go and you will see this is obsolete. This is not at all being used, but since it has been asked in the examination, we have to teach this. But otherwise not useful. Okay. Now, when you talk about MPN test, most probable test, yesterday I dealt a daily dose, so that student was asking, ma'am, deal the concept in detail. So that concept in detail takes 15 minutes at least. So now what you do, you have to take tubes, sets, different set. Like set 1, you have to take 5 tubes of 10 ml, 1 ml, zero point 0.1 ml. Then you have to take 5 tubes of 1 ml, zero point 0.1 ml, 0.01 ml. Then you have to take 5 tubes of 0.1 ml, 0.01 ml, 0.001 ml. Okay. Now, actually, the total volume in every test tube is 10 ml only. But ma'am, you have written 10 1.1. This 10 1.1 signifies 1 ml signifies that 1 ml is the test sample, 9 ml is the pure water. 0.1 ml signifies 0.1 ml is the test sample, 9.9 ml is the pure water. Ma'am, but if the same is the volume, why you are doing it like this? Then how come I will know that in this test sample is different, in this test sample is different? That is the reason what we have done. That is the reason what we have done. We have bifurcated for understanding. Like whenever you give your blood sample, they take it in a test tube and they write your name. So because everybody's blood color is same, for distinguishing it, they just label it, right? Similarly here, the sample volume is same. For distinguishing it, we write 10 1.1. 1 for making it 1 ml is the test sample. 0.1 for making it understood that 0.1 ml is the test sample. Now what you do, you add lactose broth in all of these. When the gases are being produced, that means in that coliforms are present. Now technically biological water quality parameter, I need to check the pathogens. Pathogens are disease causing microorganisms because this water is supplied to your homes. We don't consider that you guys have water purifiers in your home. It is the prime responsibility of the government that it should supply you water which you drink without even getting it purified. Nothing should happen to you. So now technically we should test pathogens, but it is expensive, it is time consuming. So rather than testing pathogens, we test what? We test the coliforms. Coliforms testing is easy, and it's like whenever coliforms are there, chances of pathogens present are there. So rather than on everyday basis, we test the coliforms. Now comes the next question, how we do it. So first we add lactose broth in all the samples, in all the test tubes, and we put it in an incubator. Incubator is like your microwave and all, where ambient condition and temperature is maintained. Now what happens is, if gases are evolved, that means it is a positive test. Now 5 test tubes of it, let us suppose here 4, here 3, here 2. Here 3 it is 2, here 1. Here 2 it is 1, here 5. These are the positive results. Now according to the code, a table is given to you for 10 ml, 1 ml, zero point 0.1 ml. It is not given for any other dilution, it is given. And remember, no adjacent dilution should be more than 10 times. You can see this 10, 1, 1.1. So it is only 10 times diluted. Firstly. Secondly, the table is given for 10, 1.1. Now I'm telling you a very important thing, guys. Listen to me properly. If all the samples positive test results come, you will take that sample, where the dilution is maximum. Now tell me which one you will take. If on all the sets you are getting positive results, you will take the set in which dilution is maximum. Which set you will take? This is as per the code. Tell me. Which one you will take? Set 1, set 2, set 3. Which one you will take? Hurry, hurry. Dilution is maximum. Dilution is maximum. It means maximum amount of water is added. Dilution is maximum. So for 215, if let us suppose the NPN is 30, okay, you checked it for 215. You check example I'm taking. I'm not giving you the exact value. The 30, you will write it 30. No. Why? Because this 30 is for 10 1.1 ml. This sample is how many times diluted? This is 10, this is 0.1. How many times diluted? 100 times diluted. So the MPN you have to multiply by 100, you will get 3000. Understood? This you should know. This you should know. Now, what if in this sample, this is let us suppose 432, 320, 205, then discard this two, directly you will get for 432. Okay, directly you will get for 432. So in this manner you have to do it. Smallest dilution we take means okay. I'm saying if in all the sets we are getting the positive results, we will take those set in which the dilution is maximum. So the dilution is maximum in this one. Why dilution is maximum? Because here 0.1 ml is the test sample and 9.9 ml is the pure water. So the dilution is maximum in this case. That's why we take this set. Okay. Now, when you checked the table for 215, where it is gone? Shit. Just a minute. Something got pressed. Set 1. Just a minute, I'll write it again. 5 tubes of 10 ml, 1 ml, 0.1 ml, then 1 ml, 0.1 ml, 0.01 ml, 0.1 ml, 0.01 ml, 0.001 ml, 10 1.1. Just check it. There shouldn't be difference more than that. Is the difference coming more than that? 10 1.1, 1.1, 0.01, 0.1, 0.01, 0.001. Fine. Because the difference should not be, the dilution should not be more than 10 times. 5 tubes. Now what I said, in all of them, the result was positive. Let us suppose 421, 210, 212, let us suppose. And this is 123. So in this case, we take that dilution, we take that set in which dilution is maximum. Dilution maximum means, we say na, that this is concentrated acid, this is diluted. Diluted means water is there. So we will take those set in which dilution is maximum. So dilution is maximum in the case of 1 to 3. So let us suppose, but the table which is given to you as per the code, that is for 10 1.1. So let us suppose the MPN comes out to be 30, but this is for 10 1.1. You want it for 0.1, 0.01, 0.001. So you check that this sample, as corresponding to this sample is 100 times diluted. That is the reason you multiply by 100. Clear? Clear everybody? Dimple, you were asking me or you were telling me? And Arun also. Okay. Now, just check it out. And if it is 0 is there, like if set 1, one point 1.01. 5202 no 522 220 202. Which set you will take? 1, 2 or 3? Which set you will take, guys? नहीं नहीं, वो आपने बोला था ना कुछ स्मॉलेस्ट वाला शुरू में मिनिमम करके, तो मुझे लगा कोई डाउट है क्या. अरुण, which set you will take in this case? Set 1. Okay. Now just check it out. See, in this the sample is 1.1.01. Okay, 532. And one more thing, you guys should ask me, ma'am, if every set, shall I tell you one more thing? If let us suppose 520 203 032 10 ml 1 ml 0.1 ml, and this will be 1 ml 0.1 ml 0.01 ml, and this is 1 ml 0.1 ml 0.01 ml 0.001 ml. See, now which test you will set you will take? Come on, guys, based on your brain, tell me which set you will take. Fast, I want the answer. Okay. See, first of all, you will take those set in which if every test you are getting 0, you will take that set in which second dilution is positive. Second dilution is positive for set 1 also and for set 3 also. So in this case, as per the codal provision, you will take that set in which dilution is minimum. So dilution is minimum, that means less amount of water is added. So it is added for one has maximum, no, not based on that maximum, no, that logic is wrong, Lago. Firstly, you will check if in every test 0 is there. So you will check that the second dilution should be positive. It is positive for set 1 and set 3. After that, since two sets are there, you will check that in which the dilution is minimum. Dilution is minimum for set 1. Dilution minimum means less amount of distilled water is added. Clear, everybody? Understood the concept? Understood it? Diksha, Dhanush, MVS, Devanshu, understood everybody? Okay. Now talking about next. Now see, in this question, we are not interested with negative people and negative tubes. Okay. Why here we go for minimum dilution. Girish, this is as per codal provision, beta. This is not which I created it. As per the codal provisions, it is mentioned. Okay. So 1.1.01 test is given to you, but remember, always the combination MPN which you will get, you will get it for N1.1 ml. Just check it out. 532, what is the MPN? 44. Without even seeing, you will mark B. Is B the correct option? No. Why? Because this is given for 10 ml, 1 ml, 0.1 ml. In the question, it has asked me for 1 ml, 0.1 ml, 0.01 ml. How many times it is diluted? 10 times. So that is the reason 44 multiplied by 10. Understood, everybody? Who was asking Lagom? Everybody, it is clear? Okay. So this was your MPN. Whew. So this, with the help of this, we complete the second chapter. Any doubts is there? Tell me. Any doubts? Shall we complete treatment of water? Then we'll give a break. What do you say, guys? Mm, coliform index test. Sterile coliform index test is the reciprocal of the smallest quantity of B. coli test. 5 minutes break. Okay. Let me create now. Also, I don't know how to do a poll. Okay. Everybody wants break. TP low. Okay, fine. I'll give you only on one condition when everybody of you will promise that nobody will go. Otherwise, what happens after break comes, some people goes that okay, fine, I'll see the recorded lecture. I'll make sure that this lecture becomes private then. Promise me. अभी तो आया हूँ तुम लेट आए ना धानुष promise me okay fine then we will take a 5 minutes break 5 so 5 minutes break 5 minutes 5 minutes break so promise रविश तुम लोग धोखा दे देते हो यार कितना टाइम हो रहा है अभी 1:10 पे मिलते हैं 1:10 PM पर 8 मिनट दिया ना मैंने गिरीश Guys, come on time because I'll be starting treatment of water and I'll be showing you images and all also. Okay? So come on time. अरे फिर अभी लंच ब्रेक भी तो देना है लंच ब्रेक भी दूंगी ना लंच ब्रेक ठीक है जाओ जल्दी जाओ टाइम जाएगा फिर जाओ फटाफट से जाओ कम ऑन गाइस Hello everyone. So we are back. Actually, I forgot my specs. See, I told you, some students become lazy. Okay, sincere students, when will be lunch break? I'm thinking that let's complete distribution. After that, we will have lunch break. What do you say, Alec? So this is the schedule. And one thing, I checked that also. This was according to the old code. This is 15 TCU. Ashish was telling. What happened? My pen tab is. Where it is going? Just a minute. Huh? What happened to it now? Just a minute. My pen tab. Where it is going? What is my lunch time? I don't have fixed lunch time, and this pen is not working now. What has happened to it? Yaar? Shit. Fine, just a minute, wait. What happened to it now? This is operating. Hello, voice is clear. Only this pen is not going. Can you refresh at this moment? How can I? Everything was going. ये भी break पर चला गया. ये break पर ही चला गया. Just a minute, I'll contact the team. This happens. That's the thing which I'm afraid of. Fine. That was 15 TCU, by the way, till that time. If I go and just a minute. Actually, you know what mistake I'm doing it? My color is white. If I'm writing anything, see what a brain I got. It is coming in white. Great. That's why, because I wrote it. Na? Oh my god. See, I'm not doing anything. It is happening on its own. Jadoo ho raha hai. 4. This is 15 TCU. Actually, it was white. When I was checking it out, it was not showing me any color. Fine. Guys, come on. Now we will start treatment. It's working. Black PPT. Black PPT. Actually, last time when I did the formula revision, they were telling me to use white PPT. So that's why I used white PPT. Now, if you are giving me the feedback, hydrology and irrigation, I will take it in black PPT. Okay. Last time you guys told me white, that's why I took white. Okay. So guys, as I told you, environment blue. Tell me the color so that the next PPT which I'll make it in that color. Maha Marathon tomorrow for Geotech, 10 a.m. sharp. Okay, so guys, now talking about treatment of water. Obviously, first we will check the quality. If, as you know, if desired quality is not there, if fluoride is not there, we will add fluoride. If excess quantity of fluoride is there, we will remove fluoride. Similarly, we'll do for other parameters also. So here, if you talk about, we have various methods of treatment. We go it in a sequence also. Like first screening, then aeration, coagulation, flocculation, sedimentation, filtration, disinfection. A disinfection is the last. These are the miscellaneous treatments which is given. These are the miscellaneous treatment. If the water is hard, then only you will give softening. If the water has not fluoride, no fluoride is there, then you will add fluoride. If excess is there, you will remove fluoride. Similarly, if salts are there, it's okay. If excess is there, you will remove it. Okay, so what will happen here? Miscellaneous treatment has been given. Miscellaneous treatments has been given for this required depending upon the quality of water. Okay, now what happens? Here, talk about first is the screening. Screening, as you see, the screening is done for the removal of large suspended particles, or you can say large floating matter. So whatsoever paper bags and all are there, animals or all the things which are floating, these are being removed in screening. Now screening, we have two types of screens. You know that, coarse screens and fine screens. Guys, what is the screens which we use on prominent basis? Coarse screen or fine screen? Coarse screen or fine screen? Coarse screen or fine screen, which we use on prominent basis? We use coarse screen. Now, if you talk about it, generally they are in the form of bars. Already mentioned the dimensions. However, it is not used so much for your gate. It is used for your ESC for conventional designing purpose. These are the bars. The bars are 20 to 25 mm dia and the spacing between them is 25 to 100 mm. Generally, they are not placed like this. They are placed at an inclination. These a single bar I have told you, these are placed at an inclination. Now you'll ask me, ma'am, why they are placed at inclination? Generally, if not mentioned, we take it 45 degree. However, they have given you 3.6 vertical is to 1 horizontal. Now, generally we use coarse. Everybody answered it correctly. The reason is fine screens. Obviously, it is good. Even it will trap the finer impurities also. But the head loss is more. So water has to spend more amount of energy to overcome the friction offered by the fine screen. Firstly. Secondly, what will happen? Frequent clogging will take place. So, frequent removal has to be done. That is the reason we go for coarse screen. In coarse screens, generally we place it at an inclination so that the amount of area which is available is more. Okay. Then, for calculating the head loss, there is a formula K by 2G V square minus U square. K is constant, depends upon the material of the screen. G is acceleration due to gravity. If by chance in the case they don't give you the value of K upon 2G, you take it as 0.0729. Clear? Now two velocity are there. U is, generally they say use velocity above the screen, but you should know that it is velocity of approach. And this is V, velocity through the screen. Now can you tell me, V will be more or U will be more? V will be more or U will be more? No, K by 2G it is there, not K square. V will be more. Why? Because here in between this area will be there. This net area will be there where the water will be passing. So discharge is constant. Discharge is equal to area into velocity. So if area is less, the velocity has to be more. While here when it was talking about here, the whole area was available. So gross area was there. So area was more. That's why velocity of approach U was. Clear? This you should know. Now, talking about further, fine screens already told you frequent calling and they are in the form of wire mesh. I will show you the diagrams also. Wait. These are like this. These are in the form of wire mesh. These are fine screen. Okay. Generally not ask questions, but they can ask you in MSQ patterns and all, so you should know. Or they want, they can ask you in 1 marks the head loss part. Coming up next is the aeration. Aeration means something related to oxygen. So what you do in the case of aeration, you bring the water in intimate contact with the oxygen present in the atmosphere. Okay, while you do so, the dissolved minerals, the gases gets removed. You don't want gases like H2S. You know nali ki badbu, which we call it, and you would have done it in your salt analysis. That strong smell of H2S comes out. So that smell, you don't want it. Okay, so that is the reason you take the water and you try to bring it in contact with the oxygen which is present in atmosphere. So what will happen? It converts into acid, like H2S gets converted into H2SO4. Okay. If carbon dioxide is there, it will get converted into carbonic acid so that the impact of gases can be reduced. Now comes the next question. How do we do this aeration? So pungent smell, or you can call it as rotten egg smell also you can call it. Okay. Now there are various methods like spray nozzle, cascade aerator, tray tower, diffused air. Now let me show you spray nozzles method and all, as you can see it in the diagrams and all. What will be happening, like if I show it to you, the nozzle will be there from which water goes out. Okay, it forms into number of layers. Actually, as you can see here, the number of layers are there. You can see number of layers. So when there are number of layers, the opportunity of oxygen to come in contact with the water increases. Okay, so this is a good method. It has greater efficiency, 98-99% efficiency for removal of carbon dioxide, H2S gas, but still we don't use it. Why? Because it is costly. So we don't use it. Now, next comes the other one is, this is what? Cascade aerator method. You can see this. Here you can see this concrete steps like this, you know, right? These concrete steps, 3 to 3.5 concrete steps. This is very simple. No need to apply any. Easy for operation, no brain to apply. You can see this. Here steps are there. Steps are there, right? You can see these steps are there. 3 to 3.5 steps are there. Thus, bring it. What will happen? It does not have a higher efficiency that spray nozzle. That is one. That is obviously it is required. What pressure you said? Pressure is required. And pressure is required. That means what? You have to install other equipments, and it becomes costly as well. Okay. Now coming next, as I told you, cascade aerator. You ask, ma'am, which is the one which is used? This is the one which is used. So if you visit your treatment units and all, you will see this cascade aerator which is being used. So now what you do it here, 3 to 3.5 steps are there. 3 to 3.5 steps are there. Water goes into this, flows into steps, and it comes in contact with the oxygen which is present in the atmosphere. Simple, easy to operate. We use this. After this, we have tray towers method. This is diffused air. We have tray towers, multiple number of trays like this tray of different sizes. Then this tray. Then this tray is there. Then again a tray is there. So multiple number of trays are there. So of various sizes. So from here also water moves into number of layers and the oxygen comes in contact with it. So there are n number of methods, but the one which we use it is cascade aerator method. Simple to construct it. Okay. Next, these three were natural. That means you were using the atmospheric oxygen for treating the raw water. But this diffused air method, what you do, just like you guys would have seen it aquarium and all. What you see it there, from the bottom the gases comes out, the oxygen comes out. Okay, so here also in dissolved oxygen method also what will be basically happening is here diffused air method also what is happening here. You are artificially here the atmospheric oxygen is not being used. Okay, so the oxygen is supplied from the bottom, but practically we have to need million liters of water. So it is not possible that we can satisfy that much demand of oxygen. So we don't use it. on a large, you can use it for a certain community, but you don't use it for a wider population. Okay, so this is the thing which you should know. Out of this, we use cascade aerator, but the best out of this is the spray nozzle method. Okay, now coming to the sedimentation tanks. If you talk about sedimentation, the whole hero of this sedimentation is specific gravity. Specific gravity is the hero of this chapter. Now, first, if we talk about the sedimentation tank, there are two types of it, broader sense, quiescent type, you call it fixed type also, and you call it fill and draw type also. Second is continuous flow type tank. Now, let me talk about quiescent type tank. Nothing to apply brain. What is there? What you bring the water, you make the turbulence zero. Water is not at all flowing, water is at rest. What will happen? You keep the water for 24 hours. Whatsoever suspended solids are there, they will settle, you will take the water. Fill, draw. Fixed, no turbulence, nothing is there. So, fill and draw type tank, quiescent type tank, this is there. Okay. Next, if you talk about generally how many tanks are basically used, 3, 2 are operational, 1 is kept as standby. You design it for maximum daily demand. You design the tank for maximum daily demand. Okay, there's nothing more we need to understand about it. Detention time is 24 hours. You keep it as manual cleaning is applied because here the suspended solids settle down. When you talked about screening, large floating matter was removed. When you talked about aeration, dissolved solids and gases are removed. When you talk about sedimentation, suspended solids are removed. Okay, now coming next, we have continuous flow type tank. Remember, continuous flow type tank means water is flowing. Water is flowing. The turbulence is not zero. Now, when you talk about horizontal flow type tank, you should know very important thing. This is the settling zone. This is the sludge. Now what happens? These are the assumptions. Assumptions might not be true, but assumptions are taken to simplify our calculations. A particle is assumed to be removed. So if a particle is present here and it reaches the bottom of the sludge zone, if it reaches here, it's not required to reach it here. So if it reaches the bottom of the settling zone or the top of the sludge zone, it gets removed. Okay, it's not, see, this is the bottom of settling zone and this is the top of the sludge zone. If it reaches here, it is removed. That's it. Next, the concentration of particles of all sizes. Let us suppose 5 mm particle is present, 200 mg per liter is the concentration of 5 mm particle. So it is saying, and let us suppose it is imaginary, the depth of the tank is 10 meters. Imaginary, I am telling. So you mean to say that 200 mg per liter of particle per meter 20 mg particle is present, which you also know that it's practically not necessary. But this is the assumption that the concentration of any size of particle which is present along the vertical cross section at the inlet is same. At the inlet is same. This is the assumptions you have taken. Okay. Now, based on that, you know two things you should know. One is the design size of particle, or you call it as concerned size of particle. Design size or concerned size of particle is that particle for which you design the tank so that your desired efficiency is maintained. So you call it as design size of particle or you call it as concerned size of particle. This is that particle, I am repeating it again, for which the tank is being designed. The velocity corresponding, see, this velocity is exclusively for design size of particle, is known as overflow rate. And you denote it by V. And for velocity of any other size of the particle, you can go by laminar flow, Stokes law, you will get the velocity. Settling velocity. Why? Because the suspended solids are present in the tank and you want them to settle. If you want them to settle, you won't make the turbulence zero, but you will slow down the velocity. Now the dia of the particle can be anything. It can be 5 mm, 0.1 mm, 0.0115 mm, anything. So we have divided into laminar, transitional, turbulent. Now a frequently asked question. Settling velocity here, it will be d square upon 18 nu gs minus 1 into g. Nu is the kinematic viscosity. If I talk about turbulent, it is 1.8 root over gd gs minus 1. Now this one more formula. Let us suppose in the examination they ask you, consider the effect of temperature. Consider the effect of temperature. So for laminar there is again an empirical formula you guys need to know. D square 3t plus 70 by 100. Same formula is there for transitional. Exactly same but only one change. Instead of d square this time it is d. That's it. Okay, and Vs settling velocity you will get it in mm per second, dia you will get it in mm, and temperature you will get it in degrees Celsius. Similarly here, this you have to make sure. Okay, so this is regarding the sedimentation tank. Now comes the question. Before we move to the question part, percentage removal efficiency. Remember, percentage removal efficiency. See, we design it for V naught, but there might be some particles which have a velocity more than that of the concerned size and which have the velocity less than that of the concerned size. So that's why Vs into 100. Now, you guys will answer. Suppose I designed for a 5 mm size of particle and 8 mm, 7 mm size of particle is present. What will be the efficiency? 100%, 50%. This is my design size of particle. And in the water, 8 mm and 7 mm particles are there. 100%. Very good. Why? Because any size of the particle or any velocity, remember, any size of the particle or any velocity more than the settling velocity of the concerned size of particle, 100% efficient. Will 4 mm, 3 mm, they will also be removed. Remember, this can be asked in statement wise, but not completely. They will be partially removed. Okay, this you should know. Now, talk about this. Consider a plain sedimentation tank. Surface overflow rate is given to you. It is asking you to calculate the dia of that particle which has 80% removal efficiency. Vs by V naught into 100. So 80% is given to me. Velocity overflow rate, let us calculate it in meters per day. Convert it into meters per second first. V naught converted into meters per second. This is meter per day. So 40 divided by 86400. Convert it. How much it is coming? This is kinematic because it is given meter square per second. No? 4.629 into 10 raised to power minus 4. This much it is coming 4.629 into 10 raised to power minus 4. Now settling velocity d square by 18 nu laminar. We are assuming it laminar. 1.10 into 10 raised to power minus 6. GS minus 1. GS is 2.65 minus 1. How much it is coming? Into 9.8. See, first tell me the answer in meters. Oh, you are telling for this, Ashish. Ashish, I have corrected it. It was 15 TCU. Huh? I corrected it. I guess you were not there, so I'm telling you. How much it is there? Come on, guys, solve this and tell me. Fast, fast. Tell me in meters, we'll convert it into micrometers. How much it is coming? Hmm? Is it? I've taken this as new. Fine. 60, okay, it is coming like this. 0.673 into 10 raised to power minus 6. No, 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 no. Deepak, it is wrong. 1, 2, 3, 4. This is wrong. Just one of the other person also calculate MVS. Okay, fine. Actually, they should have written it here Newton second per meter square. This much kinematic viscosity we don't get, but fine, they have written meter square per second. 0.673. Deepak is correct. So MVS is wrong. Fine. You guys can calculate this. This is 0.673 micrometer. Okay, fine. MVS is correct. 8.48. Guys, calculate this logic I have told you. Okay, you guys can calculate this. 3 people have got the same answer, so I have taken that. Arun, just take it once again better. Okay, fine. So now talking about vertical flow type tank. Vertical flow type tank, what you see as you move, actually you see it from here, you see that the water moves only in 2 directions, but the water moves in all the directions. So now what is happening here? What is happening here? The water moves. As the water moves away, the velocity decreases. First of all. Moreover, here if the particle is there, it has two velocity. One is settling velocity and other one is the flow velocity. So if you take the resultant of it, this is the parabolic in nature. Remember, this is an important statement wise questions. When you talk about horizontal flow type tank, if this is the settling velocity and this is the flow velocity. So the resultant will be linear. Okay, straight path will be followed. While in the case of vertical flow type tank, parabolic path is followed. Firstly, and here you should also know one thing. You should also know one thing that here if you want to calculate the volume, there is a formula d square 0.785h plus 0.011d. So d is the diameter, h is the height. So with the help of this, you will get the volume. You will get the volume. So this is the formula for vertical flow type tank. Now in examination, sometimes they ask you simple questions like they will discharge is equal to area into velocity. So they will give you the discharge, they will give you the area, they will ask you the dia. So if they ask such sort of question, discharge divided by velocity, this will be pi by 4 d square. So in that case, you can go by this method. But if specifically it is telling you to use the empirical formula, it has given you discharge, detention time and all. So first you will calculate the volume and with the help of that you can get the dia. Okay. So anybody else haven't checked the answer? So this is for vertical flow type tank. Okay. Okay. Any doubts still here? Any doubts still here? Ask to me fast. Fastly, fastly, fastly. Oh, no doubt. Formula once, ma'am. Ma'am, previous question, please show. Okay, fine. Formula is V is equal to D square 0.785H plus 0.011D. D is the diameter and H is the height. H is the height. Okay. Next, this question they have made a mistake. They should have written in this should be if it is kinematic viscosity, it should be dynamic. But based on the unit, it comes out to be kinematic. Some sort of magic is happening. I'm not touching and the slide is going. Okay. Fine. Now, talking about next is coagulation aided sedimentation. Some student was having doubt also. You can understand this. See, let us suppose if the solids which was coming is 1000 mg per liter. And the solids after plain sedimentation which goes was 600 mg per liter. What is the efficiency of the sedimentation tank? What is the efficiency? 100 minus 6000 minus 600 divided by 1000 into 100. It comes out to be how much? How much is the efficiency? 400. 40% is the efficiency. But actually I need a tank with an efficiency of, let us suppose, 80% or 90% or 95%, because I want even the finer solids should be removed. That doesn't happen in plain sedimentation. In that case, you have to go for coagulants. You have to add certain chemicals. Now, these chemicals are known as coagulants. What do this chemical do? When you add them, see, these particles are not settling. If you see this, these particles are not settling. Why? Because they are stable. Because they are stable. They will settle if I add a chemical in this, so that the stabilization will be what? The destabilization will be take place. The stabilization will be destroyed. The destabilization of the particle will take place. So for the destabilization of these suspended particles, I need to add chemical. I need to remove the finer impurities also. I need to add chemical which is known as coagulants. Now, firstly, you can add coagulant in powdered form. You can add it in solution form. Generally, we add it in solution forms. Now, when you add any coagulant, you want that it should evenly spread. So, you do fast mixing. Okay. Fast mixing is introduced so that first the particles get destabilized. After that, you pass it slow mixing. Why? So that the destabilized particles, small particles, which are now not at all stable, they combine with each other, become bigger in size, and eventually they go into the sedimentation tank and settle. So it's coagulation aided sedimentation, coagulation, flocculation, then sedimentation. Okay. Now, this is the thing. You can add 3 different chambers for this, or what you can do it, you can first mix it, then make it in, take it to the flocculation chamber, and then take it into the settling chamber. That depends upon you. Okay. Now, what happens here? There are different types of coagulants which are added. One coagulant which is very much important, on which questions has been asked, is alum. Al2SO4 thrice dot 18H2O, that is hydrated aluminium sulfate. Generally, I tell you to remember this so that you can solve any questions. If you want to go by gram equivalents method, you can go by that method also. See, the weight of this Al2SO4 thrice dot 18H2O is 666 grams. What I tell you is, alum will function only if you give bicarbonate alkalinity. Ma'am, if it is not present, it won't function. So if you want alum to function, you need to give it bicarbonate alkalinity. If you are not giving it, it will not at all function. Firstly. Now, if calcium bicarbonate is not present, what you will do? You will add calcium carbonate plus, how you will get? Water or carbon dioxide? Tell me. For getting calcium bicarbonate. Calcium carbonate will also be not available to you directly. Then you need to add what? You need to add calcium oxide. So this is the question which is asked on prominent basis. Calcium bicarbonate will be formed when you add calcium carbonate. Calcium carbonate will be formed when you add quicklime, that is calcium oxide. So generally it is very simple to understand that what happens if 666 grams requires 3 into 100 grams. This is calcium bicarbonate, and calcium bicarbonate will come when you add 3 into calcium carbonate. So 300 divided by 666 you will do 0.45 it will come. So if you want 1 mg of filter alum to function, you need to give 0.45 mg of alkalinity as calcium carbonate. So either you can have waste your time doing the manual calculation, or you can remember this. This will be easy for you to understand. That depends upon you. That's entirely your call. You can do it and you will get the answer. Okay, but remember, alum will not at all function if you won't provide the alkalinity. Till here it is clear? You want to do question on this? You want to do question on this, or you have practiced already? Tell me fast. You want to do question on this, or we'll move further? Question? Okay. So simple question is there. Fine. That gate question which is asked. And you will understand that this is very simple. Based on this, you can solve any question. I didn't have it out. Simple question is there. What you have to do, simple 10 mld of water is to be treated. 10 mld of water is to be treated. Alum dosage is given to you as 20 mg per liter. 20 mg per liter it is given to you, and water already has alkalinity. Water has 6 mg per liter of alkalinity as calcium carbonate. It has this much alkalinity as calcium carbonate. Now what it is asking you in the question, total alkalinity requirement. Come on guys, solve this. Arun, Devanshu, I want everybody to answer it. Total alkalinity requirement. How much? 10 raised to power 6 mg per day as calcium carbonate. Total alkalinity it is asking. Total means it is not bothered about how much is there and at all. It is asking the total alkalinity as calcium carbonate. Come on guys. A option is 120. However, I shouldn't give you, but fine. I'm giving it. Come on. I'll repeat it at the last beta. It's not possible now to go there. Got that? Okay, let's check it out. See, very simple if you know this. 1 mg of filter alum requires 0.45 mg of alkalinity. So 1 mg per liter requires 0.45 mg per liter of alkalinity. So, 20 mg will require how much? In this manner you did it. 20 mg per liter will require how much of alkalinity? 20 into 0.45. It is coming 9 mg per liter of alkalinity. So if 1 liter 9 mg per liter of alkalinity is required, so for how much liters it is there? 10 mld, how much it will be required? So how come it is coming 120? So 9 mg per liter is required. So for 10 into 10 raised to power 6 liters per day, how much it will be required? See, liters and liters will get cancelled. Mg converted into kg, it will be like this. So it is 90 kg. Got it? Devanshu, who was telling me, no, some other guy was, Prashant was telling me for understanding this very carefully. Understood? So if you know this, things becomes very easy. Now, one more question which was asked in this topic. Oh, Swapnil, you are there. Now you answered. My God, I thought you are not there today. Okay. Quantity of quick lime required. Now see, this is the second question. Quantity of quick lime required. This is 10 raised to power 6 mg per year as calcium oxide. 2132, 3000, 4132 and DS 6132. So this is very simple. Where I have seen your, but the table is not learned by you. Which table you are talking about, beta? I'll check it out. Milendra, I'll check it out. That Goodrich equation you're saying? No, actually you were not answering the Swapnil morning. I know you wished me, but after that you were not answering. Milind, tell me that table. I'll see. Which table? Peak factor demand table. I already told you 1.8, 2.7. That table I told you. Now which peak factor table you want? Now see, again, 1 mg per liter of alkalinity requires 0.456 mg per liter of lime in the form of calcium oxide. Now see, you require 1 liter 9 mg of alkalinity. In the solution already 6 mg is there. Additional alkalinity, how much you require? Additional you require 9 minus 6. That means for only 3 mg per liter of alkalinity as calcium carbonate, you need to add calcium dioxide. So this is 3 mg per liter. Now for 1 mg per liter of alkalinity as calcium carbonate, you require, already mentioned is, just check it out guys, 0.56. So you require 0.56 mg per liter of calcium oxide. So for 3 mg per liter as calcium carbonate, how much calcium oxide is required? 0.56 into 3, 1.68 mg per liter of calcium oxide. So if for 1 liter, 1.68 mg of calcium oxide is required, for 10 into 10 raised to power 6 liters, how much will be required? And it is needed for per year. So per year is 365 days. How much it is coming? 6132 into 10 raised to power 6 milligram. And it is already given, 10 raised to power 6 is gone, only 6132. So see, question becomes so simple if you know the following bullet points which I have told you. As simple as that. Clear? So such questions can be asked. So already told you. Now coming to the next one, that is when you are mixing. See, mixing you can do it. Now talking about, I asked about small, medium, large. Peak factor demand. That population one up to 2 lakh, up to 50,000, 50,000 to 2 lakhs, greater than 2 lakhs. That one you're talking about, I'll provide you at the last. Okay. Now, when you talk about coagulation, you want that the chemical should mix. So what you can do, you can basically do what you can provide baffle walls. When you provide baffle walls, what will happen is the mixing will take place. Okay, like I'll provide a baffle wall and show you. Like here you have baffle walls. You have various baffle walls. So water will go splash it here, go like this, splash it here, and so on. Now what happens here? Here you don't get the desired efficiency, or you can say mixing of coagulants does not take place 100%. That is the reason we go for flash mixer. What will happen here? Paddles are there. You can see it here. Impeller are there. These paddles are there. What will happen? You will feed the coagulant, and what will be happening is motor is there, so it will rotate. The paddle will rotate fastly so that the rapid mixing of the chemical can take place. But for this, you need to supply power. So how much power is to be supplied? That is given by the formula P is equal to G square mu V. Remember, many students get confused. V is the volume here. It is not the velocity. First. Now what is G? G is the temporal mean velocity gradient. Okay. The G is the, if this particle is there, there is another particle, and both have the distance x. Both the difference in the distance is x. It has the velocity v1, it has the velocity v2. So temporal mean velocity is the relative velocity between the two divided by the distance between them. So this will give me the temporal mean velocity gradient. Technically, this term G specifies me how much intensity of mixing is taking place. Okay, that is specified by G, that is temporal mean velocity gradient. So you can use this formula for calculating what, even you can derive it, but derivation is not at all important. Based on dimensional analysis, the formula comes. So P is equal to G square mu V. This is the formula. Simple, nothing else is required for this. Okay, now talking about flocculation. Flocculation is slow mixing. Slowly, gently you are mixing, so that what happens, so that all the destabilized particles comes in contact with each other. Now, for this, if I talk about, here also same mixer is there, but the RPM, the rotation per minute is reduced. Why? Because even if you say, ma'am, why flocculation you don't provide fast mixing? If I provide fast mixing, the destabilized particles will not come in contact with each other. That is the reason, because my funda is I want that those destabilized particles should come in contact with each other, grow bigger in size, and eventually settle. But if they don't come in contact because you're doing fast mixing, then there will be no use of flocculation. Okay, so that is the reason. That is the reason in flocculation we go for slow mixing. And there was, this was the thing which you should know. Any doubts? And there was one more formula for power. Power is this formula, you remember? This one formula, half CD rho W A VR. This will become VR cube. You remember this formula? Guys, this is the formula for power. So here VR is the resultant velocity. If in the question they ask you velocity of pedal minus velocity of water. Technically, they take velocity of water as 0. So in books you find it, they write it as like half CD rho W A V P. Okay, A is the total area of pedal. Let us suppose if the width and length of pedal is given, you have to multiply with the number of pedals to get the total area of pedal. Okay, so this is the thing which you should know. If they ask you, you should be able to answer. As simple as that. Okay, and power you already know, G square mu V. In place of volume, they can give you discharge into detention time. You can do. ट्रैंक एंड लिफ्ट में देता है, ये इन्वायरमेंट में भी देता है. फॉर्मूला ड्रैग फोर्स का लगा है, बट ये इसमें भी देता है. ठीक है, सो यू शुड नो. ओके, so this is the flocculation. You can see same like that, but pedals are here also there, but slow mixing is induced. That's it. Now talking about filtration. Filtration is in itself a complete treatment unit. Why? Because it will remove fine suspended solids also. It will remove microorganisms also. It will remove any sort of foreign impurities also. It will remove dissolved solids also. So it removes everything. It removes dissolved solids. It removes dissolved solids are there. Then you have what? Biological, or you can say any microorganisms are there, it will be removed. That also can be removed. Now when you talk about filtration, we do the process of filtration by the units known as filters. Now filters we have generally two types. One is gravity filters, another one is pressure filters. Gravity filters we have again two types, slow sand filters, rapid sand filters. Now first we will understand how this filtration will take place. There are four mechanisms: mechanical straining, sedimentation, biological changes, electrolytic changes. In mechanical straining what happens? This filter bed is there. You can take sand, you can take anthracite, you can take geotextile, anything you can want, you can take it. I am making the size of the particle bigger so that you can see this. Now when the water comes in this mechanical straining, what you will see, the particles which have a size greater than the size of the sand particles, they won't be able to pass through it. Okay, they won't be able to pass through it, and they will retain here. They will retain here. Eventually, even the size of the particle, which is smaller than the size of the sand particles, will also be retained at the top, and they will form a layer which is known as matte layer. Now what will happen the moment they get deposited on the top? What you can do, you can strain it out. You can mechanically strain these impurities out. So the manner in which these suspended solids are removed, the process is known as mechanical straining. Okay. Now, next we talk about sedimentation. When you go by the process sedimentation, generally this is happening in the filtration chamber. So generally, I'll take it as red color only. So these are the sand particles. It behaves like a quiescent type tank because the filter is not at all moving. You are bringing the water. Here the water is accommodated. So the water is at rest. Specific gravity will come into action. Those particles which have a density more than the water, it will get settled down. So it behaves like quiescent type tank. Now, biological changes. Biological changes gives you higher efficiency, but it takes time. It is not a one day that it will happen. It takes time. So what happens in biological changes initially, when the water comes, it has microorganisms in it. It has organic matter in it. Technically, the microorganisms are there and they are not completely removed. The organic matter is partly decomposed. Right now, the organic matter is still there. So what will happen is, when you pour this water, the microorganisms decompose the organic matter and they form a sticky deposit. Now, here algae will also be coming into action. Now, algae will be there. This this filtration tank is open to the atmosphere. So what will happen? Algae will get sunlight. With the help of sunlight, what will happen? And if you'll ask me, ma'am, how algae will grow? Because in this water, organic matter is there, and the general formula of organic matter is CaHbOcNdSePf. A moles of carbon, B moles of hydrogen, and so on. It's not necessary that every element has to be there, but this is the general formula. These carbon, hydrogen is the nutrient for algae. If such conditions are there, algae generation will take place. Algae, on the action of photosynthesis, will prepare its food. It will liberate oxygen. That oxygen will be used by microorganisms for decomposition of organic matter. Over the time, what will be happening? Microorganisms will be decomposing the organic matter, and the layer will be formed, which is known as smudge-deck layer. Smudge-deck layer. Okay. Now, what will be happening? Decomposition is happening. Over the time, microorganisms have rapid reproduction rate. Means they multiply themselves exponentially through cell division. 2 to 4, 4 to 8, and so on. So, what will happen? The microorganisms will increase. The organic matter remains the same. Those microorganisms which are getting food, okay. Those who are not getting food, they will go endogenous respiration. That means they will kill themselves on their own. Okay. So, what you will see here in this layer, there will be what? Large smudge-deck layer will be there. The thickness of this layer will go on increasing. And the water which will come out, it will have almost, if you go for slow sand filter, 98 to 99% of bacterial removal efficiency you will get. Okay, if you are using slow sand filters. So because of the development of smudge-deck layer, and let me tell you, it does not develop like in an hour and all. It takes time. Okay. Last, so here you remove pathogens. Here you remove suspended solids. Now, how to remove dissolved solids? What happens? These beds are charged. Okay, they might be having positive charge, negative charge. The dissolved solids which are coming, they might, let us suppose if this is A and this is B. The dissolved solids which are coming, they also have charge, positive charge and negative charge. So when the water which has dissolved solids, ions in ionic form is there, they pass through this filter bed. You don't know, they react with each other. How much they react, you'd never come to know. But at the end, whatsoever water you get, you will see that the dissolved solids amount is very less. Okay, so based on electrolytic changes, and if you think first mechanical straining will take place, then sedimentation, no. All the things are taking place simultaneously. Okay, so all the things are taking place simultaneously. So this is the theory of filtration which I told you. Gravity filters is important. Gravity name is given because, see, whenever water will pass through the sand, it will offer resistance. So to overcome the resistance, whatsoever energy is required, that is provided by the water itself. So that is the reason it is known as gravity filters. Any doubt till here? Guys, any doubt you have till here? Let me know fast. Any doubts you have? Generally, for idle, it takes weeks. But for rapid sand filter, we can't wait for that much amount of time. Okay? Now, talking about the slow sand gravity filters, let's be quick. This is very simple. This is an inlet chamber which you have provided. This is an inlet chamber where water is accommodated. Now, what you will do is, I'll take a blue color. Now, how much is the depth of the water? Remember, how much is the depth of water? How much is the depth of sand? That much depth of water should be there. Always. Here the sand depth is 90 centimeter. Here the water depth is also 90 centimeter. Finer quality of sand is provided at 15 to 30 centimeter of the sand out of 90 centimeter is of finer quality. Okay. Next, gravel is provided to support the sand. It has no other function. It has function is only to support the sand. Now what will happen here when the water will get poured? Obviously the resistance will be offered. That resistance will be encountered by the water itself. Same mechanical straining, sedimentation all will take place. After that there are lateral drains. These are the small lateral drains are there, and this water goes into the bigger one, that is main drain. So on both the sides technically it is like this because you are seeing a section of it, you can't see it. So these are the number of under drains, lateral drains. From here water goes into the main drains where you can take it to filter it, disinfect it or directly supply it. Okay. This slow sand filter, the major drawback is it requires large area, 100 to 2000 meters square of area. That's why it's not possible to use it. Moreover, the rate of filtration is also very slow. So that is the reason you cannot use it for urban population. You can ask me what is the function of this adjustable telescopic tube. See, initially the head loss is very less, even 10 to 15 centimeter. Eventually the head loss increases. If the head loss will increase, it will affect the discharge. So this tube you can adjust it in such a manner, you can see it, so that you get a constant amount of discharge. So for getting the constant amount of discharge, irrespective of the head loss, you have this adjustable telescopic tube. Okay, the moment you see that the head loss is 0.7 to 0.8 times the depth of the sand, you need to clean this. Okay, generally in 1 to 3 months you clean it. What is cleaning? Nothing to be done. Remove 1.5 to 3 centimeter of the top layer. That's it. Remove that. Your filter is clean, but you don't use it for 1-2 days. Why? Because you give time for the development of smudge stack layer to be formed. Okay, so you don't use it, you give time for the smudge stack layer to be formed initially, and you clean it 1 or 3 months after that when the head loss becomes 0.7 to 0.8 times the depth of the filter media, that is the depth of sand. Then you clean it. Just remove 1.5 to 3 centimeter of the top layer of sand, ma'am. Why that? Because that was a finer sand. So the impurities is even finer than that. So the maximum amount of impurities are trapped only on the top 1.5 to 3 centimeter layer. So that's why I remove that. But you won't put extra sand. No, you don't do that. Only you just remove it. This is the process of slow sand gravity filter. Cleaning I told you, na? Cleaning I told you right now. Okay. Now, this is conventional. If they say you, they don't mention the number of filters, this is for conventional. If the area is 20 to 20 meters. Take it. If it is less than 20 meters square, 2 is required. Generally, 1 plus 1 means 1 is operational, 1 is standby. 20 to 249 meters square of area, 3, 2 operational, 1 standby. Standby is always needed so that in case of any operational malfunctioning, anything it happens, so there should be 1 extra filter unit. Okay? Any doubts till here? Any doubts till here? Fast. Then we have rapids and then disinfection. That's it, guys. Quickly. Any doubts? My head gets stuck. Okay. Now, you guys are not hungry now? Are you guys hungry? No, right? Okay. Fine. So, rapid sand filter, if I talk about rapid sand filter, Girish is hungry. Then you have to be hungry till we complete. I want that distribution we should complete so that when we come to the wastewater characteristics, we'll come after half an hour, we come with a fresh mood. But let's see how much we'll able to do it. Okay. So this is the schematic diagram which you can see a section of it. Simple, you can see here the walls are being provided. Simple. One more thing. In the case of slow sand filter, water comes from raw water or the plain sedimented water. Why we don't use coagulation aided sedimented water? Otherwise, the voids of the filter pores will get clogged. That's the reason we don't use it. But for rapid sand filters, you can use any water you want. Okay, generally we use coagulated aided sedimented water. Now what is happening? From wall 1, the water will go. Okay, wall 1 is open, wall 4 is open. It will go again, same amount of water is to be maintained as the depth of the sand. Everything is same with water 4, it will go to the disinfection unit. Everything was going. Here, the size of the particles of sand or the uniformity coefficient is poorer as compared to the slow sand filter. Ma'am, then why we are using it? Because we will go for disinfection. After this, we are not giving you the water to drink. We will go for disinfection. So no matters if it happens so. Secondly, if you talk about what you will see it here, mechanical staining, sedimentation, biological changes, electrolytic action, all will be taking place. Eventually, here you will get that you have to clean the filter more often. More often means 1 to 2 days, 24 to 48 hours, you have to clean the filters. When you will be cleaning the filter, what you have to do is, you have to close 1 and 4. This wall will be closed. And what are the walls will be opening is 5, 6 and 4. So now what happens? Whenever you will do the cleaning, you do it with the clear water. That is, but obviously you do it with the clear water. So what is happening is, when you do it with the clear water, here is certain amount of filtered water is stored and an air compressor is provided. When in some places where you cannot maintain the storage tank, you need to supply with air compressor unit. Okay, so it's not everywhere it is mandatory. In those conditions, you have to supply air compressor. What will happen? From here, you will bring the water, okay, back. Right now, it was going from top to bottom. Now, for cleaning, the water will go from bottom to top. So now, this water will goes along with compressed air. So what it will do? It will expand the filter bed. It will expand the filter bed. But the filter bed should not expand more than 50%. Okay, so now when the filter bed particles will expand, the impurities will be set free. The water is being passed through it. These impurities, these are the wash water troughs. These are collected over here. From here, it goes into the wash water gutter. Okay, as simple as that, it goes in this manner. Okay, so now you are doing backwashing. You are doing backwashing so that the impurities which are entrapped, they can be removed. That's it. Simple as that. Now, over the time, after it takes around 30 minutes time. If in the question it is not telling you anything about backwashing, don't take it. But if it is telling you deliberately, you have to take it. Okay, this whole process requires 30 minutes of time. Eventually, after this backwashing is done, you do not use the water because certain impurities can still be present. So you will open wall number 1, but this time you will open what? You will open wall number, which wall? The water will come, but this time it will go what? It will go through wall number 3. Wall number 3, it will go into the wash water gutter. So you won't take it to the disinfection unit. It will pass through the lateral drains and all, but this time it will not go through here. It will go to wash water gutter. It will go to the wash water gutter. Okay. So make sure this whole time. And during this process, when you passed it, you gave the time. Who was asking me, na, see here we don't give much amount of time for the formation of smudge deck layer. So that is the reason the efficiency is not much as compared to that of slow sand filters, and that is the reason it is mandatory to do disinfection after rapid sand filter. However, the rate of filtration is 3000 to 6000 liter per hour per meter square. So it is 15 to 30 times more as compared to slow sand gravity filters, and that is the reason we use RSF. Clear? This is the whole procedure which you need to follow. Last, if when you are expanding it, this is the formula, the head loss which happens. This is the formula D1 minus N G minus 1. In some books, instead of D, they write L. So this is the depth of the filter media, N is the porosity, G is the specific gravity. If you expand it also, the head loss remains to be the same. So this is the formula. And this is very important. This one is important and this one is important. So the expanded porosity, it will come out to be VBVS to the power 0.22. This is the expanded porosity which you will get. Okay, this is the empirical formula. Now guys, solve this question. ईयर पिन करने लगा, हेडफोन लगाए. क्यों लगाते हो हेडफोन? इतनी गंदी है क्या मेरी आवाज अरुण? हेडफोन क्यों लगाते हो यार? ऐसी नॉर्मल सुना करो, कान खराब हो जाएंगे. चलो ये क्वेश्चन सॉल्व कर दो. मैं तो कभी नहीं यूज करती ईयरफोन. बात करते टाइम भी मैं तो ईयर में भी नहीं लगाती फोन, लाउड स्पीकर में. नमस्ते श्रवण जी. चलिए इस क्वेश्चन को सॉल्व करना है. रैपिड सैंड फिल्टर दिया है 2,75,000 लोगों के लिए, पानी ट्रीट करना है 200 LPCD. कमन गाइस, मैं मान के चलती हूँ मैक्सिमम डेली डिमांड के लिए डिजाइन करना है. यहाँ पे लिखा नहीं है, मैं लिख भी देती हूँ मैक्सिमम डेली डिमांड के लिए करना है. चलो लाइब्रेरी में हो. अच्छा अच्छा अच्छा. So 1.8 times 275,200 LPCD. How much it is coming? थोड़ा सा रुक जाओ अरुण, 3 o'clock तक मैं दे दूंगी. 200. This comes out to be 99 ml. But 5% more water is required. So if you want to clean it, you will clean it with what? Clear water only, filtered water. So 5% of it is required. So this will become 99 into 1.05. This will come out to be how much? This will come out to be 103.95 mld. Now what it is telling me in the question, what it is telling me, it is asking me to calculate the number of filters required for treating water with one standby. So first of all, this much amount of water is required and rate of filtration is also given to you. So the total number of 103.95 into 10 raised to power 6 liters. But the filter is operating for how many hours? 23.5 hours. Why? Because 30 minutes it was being cleaned. So that time water was not being filtered. And what is the rate of filtration? 15 meter cube per meter square per hour. So from here, convert liters into meter cube. You will get the total area of the filters. How much is the total area coming? How much is the total area coming? Total area I'm asking. Total plan area. Is it coming 295 meters square? Just check it out. So if one area, surface area of one filter is 14 meters square and the plan area is 295. So how many number of filters will be there? 295 divided by 40. 295 divided by 40. Let's multiply it. It comes out to be 7.375. So we will take it as 8. So the total number of filters will be 8 plus 1 because 1 will be as standby. So 9 filters are there. What it is asking you, calculate the head loss. So it is asking you to calculate the head loss also. Head loss is D 1 minus N G minus 1. So 2.5 minus 1 to expand the bed to 0.66 meters from its original 0.6 meters. Porosity is mentioned. Very simple. Nothing to do. Simply calculate the head loss. Nothing to do. Head loss which is required to expand the bed, it is given. Simply you can do it. 295. Previous answer you are giving. This one is coming out to be 0.45 meter. In this question, it can ask you some things like expanded porosity. So if it asks you expanded porosity, you can calculate that also. Ne is equal to Vb by Vs to the power 0.22. Remember settling velocity. Remember settling velocity in the case of rapid sand filter is transitional in nature. So the formula which you get it here for settling velocity is 4 by 3 Gs minus 1 Gd upon Cd. This is the formula of settling velocity which you use. Here the flow is not at all laminar, it is transitional in nature. Okay, so if it is asked, you can go by this. Simple. And expanded porosity, you will go by this formula. D1 minus N, G minus 1, D dash 1 minus N dash, G minus. So I told you two things, but if they'll ask you any other thing, you should be able to solve it. Clear? This whole concept is clear? Tell me fast. Now we have reached to the last topic, disinfection. Okay. Now, technically there are two things. One is disinfection and the other one is sterilization. The process of killing disease-causing microorganisms, that is pathogens, it is known as disinfection. Sterilization is the process of killing all types of microorganisms. All types of microorganisms is killed based on sterilization, and disease-causing microorganisms are killed based on disinfection. The velocity formula is here the flow is transitional in nature. That's why you will use this. Okay, you will use this formula, Girish. Now, technically, can you tell me, is it possible? You tell me. Okay, you are disease causing, I will kill you. You are disease causing, I will kill you. Is it possible that we apply any chemical and it will only kill disease causing microorganisms? Is it possible? CD is coefficient of drag. We have formula 24 Re plus 3 Re by half. That formula. CD is coefficient of drag. Is it possible, guys? No. So technically what happens? All types of microorganisms are killed. So in the process of sterilization, disinfection happens. It's not possible that we can check it out or what is the disease causing microorganisms and we'll kill that. No, it doesn't happen like this. So in the process of sterilization, disinfection happens. Now there are various type of things. You can add ozone, you can add KMNO4, n types of things are there, but we go for chlorine. Why? Because you need two things. It should kill the present existing microorganisms and it should take care of future recontamination. So if you do boiling, first of all, it requires lots of fuel. It does not safeguard against future recontamination. UV rays also, it does not safeguard against future recontamination also. Ozone you know, ozone is O2 plus O. This nascent oxygen is a strong oxidizing agent. It kills the existing microorganisms. It is costly in Chandigarh and all you use this, but on prominent basis you don't use it. Okay, so basically we go for Cl2, that is chlorine. Now This chlorine will function only when the pH is greater than 5. If it is less than 5, it will remain as it is as molecular chlorine. So if you want it to function, you have to provide the pH of water more than 5. And you know also the pH which is permitted as per the codal provision is 7 to 8.5. That means in that pH chlorine will function. So it will form hypochlorous acid, and hypochlorous acid, when the pH is greater than 8, it will form hypochlorite ion. Hypochlorous acid is 80 times more destructive than the hypochlorite ion. So that means it quickly reacts. Now, if you want the present existing microorganisms to be killed, then we go for chlorine. In that, HOCl is responsible for present killing of the bacteria or the any microorganisms. For future recontamination, if you want, silver and all also we don't use it. We don't go for silver, copper and all because sometimes it becomes toxic. We don't go for acids and alkali because if you want acids to be used, the pH should be less than 3. If you want the alkalis to be used, the pH is greater than 11. So technically that is not the pH permissible by the government. And remember, disinfection is the last treatment. After this, you cannot do anything. After this, water is supplied to the homes. So last treatment, so you have to make sure of the pH and all also. Now, for preventing against future recontamination, there is ammonia which is present, NH3. It reacts and forms chloroamides. So it reacts, it's from monochloroamine. Again, it reacts with chlorine, it forms dichloroamine. This is pH is very important. Reversible reaction, you know the sign, right? It is reversible reaction. So it will move forward or backward. That will depend upon the temperature and pH. Okay. Next, coming further, if you ask me the effectiveness, the topmost is dichloramine, then monocloramine, then trichloramine. So this is responsible for preventing the water from future recontamination. Because others were not giving, other types of treatment units were not giving you this effectiveness, okay, or they were not giving you this property of future recontamination saving. That's why we go for chlorine. Now, before we do this, there is a formula which you know it properly, that is Hicks law. E to the power minus kt. N number of times questions in GATE have been asked in this topic. So whenever they ask you percentage removal, percentage killing, that is N naught minus NT. Is it? Or NT minus N naught into 100. So how much it becomes? 1 minus e to the power minus kt into 100. This is the percentage efficiency which you get. Okay. So now solve this question. This is very simple question. It has asked you to calculate the volume. Two things it has asked you. First, it has asked you find the removal of microorganisms after 5 minutes, and it has asked you the volume of that. Come on, guys. Come on, guys, fast. Fast. आया किसी का आंसर? मेरे में तो 4 मिनट का इसमें नहीं. Okay, guys, do it fastly. Just a minute, I'll be back. Got this? Answer. You guys are waiting for me to solve. See, nobody answered till now. What is this? Percentage removal. Already I told you 1 minus e to the power minus kt. So what is happening here? What is happening here? 8 mld is given. Find the removal of microorganisms after 5 minutes. Everything is given to you. What to do in this question? I don't understand. 5 minutes. So tell how much it is coming? 10.34. How it can come 10.34? Simple. 1 minus this will come out to be 68.96 beta. It is as simple as that. This is the percentage removal efficiency. Simple. Just apply the formula. Next in this question it has asked you to compute the volume of the tank required to achieve 99% of the efficiency. If it is asking you volume, that means discharge into detention time. Discharge is given to you in the question is 8 mld. What you are telling me? In this question, discharge is not mentioned or what? Take it 10 mld. 10 mld. 0.689. It has asked in terms of percentage. So it becomes 68.9. Now talking about discharge. Discharge is 10 mld. That is 10 into 10 raised to power 6 liters per day. You need only detention time. Time you can calculate because efficiency is given to you in the question this time. See, any type. This way question can be asked. Reverse question can be asked. So the efficiency is 99%. You can write 0.99. Okay. This is given to as 0.234 into T. Since if anything is there in the power, you have to go by what? You have to go by log. So 1 minus 0.99 is 0.01 e to the power minus 0.234 T. So take log on both sides. Log base is 0.01 minus 0.240 log E base E. How much it is coming? Time comes out to be how much? 50. You are telling what answer? You are telling 50. Very good, Sabrita. 19.68 minutes. Correct. So 19.68 minutes. 19.68 minutes. So convert days into minutes. 1 day is equal to 24 hours. 1 hour is equal to 60 minutes. And convert liters into meter cube. 10 raised to power minus 3 meter cube. You will get the answer. 136 correct. Very good, Devanshu. 67 meter. So this will be the volume. Simple. So such sort of questions are being asked. Okay. So with this, we complete Geotech Marathon. Already told you. With this, we complete our treatment. Shall I do distribution and then we take a break? It will take hardly 20 minutes. Shall we do it? Arun, Girish, everybody. Pratiksha. Okay. Fine. So now, lastly, in this raw water part, we have distribution and conveyance system. Distribution and conveyance system. So generally, when you lay out the distribution networks, you have dead end, gridiron, radial, and ring system. Whenever you take any distribution system, you make sure that you don't, with laying of pipes and all are there. So generally, it should be economical, laying should be cheaper. All these conditions you have to make sure. So now, this is first the dead end system. Dead end, no logic, nothing. You made your house, connect the pipe. You made your house, connect the pipe. That's it. No brain is applied. Okay. So you can see it here. There is a main pipe. Okay. And these are the sub-main pipes which is there. These sub-main pipes are there. From these sub-main pipes, you can see there are branch pipes which are there. So this is main pipe M, then sub-main pipe S, then branch pipe B. So what is happening here is, by any reason, if this pipeline goes for maintenance work or failure, this portion of people will not receive water. If outbreak of fire is there, you have only one route, so you cannot divert the flow of water also. Moreover, these are dead ends. Okay, so stagnation of water can also take place. There is no free circulation of water. So there are n number of drawbacks which you get it. Yeah, circulation of water is there, single, no brain to be applied, nothing regarding head loss, just fix it, that's it. But emergency cases, outbreak of fire, nothing it can maintain. And that is the reason dead end system is for old cities, those cities which were not properly planned, there you will see these systems. Now, you tell me which is this system? This is grid iron system. Generally, you will see it in, Chandigarh is the first planned city. So, in those planned cities and all, you see this types of things. There will be a main wall. Oh, this is cut-off wall or this is one, the grid iron system. Which one is there? This one is there. Okay. Now, what happens here? These are cut-off walls. I'll tell you about the walls. Right now, I'll tell you this gate walls are used to regulate the flow of water. Okay. So now what will happen here? Here you can see that if any case the water does not come in this position, you can divert the flow from any other positions. Okay. Laterals are there. You can adjust it in that manners. If fire outbreak is happening, you can divert the flow in that position. So all 7 drawbacks was there in the dead end system. It is eliminated in grid iron system and ring system. Okay, so ring system you go for grid iron system, and in both of the cases all the drawbacks of dead iron system was eliminated. But this process is costly. You need to calculate how much head loss will be there at each and every positions. All these things you need to do it. Moreover, if you see that large number of radial roads, you can see these number of radial roads are there. So what you can do? You can install a service reservoir here, so that the water can be provided to all these, because wherever roads are there, their sides, houses are there, you will be supplying it. So you install a distribution reservoir at the intersection. As simple as that. That's it. Now, talking about the storage capacity, see, 3 things are there: balancing storage, breakdown storage, fire storage. Fire storage, already told you. Breakdown storage, in case of failure of pumps, emergency cases, generally 25% of the total storage capacity, or 1.5 to 2 times of the average hourly supply. See, generally what happens in case of failure of pumps and all also, you get the water from the service reservoir, because for safety purpose, for all these conditions, certain amount of water is stored in the reservoir. Okay. Now, let me talk about balancing storage or equalizing storage. Balancing storage or equalizing storage is, let us suppose the supply is constant. Supply does not vary. It comes at a simple rate. It will come that, let us suppose 10 liters per minute water is to come. It will come in that minute. But like Arun said, he took a bath with 8 liters of water. So his demand was more. Some doesn't have took a bath, so their demand is less. So the demand fluctuates. So in this case, balancing storage tells you the storage in the service reservoir should be such that it should balance the variable demand by maintaining the constant supply. So here you see demand is more, supply is less. Here supply is more, demand is less. So you take a mod of it, mod A plus B. That means maximum depletion plus maximum accumulation. Accumulation will happen when supply will be more. Depletion will happen when demand is more. Okay. So this you have to balance the variable demand against the constant supply of water. Now, this names you should know after this. Whenever you want to detect leaks and all, if you see a sand is there and you see wetness is there, you can clearly say that, yeah, here leakage of pipe has happened. Or there are ways detecting, meters and all are there, sounding rods are there, which will tell you that if sounds comes, that means the leakage is taking place. So these names you should know in case they ask you. Very cold weather, and that then too you bath with 8 buckets of water. Hats off, Arun. Okay. So these are the pipe appearances. Maximum 4-5 appearances are there which you need to remember, which is very much important. That's it. First is gate valve. See, very, very important. I'll tell you, remember the alternative names of it. They can ask you in 1 marks question. Don't lose it. This is cut short. They can ask you in match the following. They can ask you in any way. Sluice valve, gate valve, or you call it as cutoff valve. The function of it is to regulate the flow of water. These are manually operated. Secondly, these are placed on the summit point, that is the crest point. Okay, the topmost point. Ma'am, why they are placed at the topmost point? Because the pressure at that position is very late. Prem, how could I know? यहाँ देख लो ना. ठीक है, the pressure at top point is less. Moreover, whenever the proper regulation is not happening, whenever water hammer effects happens, this gate valve prevents the pipe from it. Next is air valve. Now two things are there. Air valve is placed on both the sides of the gate valve. Air relief valve is there and air inlet valve is there. Both valves are there. So can you tell me this is air inlet valve or air relief valve? Air inlet valve is there or air relief valve is there? Good afternoon, Abhinav sir. Abhinav sir is also there. Yes, sir's lecture is tomorrow at 10 a.m. Geotechnical lecture. Air inlet valve or air relief valve? Guys, we have two valves, right? Air inlet valve or air relief valve? Inlet or relief? Guys, fast. I'll tell you first the difference between the two so that you can tell me the correct one. See, now we design the water for the pressure of pipe. Okay, for the pressure of pipe, basically we design the pipe for the pressure of water. I said the opposite. So we design the pipe for the pressure of water. We never design it for air. So now what happens? Now what happens is, by any reason, if you see that the water or the pressure inside the pipe falls below a certain predetermined value for which you have designed it. So if the pressure in the pipe falls below a certain predetermined pressure, then, or you can say, a negative pressure is created. So in case a negative pressure is created, what you need to do? You have to bring the atmospheric air pressure into the pipe so that that negative pressure can be compensated. Okay, if it is not done, then crushing failure will take place. Now coming to air relief valve. If pressure of air in the pipe is more than the predetermined value of the pressure, and if you don't remove that pressure, bursting of pipe can take place. And that is the reason you need to provide air relief valve. Relief valve is for the release of pressure, air inlet valve for bringing the air into the pipe. Because if negative pressure is there, vacuum will be there, crushing failure can take place. Clear? So this you should know. Okay? Okay. Now coming last one is second last one is cover valve, blow off valve or drain valve. What happens in this case is, this air valve and air inlet valve is mechanically operated, or you can say they are automatically operated. Okay, you don't have to measure it each time. They know how to adjust it, how to bring the air, how to remove it. It's what? Negative gauge pressure. Negative gauge pressure is for the case of when air inlet it happens. For compensating that negative pressure, air has to enter. Otherwise, crushing failure will take place. Now, blow off on drain valve, this is manually operated. Whenever the suspended solids have deposited and you need to clean that, you will stop the valve so that you will open this valve so that the water comes and it carries suspended solids with itself. Okay, so this blow off valve, drain valve or scour valve, all the names you should know, synonyms they are. Okay, last coming is pressure valve. These are also placed on the summit points. Here they are placed pressure valve. Pressure valve is if the pressure of water falls above a certain or basically it goes above a certain predetermined value. So that is the reason for relieving the pressure of water you need it. So that is the pressure relief valve. It's not mentioned it here. So this is the pressure relief valve. So five valves which are very much important. And let me tell you, butterfly valve and globe valve, they also have the same function of regulation of water, but the only difference is their functioning is different, but the thing is same. Okay. And one more valve is that check valve, or you call it as non-returning valve. Check valve, non-returning valve is, let us suppose there is pump is there and here you are supplying water. So these valves are installed in these places so that when you stop the pump, the backflow of water in the pump does not take place. So check valve, non-returning valve to allow the flow in unidirectional, gate valve for regulating the flow of water, air inlet and air relief valve I already told you, pressure valve if the pressure of water is more than a certain predetermined value, then you provide pressure relief. Clear? Pressure relief valve, air inlet valve, air relief valve, these are automatically operated while blow off valve is manually operated. Clear? Understood this much? So this is the schedule which already told you, control water and marathon class of Sir tomorrow. So wastewater, shall we continue or you require a break? Diksha, Prem, Arun, break or shall we continue? Tell me fast. How can Varun eat in the library then? Okay. You will not eat food. Okay, fine. Break. Okay. Break. How much time? First promise me, then you will come. Otherwise, see, the students get reduced when you take the break. Promise me and tell me the time. First promise and tell me the time when you will be back. Because wastewater disposal, everything is remaining. How much? 30 minutes. So it's 2:40. नहीं नहीं ऐसा मत बोलो 3:30 2:50 ना हाउ मच 3:30 चलो मेरा यही खराब कर दिया है fine okay so you guys promised me so we'll meet and now after this we'll complete whole wastewater so if you want take a power nap also of 10-15 minutes hello Navneet okay so we'll meet at 3:30 p.m. Fine guys. No. Good evening, everyone. So, Geotech Marathon right after this tomorrow. Shall we start? Speed plus ma'am. Okay, fine. Fast, fast, fast. Okay. Hello, Shears. Swapnil back. Fine. Okay, then. We'll be talking about wastewater characteristics. Ready, everybody? So, initially, till now, we did regarding the raw water engineering. Now, we'll be talking about wastewater engineering. When you talk about wastewater engineering, right now, before that, you were talking source to the community. This was the whole process was known as raw water engineering, RWE. Now, what happens, the waste, the water which was supplied to your homes, eventually you will use it for drinking, cooking, washing and all those things. So that water will convert into wastewater. So that wastewater from the community, after being treated, when it is discharged to the source, this whole engineering now we will be talking about will be the wastewater engineering. So this engineering will be now wastewater engineering. Okay, so that's wastewater engineering we'll be talking about. Now, technically, there is a slight difference between sewage and wastewater, but on basis we take it as same. Now, what we understand by the word sewage, when you talk about sewage, it consists of 99.9% of water and 0.1% of solid. So when you talk about sewage, it is a mixture of water and liquid waste which is generated upon different activities. Okay, if it is generated due to domestic activities, you will call it as domestic sewage. If it is generated due to industrial activities, you will call it as industrial sewage. Now, if it is generated, because what happens if you see this diagram, what happens, rainfall occurs, okay, rainfall occurs, so certain amount of water infiltrate, certain amount of water go into the ditches, some amount of water goes into the rivers, some amount of water gets stuck in the trees and all. So after all this water, the amount of water which get drains, okay, and which you can see it, Okay, that water is known as runoff. So that amount of water which drains from the streets and all, after all the losses has been satisfied, that is known as runoff, or you call it as drainage. So that is what drainage or runoff. Technically, they say that domestic sewage plus industrial sewage is known as sanitary sewage. Sanitary sewage. Now coming up further, talking about sewers. Some people call it as sewers, whatsoever pronunciation. I just call it as sewers. Now, sewers are nothing. They are pipe, or technically in a fashionable manner, you call it as conduit, whatsoever you want to say. So these sewers are generally pipes or conduits which carry the sewage from one place to another place. Now, sewerage system, the whole system of collecting, treating and disposing it. This whole system is known as what? Sewage system. So the whole process of collecting it, treating it and then discharging it to the rivers and all everywhere, that is known as the sewerage system. Okay. Now, the question comes when you talk about it, when you talk about the various types of sewerage system. Before that, let's talk about the physical parameters of this sewage. When you talk about the physical water quality parameter, the measurement of solids which is present in the sewage is exactly same as you have studied. Okay, so whatsoever test and all which you have studied in the raw water, exactly it is the same. Turbidity, same. Talking about color, so this has been asked, the fresh sewage, if the sewage is fresh, it is yellow or you can say light brown. Over the time, the sewage color becomes black or you can say grey or you can say dark brown. So when the color of it becomes black or it becomes dark brown, it becomes septic and acidic. The sewage becomes septic and acidic. Clear? So initially, if it is yellow or light brown in color, it is fresh sewage. Afterwards, when it starts to become black or dark brown, so basically it has become septic and now it is acidic. Clear? So this you should know, they can ask you in 1 mark. Taste and odor, so I guess you can say, yeah. Initially, the odor, when it is there, it is odorless. When it is generated sewage, it is odorless. Over the time, you will see that because of the oxygen being exhausted, H2S gas liberation and all will take place. So it becomes a pungent smell or you can call it as the rotten egg smell. Temperature, again, with every 10 degrees Celsius rise in temperature, the biological activity will double. So all these are the physical parameters. Yeah, black, dark brown, grey. Correct. So all these are the physical parameters. Now, if you talk about solids, here we have 4 categories. I'll tell you. All the things will get enhanced. How? There you studied in raw water 2 types of screens. Excuse me. 2 types of screens. Fine screens, coarse screens. Wastewater you will study medium, fine, coarse. In raw water you studied 1 sedimentation tank. In wastewater there will be 2 sedimentation tank. In solids portion in raw water you studied only 3 types. Here you will study settlable solids. What are the other types of solids, guys? What are the other types of solids? Settlable, and 3 already I told you fast. Settlable solids, 3 more. Suspended solids, colloidal solids, dissolved solids. Now, let me tell you few things. I didn't told you that time regarding settlable solids, and I told you I'll tell you in wastewater part. If you want to measure settlable solids, no need to apply any brain. There is a hem of cone. This is sort of cone is there. And here calibrations are being marked. So here calibrations are being marked. Like this. So this is a hem of cone. Nothing to do. Don't apply your brain. Take the sewage sample, put it in this hem of cone. And you just wait for 2 hours. What will happen? Whatsoever solids are there which have the tendency of settling, they will settle in this hem of cone. They will settle in this hem of cone, and you will measure it. Directly you will come to know the concentration. Why? Because here also you have done calibration. You have related to unknown parameters. That's it. Clear, everybody? And if you want to know the dimension, this is 10 micrometer. This is 1 micrometer. This is 10. I have written this is 10. Just a minute. Right. This is 1 micrometer. This is 1 to 10 raised to power minus 3, and this is 10 raised to power minus 3. So in case if they ask you, you should know this. Everything is in micrometer, greater than micrometer. This is also micrometer. Clear? So this you should know. This is regarding the dissolved solids, suspended solids. If ever they ask in match the following and all, you should know this. These are the types of solids which they can ask. Fine. Now, coming further regarding the chemical water quality parameter. Talking about the chemical dissolved hem of time. Okay. Now, understand this very carefully. When you talked about dissolved oxygen, you know you have memorized it or you have studied a number of times that the minimum oxygen required for the survival of fishes is 4 mg per liter. Leave that. Right now, I'll tell you one thing, DO saturated, which you call it as saturation dissolved oxygen. Now, listen to it very carefully. Saturation dissolved oxygen, maximum quantity of oxygen that is practically dissolved in water at a given temperature. That means at 20 degrees Celsius, if I say that DO saturated is 9.2 mg per liter, that means that anything can happen. Maximum at 20 degrees Celsius, it can be less than 9.2 mg per liter, but the maximum quantity of dissolved oxygen which can be present at that temperature in that water is 9.2 mg per liter. So that is the maximum quantity of oxygen that is present in water at a particular temperature is known as DO saturated. Yes, it is temperature dependent. If you change the temperature, the dissolved oxygen changes. With the increase in temperature, the solubility of dissolved oxygen decreases as per Henry's law. As per Henry's law. Okay? So, increasing the temperature, DO saturated decreases. Now, how will I come to know that organic matter is present? Now tell me, in water, DO saturated should be there. Okay, there should be the oxygen present. But at any time, the oxygen present is D. Okay, this is the oxygen which is present. So if I subtract DO, let me talk dissolved oxygen. This will tell me the deficiency. How much deficiency is there? How much deficiency of oxygen is there? If deficiency of oxygen comes out, this should be present, and this is the current dissolved oxygen which is present. Dissolved oxygen present at any time t. So when you will subtract this, you will come to know the deficiency. If there is deficiency is directly related to organic matter. More the deficiency, more the organic matter. Why, ma'am? Why? Why the oxygen is deficient? Because microorganisms is using that oxygen. Why microorganisms is using? Because it want to carry out the decomposition of organic matter. To be precise, biodegradable organic. So more the deficiency, more is the concentration of organic matter. Now, coming up next, chemical oxygen demand. Chemical oxygen demand is the total quantity of oxygen required total quantity of oxygen required for the decomposition of biodegradable as well as non-biodegradable organic matter. Now let me tell you some things which are truth. Non-biodegradable organic matter. First of all, this is just a demand which we are calculating. In practical, when you go in the treatment plant, you don't apply chemicals. Why? Because when you are applying chemicals, you are spending money on that. But you can say the advantage is when you leave it for the microorganisms for carrying out the decomposition of organic matter, firstly it is time taking. Okay. Secondly is basically you have to maintain ambient conditions and all, that's okay. But when you use chemical, biodegradable organic matter as well as non-biodegradable organic matter, both will be decomposed. But if you go by the microorganisms, generally they carry out the decomposition of only biodegradable organic matter. So, ma'am, if so much are the benefits of COD, why we are using not COD, why we don't use chemicals? Because beta, it requires money. Moreover, this water we are not going to drink it. Ultimately, after treatment also, you will be disposing the water. So it's not that you will add chemical, the water will become fit and you will drink it. It's not going to happen like that. Okay. So ultimately what will be happening? You will be disposing it. So that is the reason what you have to do. Chemical oxygen demand, biodegradable as well as non-biodegradable organic matter. How much oxygen is required, that you will check it out. Okay. Now guys, tell me, do you want that I should tell you, it's not asked, but if you say I'll write it for you guys. Do you want the test to be also told to you, that dichromate demand test? If you will say, I'll do it. Fast. Yes or no? No, not needed. Okay, fine. So basically, not needed, no? Okay, fine. One thing I'll tell you. Okay, one thing I'll tell you. If they can ask you in MSQ questions, technically chemical oxygen demand is known as dichromate demand test. This you should know. Okay. Here you use K2Cr2O7. So it is known as dichromate demand test. Firstly. Secondly, what happens? These are called statement wise. So I'm telling you the important things. Secondly, what happens? What I said, the amount of oxygen required for the decomposition of biodegradable as well as non-biodegradable organic matter. But when you add dichromate, K2Cr2O7, when you add it, it not only decomposes biodegradable as non-biodegradable, it also decomposes inorganic matter. So that is the reason we say in normal COD test, but beta, it is not a COD test. It is a dichromate demand test, because along with organic matter, inorganic matter is being decomposed. But organic matter is not completely decomposed. So don't get confused. We say COD is oxygen required for the decomposition of total organic matter. That means biodegradable and non-biodegradable. Plus oxygen required for inorganic matter. Then I also told you that organic matter is not completely oxidized or not completely decomposed. So that is the reason it is known as dichromate demand test. Okay. Now coming further, the next test is theoretical oxygen demand test. Now what happens, this is theoretical in nature, doing it in pen and paper. Nothing practical, no experiments, nothing. So when you go by theoretical oxygen test, if you know the type of organic matter, if you know the concentration of organic matter, then go to this test. Okay. So if the type and concentration of organic matter is known. Why? Because on pen and paper, you assume that complete decomposition of organic matter has taken place, which in practical has not. So if you know the type and concentration of organic matter, how much demand of oxygen is required, that is known as theoretical oxygen demand. Now, I'll tell you here only. This type of question has been asked in your gate. So C6H12O6 plus 6O2. This will give you 6CO2 plus 6H2O. So let us suppose we say if 180 grams of glucose requires 6 into 32 grams of oxygen. So in the question it will give you, let us suppose 1000 mg per liter of glucose will require how much oxygen. So that will be termed as theoretical oxygen demand. You know the type of organic matter, it is glucose. The concentration also you know 1000 mg per liter. So if the type and concentration is known, you can calculate theoretical oxygen. Simple. Very, very simple. Okay. Now coming further to the very important, that is biochemical oxygen demand, which you call it as BOD. BOD is the amount of oxygen required for the decomposition of biodegradable organic matter. Remember, the amount of oxygen required, to be precise, who requires oxygen? Aerobic microorganisms. So the amount of oxygen required by aerobic microorganisms for the decomposition of biodegradable organic matter is known as biochemical oxygen demand. In short, we call it as BOD. Now, if you want this oxygen demand to be calculated, you need three things. If you want BOD, you need organic matter, you need microorganisms, you need oxygen. Ma'am, if oxygen is not present, you will add oxygen. Ma'am, if microorganisms is not present, you will bring microorganisms from other plant and you will add it. Okay, so this you have to do it. Now coming further, three cases are there. Generally, the third case is not asked till now. So basically, we'll do two cases. If you want, we'll do the third case also. But most prominent, one case is asked out of this three cases. Okay, now. First case is, let us suppose case 1 is when organic matter is there, microorganisms is there and oxygen all are present. So what you will do is, you will take the sample, you will measure the initial dissolved oxygen. Ma'am, how do we measure? There is a test known as Winkler's method. Okay, generally firstly, for a remembering purpose, I used to remember like wrinklers. So it's Winkler's but. So you can measure the dissolved oxygen initial by Winkler's method. You will put it in this incubator. You can see this incubator, right? You will put it in this incubator for 5 days, 20 degrees Celsius. And after 5 days, you will take it out and you will check. After 5 days, you will check it out the dissolved oxygen final. So you will say, since you incubated for 5 days, I told you, here you are totally dependent on microorganisms. For microorganisms, temperature and days are very, very important. So BOD for 5 days at 20 degrees Celsius is DO initial minus DO final. In this case, microorganisms was there, organic matter was there, oxygen was there. So this was the first case. Now let us suppose, what is happening? Organic matter is there, microorganisms is there, but oxygen is absent. Now how you will do? Now, how you will come that oxygen is absent? Or second, the oxygen is not present in sufficient quantity. In the same case, let us suppose you conducted the test and you found that dissolved oxygen final comes out to be 0. In this case, you cannot do that. This experiment will become wrong. Why? Because you took the sample out after 5 days and you found that the dissolved oxygen final is 0. But it might happen that on the second day, the entire oxygen was being used. On the very first day, the entire oxygen is used. But you are telling the wrong thing. You are reporting it as 5 days BOD, but it might be possible that the BOD would have been of different day. So that is the reason when you get dissolved oxygen final as 0, this pattern question has been asked in your gate. You don't consider that reading. That reading is wrong. That reading is eliminated. So ma'am, if such condition happens, if O2 is absent or is it not present in sufficient quantity, then you need to add O2. How you will add? You will take a distilled water which is fully saturated with oxygen. Fully saturated means if it is at 20 degrees Celsius, the oxygen which should be present is 9.2 mg per liter. It should not contain any organic matter. Why? If organic matter will be there, so in that also microorganisms will be there, in that also oxygen will be used. So it should be distilled water. It should not have there's a huge gap between what is taught and what you have to execute it because in urban infra so do more internship rather than just okay. Okay, Harish, they will do it. That's true. Whenever you study theory, whenever you do practical, there is lots of difference. As I also told you, when you do it here, you do it by geometric mean method of population forecasting. When you'll go there, you will do arithmetic mean method. Already they know. My students already know. I don't think that they need your advice for this purpose. Yes, yes. BOD 5 is removed, oxygen or remaining 5 day. Always I get confused. That point also I'll take it out. Okay. So Harish, thanks, but no thanks. Okay. So when you talk about wastewater, as I told you, you take that water which is fully saturated with oxygen, okay, and there shouldn't be any organic matter and microorganisms present. Now, if this is the volume of the sewage, okay, it will have some dissolved oxygen, and this will be the volume of water. It will be having some dissolved oxygen. This is dissolved oxygen of sewage. This is the dissolved oxygen of water. You will mix them. So now the DO mix will become how much you can discharge. Also you can add it, or you can add it the volume here. Volume of sewage into dissolved oxygen of sewage, volume of water, dissolved oxygen of water divided by volume of sewage plus volume of water. Okay, so you will get DO mix, which is initial. Now you will put it in the incubator. After 5 days, when you take out the sample, you will get the DO final mix. So when you calculate the BOD is DO initial mix minus DO final mix. This is not the BOD of the test sample. Why? Because you added water in this. For removing water, what you have to do, you have to multiply by the, or basically for getting the BOD of the test sample, not removing, for getting the BOD of the test sample, you need to multiply by the dilution factor. And what is dilution factor? Final volume of the diluted sample divided by the initial volume of the test sample. Okay, so how much water you added? Like if I want to say, I'll say final volume is the volume of sewage plus volume of water divided by the volume of sewage. This is the dilution factor. As per the code, the BOD bottles which you take it, that is 300 ml. 300 ml is the size of the BOD bottles which you take it. Okay, so if you incubate it for 5 days, the BOD which you will get is for 5 days at 20 degrees Celsius. This will be the BOD. So generally till now in GATE examination, whichever questions have been asked, they go by this formula. That's it. Till now, the scenario has not changed. Okay. Now, as already told you, now Shears was asking, now let's go further. Why we take 5 days BOD? Generally 5 days BOD, if you want to take that, ma'am, I want to know when complete decomposition of organic matter will happen. Not even a single organic matter is there. So that will take large time. Large time means infinite time. So that decomposition will take infinite amount of time. Okay, firstly. Secondly, we go for 5 days 20 degrees Celsius because here 2 by 3 or you can say 66.67% of the decomposition of organic matter has taken place. There is a term known as ultimate BOD. Ultimate BOD is the amount of oxygen required by aerobic microorganisms for the decomposition of total biodegradable organic matter. So for this, it requires infinite time. However, ultimate BOD is independent of temperature. It remains same. Okay, it won't change whether you make it 20 degrees Celsius, 30 degrees Celsius. But there was a curve, you remember, and it was like this curve which is there, and it used to tell you that this curve, when you increase the temperature, where it will shift? It will shift to the left. Why? Because when you increase the temperature, in lesser time, decomposition of organic matter takes place. Okay, now, very important thing which maximum students get confused. Initially, organic matter is high. Eventually, when oxygen is being used, microorganisms multiply and the organic matter reduces. It doesn't become zero, it reduces. L naught, you take it or you can write it as BOD ultimate, that depends upon you. I want to calculate the value of BOD at any time t. Now you guys get confused in maximum cases whether it is asking about BOD consumed or it is asking BOD remaining. So by this graph you know that let us suppose at any time t I am talking about. So this is the BOD which is remaining. And this is the BOD which is consumed. L naught minus L. This is the consumed BOD. Okay. Now, when maximum students, when you are getting confused, let's talk about it. Yes, I agree. 2-3 points let's discuss first. In the question, sometimes they write it as BOD remaining, which is easy to understand. But sometimes they don't mention. So generally, if they say BOD 10 kilometer downstream, yes, you were getting confused now. BOD at 10 kilometer downstream. So that time it is talking about the remaining BOD. That at 10 kilometer downstream, what is the BOD which is there? Present. Present means remaining. Okay. Now, if you see the past year's papers where the sentence was not clear, that time if it's not mentioned anything, we go for BOD consumed. But if it is telling BOD remaining or it is telling at 10 kilometer downstream what's the value, then you go for BOD remaining. Clear? What does the BOD 5-day test measures? It will measure how much oxygen is required. By whom? By microorganisms. Why do microorganisms require oxygen? Because they want to carry out the decomposition of biodegradable organic matter. Okay? Because in practical, your sewage, my house sewage, everybody's sewage is treated by microorganisms. We don't go for chemical treatment, we go for biological treatment. Okay, so we want to see, ma'am, but why you want to calculate the oxygen? Because if we go for, now I'll be telling you after this treatment methods. So if you go for ASP activities, clutch process and all, there you will be the one who will be supplying oxygen. So that is the reason you are testing to know how much oxygen is required. Clear? BOD ultimate is independent of temperature. Correct. Yes. Yes, Push. Okay. So now, BOD 5 days is 2 by 3. As I already told you, there are two formulas. One is 1 minus E K to the K into T, and this is KDT. K and KD are deoxygenation rate constant. One is base E, one is base 10. Let me tell you one thing. Before, if you see before 5 years papers, in many cases they don't used to mention whether the value of K is base 10 or base 3. But since you are preparing now and since you are attempting for this time, you don't have to worry. They will give you in the question that deoxygenation rate constant is base 10 or whether it is base E. So you don't have to worry. Okay, if you see the past 90s paper, there it used to be happen. But I'll tell you a hack also. When it is 0.23, 0.22, generally it is base E. When it is 0.10, 0.11, then it is base 10. But you don't remember this because generally they will give you the deoxygenation rate constant base E or base 10. Okay. Now, dilution factor I already told you. Sometimes they say that 2% dilution is done. This is very important. So, if they write 2% dilution, okay, that means what? That means what? Let us suppose if 2 ml will be the test sample and 98 ml will be the distilled water. Okay, so this is the meaning of it. So don't need to do it. See, if you will do 2 plus 98 by 2, So ultimately what will happen? 100 by 2 it will come. So directly they have written 100 by X%. So quickly you will get the value of dilution factor. As simple as that. Okay. So this is the method. Either you can go by BOD test, or if you want to do it graphically, you will get this value. There is no need for derivation. So that's why I have directly written the formula. Come on guys, now solve this. This is a very easy question. I guess you guys can solve it. BOD by COD ratio 0. BOD COD is 0. So BOD, here it is biodegradable plus non-biodegradable. 0. So it will become 0 when biodegradable becomes 0, then also it will become 0. So wastewater is free from organic matter. No, you cannot say that. Why BTech trader? Because it might be possible that the numerator is 0. Okay, so you are saying like this, but it might be possible that some amount of non-biodegradable organic matter is present. So you can say that biodegradable organic matter is 0. You cannot say that total organic matter will not be there. Clear? Correct. Correct, Pushp. Now guys, 5 days BOD is given to you. It is asking you 8 days BOD but a different temperature. This is not a simple question because I want to tell you one thing, but I want you should solve this. See, temperature is 15 degrees Celsius. You will need to calculate the deoxygenation rate constant. But you know what? Here you will not apply 1.047. When the temperature is less than 20 degrees Celsius, when the temperature is less than, ma'am, is it correct? So it will be 1.056. Less, you will go theta, or you can call it as here T. This is the temperature coefficient. T minus 20. This you will apply temperature coefficient value 1.056 when the temperature is less than 20 degrees Celsius. So 0.23, 1.056, 15 minus 20. Come on guys, tell me. So now BOD 8 days will be BOD ultimate. 1 minus e to the power minus, how much is the value coming? How much is the value coming? 0.175. But the problem is I don't know BOD ultimate. So calculate it, no issue. $150. Arun, you calculate BOD ultimate. Push you calculate BOD. Ultimately, it will be needed only. Fine. Calculate BOD ultimate first. Calculate BOD ultimate. $219.5. Correct. Substitute it here. 219.5. 1 minus 0.175 into 8. BOD at 8 days. 165. Just 219.5. $165 mg per liter. Fine. Okay. See, if nothing is mentioned, now shears, you were getting confused now. If nothing is mentioned, it is asking you BOD 8 days. Just tell the BOD consumed. But I agree that many cases it just tells you like that. It becomes difficult to understand whether it is asking you BC. Whenever they write exerted and remaining, it becomes easy to understand. But when it is telling you like this, so better go for BOD consumed. Okay? Fine. Now, talking about here, shares, you are there. Population equivalent, if I am talking about. See, if let us suppose in your home, in your city, 1 crore amount is spent for treating the sewage. Okay. And let us suppose 10 rupees for a month I'm talking about 1 crores. And 10 rupees is required per person. And in your home, 4 persons are there. How much they have to give? 40 rupees. But how you will collect it from the industrial people? Ma'am, why? Obviously, their sewage is also getting treated, and why we will pay for their sewage? Obviously, when it comes to pay for somebody else, until and unless he or she is your girlfriend or boyfriend, you won't pay. Yes or no? You won't pay a single penny. I know that. It happens to everybody. Yes or no, Tiksha, Prashant? It happens, right? So why the hell you will pay for those industries for treating their sewage? So that is the reason this term population equivalent came into picture. Now you will see that this sewage which is generated from these industries, how much equivalent to how many people they are generating the waste. If that industry is generating sewage equal to 2000 people, how much money you will collect it from them? You, for 1% 10 rupees, and they are generating sewage equivalent to 2000 persons, so you will take 20,000 rupees from them. So how you will calculate it? This I gave you an example. How you will calculate it? You will calculate by population equivalent, that is standard BOD of the industrial sewage, okay, divided by BOD produced by per person per day. If it is not given to you in the question, it is 80 grams per capita per day. This is the BOD which is produced by per person per day. But if in the question it is giving you to take 75 grams, take that. I told you the standard BOD rate. So with the help of this, you will calculate population equivalent. This is used for the industries and all, so that the charges can be taken out from them. Okay, as simple as that. Next, coming to relative stability. Okay, relative stability. Now, in your opinion, what do you mean by stability? Just tell me. In your life, if I say that stability comes, what do you mean by stability? What do you mean by stability? What do you mean by stability? Get a government job, get a good job, anything which is stable. Okay. Here, if I talk relative stability, if I talk about, here stability means amount of oxygen required. Amount of oxygen required. The spelling, see what I have written. Relative stability. Amount of oxygen required. In which form? Any type. It can be molecular bonded oxygen. It can be normal oxygen. Amount of oxygen required. Okay. Be it molecular oxygen or molecular bonded oxygen, dissolved oxygen, divided by amount of oxygen required for first stage BOD. Remember, now let me tell you first stage BOD and second stage BOD are small things I'll tell you which is required. See, this is first stage BOD, the amount of oxygen required for the decomposition of carbonaceous organic matter. This question can be asked in your statement wise. Not this one, I'll tell you the question. First stage BOD, who attacks it? Autotrophs or heterotrophs? Autotrophs or heterotrophs? Autotrophs or heterotrophs? Heterotrophs. And second stage BOD, you call it as nitrogenous BOD, the amount of oxygen required for the decomposition of nitrogenous organic matter. And here you have what? Autotrophs. Here you have autotrophs. Heterotrophs utilizes organic carbon. Autotrophs utilizes inorganic carbon. Like in carbon dioxide, this carbon is there, that is inorganic. So how much time this autotrophs will take to utilize the carbon, in that time heterotrophs will finish its function and go. So in treatment unit, remember, our primary focus, we never design it for nitrogenous treatment. Never. We only go for carbonaceous treatment. Okay. Now, relative stability, there is a formula for it. Two formulas are there. 100. I'll write it down. You tell me whether it is correct or not. T 20 degrees Celsius, and this is 100, 1 minus 0.630 T 37 degrees Celsius. Now, T 20 degrees Celsius and 37 degrees Celsius are time required in days for the decolorization of methylene blue colored solution. Now, why this methylene blue colored solution will decolorize? Because there are certain enzymes which are present, okay, which will lead to the decolorization of methylene blue colored solution. Why these enzymes will do the decolorization? Because when oxygen is there, no issue. But as the oxygen gets exhausted, anaerobic conditions prevail, and there will be certain enzymes which will carry out the decolorization of methylene blue colored solution. Sooner the anaerobic condition develops, sooner the enzymes will come into action, sooner the decolorization will take place. So, sooner will be the instability which will come into action. If the time is less than 4 days, what you call it? Time is directly related to stability. You can say that. You can say that. You can say that. Why use KD K20 1.0546? If time is less than 4 days, the sample is declared unstable. Because Ashish, the temperature was less than 20 degrees Celsius. What you are saying, that we will use it when the temperature is 20 degrees greater than 20 degrees Celsius. Since here the temperature is 15 degrees Celsius, we use that. I told you also, beta. Okay. Okay, fine. So this completes your wastewater characteristics. Any doubt? Arun, Girish, anybody? Devanshu, Dinesh, Swapnil? Anybody? Any doubts? Any doubts? Fine. So first you studied the behavior. Now we will be talking about the designing of sewers. Okay, sewers are those pipes from which we carry the sewage from one to another. Ask me, Kishayala, ask me. So what happens? Remember, you are an engineer. Whatsoever sewer designing is done for your homes, you are the one who will be doing it. You are the one who will be doing all the connections. Government will not do it for you. Yeah, but the moment, these are the household sewers. Okay, these are the household sewers. These sewers, water will go from all the households, it will go into the lateral sewers. This is the responsibility of the government. But your home sewers, it is the responsibility of you. Government is not responsible for that. So all the household sewers gets collected to lateral sewers. Lateral sewers, you have branch sewers. MA which you are seeing, this is the manhole. Okay. From here, many number of branch sewers, it will go into the main sewers. From main sewers, it will go, this is the treatment plant. So from main sewer, the sewer which goes into the treatment plant, and from treatment plant, the sewer which goes into the disposal. Both of the sewer is known as outfall sewer. Both of them is known as outfall sewer. Why we design only for carbonaceous and not for nitrogen? Because firstly, nitrogenous, for taking the decomposition of nitrogenous, it takes time. Secondly, moreover, you will dispose it. Okay, so when you dispose it, after this we will study that chapter. So when you will dispose it, eventually by dilution and by other techniques, eventually the organic matter will be removed. And after that, that water, let us you are disposing it in rivers. You will take the water from river, and exactly the whole procedure which we dealt in the first half. again you will be doing the treatment, but that time it will be raw water treatment. So nitrogenous BOD, it takes time, so that's not our concern. Secondly, moreover, we are not drinking that water, we are just disposing it, so self purification will take. Okay, now coming next, we told you from main sewer to treatment unit to disposal, both the sewers are known as outfall sewer. Now coming next, how we design the sewers. Sewers are never designed for full flow condition. You guys know that. Why? Because anaerobic decomposition takes place. Can you tell me what are the things which are generated during anaerobic decomposition? What are the end products? Acids, alcohols, gases. Gases like methane. Let me tell you, methane is known for its high explosive tendency. Methane is known for its high explosive tendency. So that is the reason what you do, you never fill it up to the top. Okay, you fill it up to half, 2 by 3 or 3 by 4. Okay, you give a certain space for the accumulation of methane. Yeah, H2S is there, but majority concentration is for methane. You give time for the accumulation of methane. Secondly, if I come about, the next things which comes into picture, is you don't fill it full. Next is generally we prefer circular sewer. Why? If you go, you can roll this, basically when you are sewers or you can take the manholes, you will see they are circular in nature. Sewers also circular because the fluctuation in discharge, the fluctuation in velocity. I told you the meaning of fluctuation. How many times maximum value is more than the average or average value is more than the minimum. So the fluctuation comes out to be minimum for circular sewers. So you have n number of sewers, okay, but we prefer circular sewers. So generally you would have seen the concrete sewers pipelines which is laid, that is of Tata, everywhere it is going on nowadays. So they are generally circular only. Okay, now comes the next thing. Okay, one question I'll ask. The time where your demand is maximum for water, the same time the value of discharge will be maximum for lateral sewer, yes or no? I'll repeat again. The time at which your demand for water is maximum, that same point will the demand or will the amount of discharge in lateral sewer be maximum? Yes or no? I expected that answer. No. Just let example. Now in front of you, I'm drinking water. My demand is increasing. But right now I'm going to the washroom or what? When I'll go to the washroom, urination, then it will convert into sewage and after that it will go into the sewer. So remember, that time when your water demand is maximum, that time lateral sewer discharge is not maximum. And the time when lateral sewer discharge is maximum, that time branch sewer demand will not be maximum. Clear? Understood now? Everybody, understood now? You all were saying wrong, beta. No. Right now, who told me? Arun. He took a bath with 8 buckets of water. So that 8 buckets of water he bathed, that will go through the trap, it will go to the sewage. So at that moment the demand was maximum, but for lateral sewer the discharge is not maximum. Clear? But we consider 80% of what we get as supply is converted to sewage. I am asking about that instant of time, Girish. You are telling me the theoretical way of designing, beta. I am telling at that instant of time. Okay, I'm telling that time. I'm talking about the time. I'm not talking about the quantity. You are telling me the quantity and I'm talking about the time. Okay, understood? So lateral, then branch, it will take time, then main, then outfall. So it's not one time it will happen. Next, as I already told you, this is the whole depth. If you're filling it, less diameter this is the depth of flow. Okay. Now what will happen if the depth is less than 400 mm? 1 by 2, 400 to 900, 2 by 3, greater than 900, 3 by 4. This is the depth which you have to keep in mind when you do the calculations. Now remember one thing, they can ask you in 1 mark. If in the question, this is for ESE conventional, but remember this. If never ever they have mentioned which type of sewer you have to design it for branch. If this is basically for ESC conventional, but you should know that if they are not telling you that whether it is fluctuation is for lateral sewer, branch sewer, main sewer, you design it for branch sewer. Okay, and the fluctuation is 18 plus root p upon 4 plus root p. P is the population in thousands. As simple as that. Okay, now Now, self-cleansing velocity. You can see the sewer. Now, I guess you can see. You would have seen it in Hollywood and Bollywood movies also, sewers and all. Hero goes there, removes his shirt, then lifts the pipe for doing the, what you call, for stealing some jewelry, diamond jewelry and all. So, you guys would have seen the interior of sewers and all. So, now let us talk about the self-cleansing velocity of sewer. Generally, when you talk about sewers, that is an open channel flow. I already told you open channel flow does not mean it has to be open. It needs to have a free surface and it should be flowing. Flow of water takes place under the action of gravity. So that's why sewers are placed at a certain inclination. 1-2 degrees also sufficient. Okay. So that water will flow under its own weight. Here the water is the wastewater. What we do when we design the sewers, we have to maintain Spider-Man Mission Impossible, Teenage Mutant Ninja Turtles. Oh my god, now I have to see these movies. Okay, so self-cleansing velocity, when you design the sewers, you have to make sure that a certain velocity should be maintained so that whatsoever solids have already settled, they are removed and no amount of solid should settle. So self-cleansing velocity is the minimum velocity. Okay. Whenever you design the sewers, self-cleansing velocity is the minimum velocity so that the suspended solids does not settle and those solids who have settled, they should be removed. Okay. Now, there are two formulas for this. This is by Chase's method. This is by Manning's equation. So these are the formulas for self-cleansing velocity. Okay. As root over 8g by f is Chase's constant. Okay. So this is one formula. This is Manning's formula. If they will mention the value of n, Manning's roughness coefficient, you go by Manning's equation. Okay. You can write it as SS as the specific gravity or you can write it as ds. That's up to you. Okay, dp is the size of the particle which is present. Okay, so this is the formula which you should know if you want to calculate self-cleansing velocity in sewer. Now comes the next question, that if the water is flowing here, the water is flowing at full depth and the water is flowing at partial depth. Okay, so if you want to know the area for this depth of water, the perimeter for this depth of water, the hydraulic radius, how you will go? So if this is the center, you know this, right? So this is the whole alpha. So all the equations, I don't think I need to derive it. So d by d, the depth of water divided by the complete depth, that is 1 by 2, 1 minus cos alpha by 2. Similarly, area, perimeter, hydraulic radius. You can calculate each of them. Okay, even if you want, you can calculate velocity also, v by capital V. Okay, you can calculate discharge also, small q by capital Q, which will be equal to small a by capital A into small v by capital V. And if you go by Manning's equation, you know velocity is 1 by n, r to the power 2 by 3, s to the power half. So sewer is same, only the depth is changing. So what you can do? Small r by capital R to the power 2 by 3. So exactly same thing is there, but the power is 2 by 3. Okay. So this you should know. This you should know. Okay. Now let's solve this question. No, for this question to solve, I have to teach you this. Wait a minute, huh? Now, the shear stress when the sewage is flowing. See, the sewage flows under the action of gravity. So when the sewage is flowing, there will be a shear stress which will be exerted. This is the longitudinal section. The solids are also there. So what is happening? Shear stress will be exerted. Okay. So the value of shear stress, not going through the derivation, it is gamma RS. Gamma is the unit weight of sewage. R is the hydraulic radius. S is the slope. Now, if I say that this is one sewer which is flowing at any depth capital D, this is another sewer flowing at depth small d. If both the sewers have same degree of self-cleansing velocity, then the shear stress by them is same. This is capital, this is small. Gamma RS, this is, let us suppose, unit weight. This is gamma RS. If I assume, see, the unit weight of sewage is slightly more than the unit weight of water. If it 1 is for them, that is 1.02, like that is there. So this will come out to be, if I take them as same, R capital S, R small s. So this will become R by capital small r. This will become small s by capital. Okay, this will happen. Now, if you talk about the velocity, velocity will become how much? 1 by n, and this will be capital N by small n, r to the power 2 by 3, s to the power 1 by 2. Now, firstly, it is not necessary that Manning's roughness coefficient is same. ये कौन आ गया भाई? ये कौन आ गया? बीच बीच में कुछ लोग आ जाते हैं ऐसा काम करने के लिए. अब बताओ क्या करूं? अरुण, गिरीश, इन लोग का क्या करूं? बताओ. और मैं चेक करूं ना भी तो फेक आईडी रहती है. कोई बात नहीं, चलो. अब now if in the question it is telling you the Manning's roughness coefficient is same, Manning's roughness coefficient is same, then n and n will become same. In that case you will get r by r 2 by 3, and in this place small s by capital S you can write small r by capital R minus half. My minus half because r by r is there, so I just reversed it, so I wrote this. So the very important formula, very important, if Manning's roughness coefficient is same for both the sewers, this is 1 by. Clear? Very important. This you will use in this condition. If Manning's roughness coefficient is there, then that value will also come into action. Okay? This is used when both the sewers have same degree of self-cleansing capacity, velocity. Now, solve this question. This is a good question. Vishal, what a punch. Okay. Guys, solve this question. Come on. First, you have to calculate slope. Slope is very easy. You can calculate, right? R to the power 2 by 3, S to the power half. So 1 by n, 0.03. R is D by 4. The dia is given to you in the question, right? 3. Here it is asking me for full depth I am taking. If it is asking me 0.3 or 2 by 3. Slope I need to calculate. Velocity it is 0.9 meter. Full flow velocity it is telling me 0.9 meter per second. So I am calculating slope corresponding to full flow velocity. How much it is coming? Second part is interesting. Come on guys, how much it is coming? Just check it out. Is this coming? Now second part is Velocity, assuming velocity it is asking you, that means it is asking you velocity corresponding to small d. That is, it is asking you small v. How you will calculate it? How you will calculate it? You know, right now I need to calculate small v. How will I calculate it? Come on, guys. Capital V is given to me in the question, 0.9 meter per second, and it is asking me, see, it is written depth of flow is 0.3 times the full depth. So it is asking me velocity corresponding to 100 mm depth of flow. No, this is not 100. This will be 0.3 into 300. So this will be how much? 90 mm depth of flow. So how you will calculate it? Now, anybody want to give your brain how you will calculate it? Here you have to apply the concept, and they can ask this in your GATE examination. Don't you think that they can't? Small r by capital R to the power 2 by 3. Remember? I told you. And I told you small r by capital R was alpha by 360 minus sine alpha by 2 pi divided by alpha by 360. But ma'am, we don't know alpha. You can calculate it. Why? Because I know small d by capital D is half 1 minus cos alpha by 2. And small d by capital D, I know it is 0.3. Come on, guys. Arun, Tiksha, everybody calculate alpha now. So this was the question. All the 2-3 formulas they have added, summed up, and they gave you this problem. Come on, solve it. Very good. We will use it because we will use it s to the power. This will be also there. But BTech, everybody, since in the question the slope is same, they are not changing the slope. So we will do it r to the power 1 by 6. Because it is talking about the same sewer, only they are changing the depth. Or if they have taken different sewers also, but they have maintained the slope to be same. Come on, calculate alpha. Substitute it here. Good. Substitute it here and calculate the value of r. It will come out to be 0.6837. You guys can check it out. Calculations, you should check it out. Huh? So, small v will be 0.6837 to the power 1 by 6 into 0.9. How much it will come? No, you are telling 132 for that one. How much it will come? It will come out to be 0.84. So this will be the answer. Correct, Tiksha. Tiksha is very fast. Good. Good, Swapnil. Okay. So this will be the velocity. So see, this formula, this formula, this formula. 3 formulas are used for getting the value of velocity. So such sort of questions they can ask you. Okay. Now, coming further. Hydraulic equivalent section. 2 sewers are said to be hydraulic equivalent if they carry the same discharge and they are running on same slope. Okay, so the discharge is same and the slope is same, then you call it as the hydraulic equivalent section. So if this section is there, this is square and this is circle. So what you can do, the discharge is same, you will cancel the slope, and right now I'm assuming it that they are running on full depth. If they are running on full depth, hydraulic radius is wetted area by wetted perimeter. So this will be d by 4. Okay, and for this hydraulic radius will come out to be how much? A wetted area by wetted perimeter. So B into this will come out to be B square, perimeter will be 4B. So this will be B by 4. So on solving it, you will see that diameter is equal to 1.1 times of the side of the square. Okay, so they can ask you sometimes these things, so you should know that. Okay, now one thing more I'll say, this is very important. Generally, we prefer circular sewers, but why? Because the fluctuation in velocity and discharge comes out to be less. But all the benefits you will get only when the depth is more than 0.5 times the diameter or the total depth. If it is less, you won't get the benefits. That's the reason we go for X-shaped sewers. So I'm drawing it by freehand. Generally, you guys have seen sewers like this. So the upper sewer, this is D. So this will become D by 2. Okay. So generally, generally the upper sewer is used for the rainy season, and this is used under normal condition. Ma'am, why? Because beta, if you are designing a combined sewer, okay, combined sewer, I'll tell you right now, combined sewer. So in that case, what you will see, rainwater and the sanitary sewage both get mixed. Okay, so in that case, self-cleansing velocity is maintained. But when the rainfall is not taking place, self-cleansing velocity will not be maintained. That's the reason in that case you will go for this. Okay. Now, what Girish was telling, let's talk about the designing. Designing, as he already told us, let us suppose if X is the population per person's water demand and P is the population. So the total water demand comes out to be P into X. Already told you 80%, generally 70 to 80% of the water supply is taken as converted into wastewater. Two things, very important. First thing, read it in the question carefully. Whether it is written water supply or whether it is written the wastewater supply. Okay. If they are writing raw water, you have to multiply by 0.80. If they are not mentioning raw water, or if they are mentioning raw water, you have to take it 0.80. So remember, if not mentioning, or basically they have written the wastewater supply, just P into X. If they are mentioning it is the raw water, multiply by 0.80 P into X. They'll mention 70% converted, 80% converted, they mention. And you will multiply by 3. 3 is the fluctuation in branch sewer. Okay, so you multiply because you design it for peak value, so you multiply by 3. Now, coming further, here rainwater is also there because when you design combined sewerage system, there are 3 sewerage system. One is separate. In separate sewerage system, what happens? If this is the ground level, you know already all pipes are laid below it. This is the water pipe. This is the pipe for drainage. This is the pipe for sanitary sewage. So generally you will see what? That in this condition, laying of pipes is costlier. In congested roads, you cannot apply. However, the treatment is reduced because drainage water, the water from the rainfall and all, that contains inorganic particles. They won't contain organic matter. So drainage cost is reduced. In combined, what you do, this is the water pipe. You have only one pipe, both for drainage plus sanitary sewage. Okay, so in these conditions and all, you make sure that you multiply by the factor 3. Okay, but this is the water only for sanitary sewage. You want to calculate the drainage water. So the drainage, the storm water is given by the formula 1 by 36 kPCA. Remember, this is in hectares or kilometer square. This is the rainfall intensity in centimeter per hour and this is in hectares. This is the catchment area in hectares. This formula you should know. Okay, and you will get the discharge in meter cube per second. Now, critical rainfall intensity will be given to you directly. Otherwise, it is the function of time of concentration. Now, what is time of concentration? I'll tell you. If this is the main streams and the water comes from here, water comes from here. So the time taken by the last water molecule droplets to reach to the outlet, that is known as time of concentration. That is known as time of concentration. And that is equal to the time of inlet plus time of flow. Okay. When it is time of concentration is 5 to 20, 5 minutes in this range. 75 Tc plus 10. When the time of concentration is greater than 20 minutes, the critical rainfall intensity is 100 Tc plus 20. So this is the formula. सब एक दिन में कैसे करूँ? Correct, BTech trader. Correct. Okay. So this is the formula which you should know. Now coming next. Okay, fine. So this completes your design of sewers. Any doubts, guys? So no logic is there. Whenever you want to add, simple questions are being asked. If they ask you to design a combined sewer, what you will do? You will add sanitary sewage discharge and you will add this discharge. That's it. Just apply the formula. Yeah. One question which they have asked you, which you should know, is very important. Sometimes the value of K is not same. Like this A1 area, K1 is different. K1 is runoff coefficient. K3 area, A3 area, K3 is different. A4 area, K4 is different. In this case, you have to calculate equivalent runoff coefficient K1 A1, K2 A2, K3 A3. A question has been asked in GATE examination. Till now, I assume that you might have done PYQs 2 to 3 times. Weighted average, correct. सिविल 2.0 में सही हूँ. डिजाइनिंग ईएसी का बेटा, उसका न्यूमेरिकल अभी क्यों बताऊं मैं? मतलब वो तो डिजाइनिंग का पार्ट है ना, उसको अभी बताऊंगी तो वो तो गेट में नहीं आएगा. बताना है गाइस, एवरीबॉडी, डू आई हैव टू टेल? Simple formula based it is there. That's not asked here. Designing is for ESE conventional. Okay. Now talking about disposal of sewage effluent. Now, why we are starting disposal before the treatment of sewages? The reason is because how much treatment is to be given, that depends upon disposal. Example, government has specified for different states, for different union territories, it is being specified. If you are disposing on rivers, what should be the 5 days BOD? If you are disposing on seas, what should be the BOD, and so on. So disposing, when you do it, disposal can be done by two methods. Disposal by dilution, or you dispose it on land. Dilution means when you say na the acid is diluted, you might have done it H2SO4, सब लोगों का जला होगा हाथ वगैरह, everybody might have got burnt and all. Okay, so what happens? That was concentrated, and if you add water in that, what will happen? If you add water in that, it becomes diluted. Similarly, when you throw the sewage in a place, in that water body which has large volume of water, so what is called? That is known as disposal by dilution. Now, everything is mentioned to you. Whenever, these are the important points. This I have written for you. In the case it comes in an MSQ question. So, this you should know, important. Okay. When you are throwing the sewage, what will happen? Make sure that it has high concentration of dissolved oxygens. Okay, and the diluted, that water where the diluting water where you are disposing it, it should not be used for navigation purpose. Otherwise, it doesn't look good. Aesthetically, it is displeasing. Okay, and when you are throwing it, the sewage should be comparatively fresh. It should not have stale smell and all. So these are the things which you should keep in mind when you are disposing the sewage by dilution method. Now comes disposal by dilution. You can do it in rivers, lakes, seawater. Now when you do it, disposal by dilution in rivers, गिरे जो भी है आप, last time I am telling you, if you are going to do this, first of all, I'll block you out and I'll make sure by the YouTube authorities that you never ever be able to download YouTube again. I'll just track your IP address right now. पढ़ने आए हैं तो पढ़ाई करो, और नहीं पढ़ना तो आपको इस चैनल में किसी ने नहीं बुलाया, बाकी लोगों को डिस्टर्ब मत करो. दिस इज द लास्ट एंड फाइनल वार्निंग. Come on, guys. So, when you are disposing it, when you dispose by dilution method, that means you are adding water in it. Okay. So, disposal by dilution is do what? Disposal by dilution, when you do it, this is basically for river water, generally we use it. What happens here? The water purifies itself on its own. That is the self-purification ability of the rivers. So basically it takes place by four methods generally: dilution and dispersion, sunlight, sedimentation, oxidation and reduction. You can take it in a single or you can separate it and take it out. Now what happens? Dilution and dispersion are technically not the method of treatment. What you do technically, when this, if let us suppose 5 mg of suspended solids was present in 1 liters, you added 9 liters of water. Now that 5 mg is present in 10 liters. So here the concentration was 5 mg per liter. Here the concentration is 0.5 mg per liter. So what is happening? What is happening here? The concentration is reduced. That's it. The suspended solids, previously also it was 5 mg. Now also it is 5 mg. So that is dilution. Sunlight. When sunlight comes, you know, algae will prepare its food. When algae prepare its food, oxygen is liberated. That oxygen is used by microorganisms for carrying out the decomposition. So in that manner, organic matter, who were asking the nitrogenous and all, they will be getting removed now. Sedimentation, water is flowing. The turbulence is not zero, but it is flowing. So whatsoever particles which have a higher weight, they will settle down. Oxidation and reduction, chemical processes, these three are the physical forces. And this oxidation and reduction is the chemical forces with the help of which what is happening? The biodegradable or any organic matter is getting removed. Now, degree of treatment depends upon dilution factor. Let me tell you one thing important. Dilution factor, if it is greater than 500, no treatment. 300 to 5 treatment, do plain sedimentation, make sure that the suspended solids is less than 150 ppm. Then about 150 to 300. Okay, suspended solids should be less than 60 ppm and treatment is required. If the dilution factor is less than 150 ppm, you need to do complete treatment such that the BOD is less than 30 ppm. This is wrong. Can you tell me what is the correct one? This data written is wrong. The date, ma'am, if depth of river is more, how sunlight will reach to algae? First of all, BTech trader, some algae are not rooted plants, so they are present on the beds also, they are present deep inside. So that portion till where sunlight is able to receive by the algae, they'll prepare the food. Those who are not, basically the sunlight cannot penetrate, they won't be able to do it. Okay, as simple as that. This is wrong. Can anybody tell me? One of this is 20 ppm. Which one is 20 ppm, guys? Tell me fast. Next, one more thing which I'll tell you. Dilution factor, you will say, ma'am, you told us dilution factor is volume of sewage plus volume of water divided by volume of sewage. Right now you are writing discharge of sewage, discharge of river. Why? Because practically, beta, it is not possible to measure the volume of river. Can you measure the volume of river? So in that case, you measure volume per unit time. Okay? Any doubts still here? Very good. Two people answered differently. Suspended solids 30, BOD 20 and Tiksha told suspended solids 20. Which one is correct? Come on, Girish, Arun, everybody. Fast. Be confident. Okay. I wrote it, you guys told me. Fine. Now, this is very simple. Let's do it quickly. Zones of pollution. We have four zones. Zone of degradation, active decomposition, zone of recovery, zone of clear water. Initially, the water was clear. The moment you see, this is the upstream, this is the downstream side. So here you will do what? When you dispose the sewage, what you will see it, this is the zone of degradation. What you will see it in the zone of degradation, initially fishes and algae were there. Some amount of algae will die here. Okay. Now, when you throw the sewage, it has a large amount of organic matter. So when you will throw this, organic matter is there. By default, microorganisms will be there. You know na that song. जहाँ मैं जाती हूँ वहीं चले आते हो. So wherever organic matter will go, microorganisms will follow it. So wherever organic matter will go, there microorganisms will go. So what is happening is here, the moment you throw it, eventually microorganisms will start to utilize the dissolved oxygen of the river. So the dissolved oxygen value decreases, and during this process, this zone of degradation ends. When this was deosaturated, this becomes deo, 40% of deosaturated. So this will add. मैं एक गाना और तू जहां मैं वहां, हाँ, that is also correct. So wherever is organic matter, therever microorganisms will come. Okay. Now talking about zone of active decomposition. This is the also known as by the name of zone of heavy pollution. What will happen? The DO level may even fall to zero. Dark and turbid water. Fishes will also die. Okay. So eventually every maximum amount of fishes will die. The water will become dark. Eventually, slowly this will lift. Again, this zone ends 40% of deosaturated. Okay. This will lead to the zone of active decomposition. After that zone of recovery, now maximum decomposition has taken place. Now the water is becoming clearer. But remember, at no point in zone of recovery, the DO level becomes equal to deosaturated. It will be less than deosaturated. And on the fourth zone, zone of clear water, fishes, algae, all will be alive and it will reach to deosaturated. So this is the whole thing. Anaerobic respiration ho jayega. Of course, it will happen. So generally, you guys would have ever seen in the river certain place you get the black portion, you just see it. Generally, you would have noticed. So that is the zone of active decomposition. It becomes like black and turbid. That is zone of active decomposition. Okay. Now, this is mentioned for you for the theory purpose. You guys can check it out. This is for your theory purpose. Okay. Now, you told me now, at sides of river, in the between also you see it, Vamsi. Yeah. Now what happens, like I told you, in this portion it becomes like this, it rised. So technically it is divided into three zones. How? That zone of active decomposition in itself divided into three zones. How? Firstly, second, third. What happens is, you know, KR and KD, two things are there. KR is rate of reoxygenation, KD is rate of deoxygenation. What happens is, when you talk about KR rate of reoxygenation, both are going. At some point reoxygenation is more, at some point deoxygenation is more. You know, initially when you dump the sewage, what you will see, ma'am, Ganga kabhi ganga nahi hota, ye sach hai kya? Then if it doesn't have, then why do we have Ganga plan and all for see, गंदा नहीं होता पर गंदा हम करते हैं. ठीक है, वो तो नहीं होता. रिवर कभी खुद से कहाँ गंदी होती, वो तो हम करते हैं ना. Okay. Now, initially when you dump the sewage, deoxygenation rate constant is more. So you can see the deoxygenation curve is more. Eventually, over the time, when maximum demand of oxygen is satisfied by the microorganisms, Okay, they have utilized the oxygen, maximum decomposition of organic matter has taken place. This deoxygenation reduces, and the rate at which the oxygen enters into the water, it is same, but the rate is increasing. Okay, so when you take the summation of it, you will see here, you will see it here, this will come out to be DC. This DC is critical DO deficit and the time is critical time. Okay, now at any time, now this is a very special formula which you guys need to know, because in gate examination also they have asked you. Okay, now DO is the initial DO deficit. When you dump the sewage, there will be certain deficit in the dissolved oxygen. Why? Because organic matter is there. If organic matter is there, what who said na? Kishal se tum jahan main wahan. So when organic matter is there, microorganisms will come. If microorganisms will come, oxygen will reduce. If oxygen will reduce, deficiency will come. Okay. So now I want to calculate, let us suppose I want to calculate the deficiency of dissolved oxygen after 5 days, after 10 days. So you have a formula, your favorite formula, Streeter-Phelps equation. This is the formula. Streeter-Phelps equation formula is there. Kr is the Kr reoxygenation rate constant, Kd deoxygenation rate constant, D naught is initial DO deficit, which is equal to DO saturated minus DO mix. Okay, and DO mix is the DO of river, discharge of sewage, dissolved oxygen of sewage. Don't worry, I'll do a question also with it. So this is the formula, you have to remember it. I can't do it. Solve 3-4 questions, you will get it out. Now, next is the critical time. And remember, L here is not the length. Many students get confused. L is the ultimate first stage BOD. As I told you, we are not bothered about nitrogenous BOD. We are bothered about the first stage BOD. Okay. Now TC, this is a difficult formula. I'll advise you not to remember this. Okay. F is equal to Kr by Kd. This is the purification constant, self-purification constant. Don't remember this formula. Instead, remember this formula. Okay. Try to remember this formula. Now, when the time becomes equals to critical time, the deficiency becomes equal to critical DO deficiency, or you can say critical DO deficit. So this is the formula. Remember this formula, this formula. Okay, so 1, 2, and this is the 3. 3 formulas you have to remember. That's it in this disposal of sewage effluent. Okay, thank you, Sagnik. Now, as I already told you not to remember this, remember this. Why? Because in some conditions, they will ask you critical DO deficit. Understand this, very important. Huh? Some case they will ask you critical DO deficit and you don't need to calculate critical time. That is a wastage. So don't calculate using this formula. Okay. You can directly get the critical DO deficit by this. So which formula to use, that will depend upon what is given in the question. Fine. Now solve this question, guys. 2 questions are given. Solve it fastly. एक क्वेश्चन ही दोनों नाइट में ज्यादा हो जाता है. डेटा मोर इन डेटा डीओ नाइट में ज्यादा होता है, डे टाइम में. हेनरी लॉ. डीओ सैचुरेटेड डीओ तो कांस्टेंट है 9.2 mg पर लीटर 20 डिग्री सेल्सियस के लिए. जैसे जैसे टेम्परेचर बढ़ेगा, एज द टेम्परेचर इंक्रीजेस, डीओ विल रिड्यूस. तो नाइट टाइम डे टाइम वो डिपेंड कर जाता है. नाइट टाइम में टेम्परेचर कम हुआ तो डीओ भी फिर बढ़ जाएगा. ठीक है, बट कभी भी डीओ सैचुरेटेड से उस पर्टिकुलर टेम्परेचर से ज्यादा नहीं हो सकता. कम ऑन गाइस, ये तो बहुत सिंपल क्वेश्चन है. कंबाइंड डिस्चार्ज एंड ऑल, यू गाइस कैन सॉल्व इट फास्टली. अब यही क्वेश्चन फास्ट करना, क्योंकि दूसरा क्वेश्चन टाइम लेगा. 5 बज गए क्या? मुझे लगा था 5 बजे तक ये चैप्टर हो जाएगा. ओके फाइन. कंबाइंड डिस्चार्ज QR plus QS. Discharge wastewater 560. Where is the discharge? 28 meter cube per second. Convert it. Convert 28 meter cube per second into liters per second. Or 560 converted. Discharge is 28. This I'll write 0.56. It will become 28.56 meter cube per second. BOD. See, determine the flowing water after mixing of wastewater with the river water. Technically, they are writing BOD, but this is BOD mix. So this is BOD mix. Okay. Discharge of river, BOD of river. Discharge of sewage, BOD of sewage. Discharge of river plus discharge of sewage. Come on, I'll tell you. Vamsi, Girish, calculate BOD mix. Kishalya and BTech trader calculate DO mix. And who was there other? Sagnik and all calculate temperature. So guys, tell me what are the things fastly so that we can do it fast. 28, BOD is 50 mg per liter. BOD is 4 for this one. 4.56, BOD is 50. 28.56. This is only live. I think I should make it private. Discharge of river, DO of river. Discharge of sewage, DO of sewage. Discharge of river plus discharge of sewage. 28, DO 8.2. 4.9 is what? BOD mix. 4.9 mg per liter. What is DO mix? Mg. Temperature mix, I will write it here. Temperature, this is 23.56 and this is the temperature 17 and it is 28 and this is 28.56. How much is the temperature? 17.12. Clear? 8.098, that is 8.1 only. Okay. This is the second question. Then we will move towards street disposal in lakes is also left. Fine. Deal this. It is asking you find location at downstream where oxygen deficit occurs. And also find first the location it is asking you and also find the value of critical oxygen deficit. That means location it is asking you, that means it is asking you the distance and it is asking you the value also. Come on guys, how you will do? How you will do it? See, if it is asking you L by F 10 raised to power minus KD TC. That means KD is given to you in the question. Yes. You need to calculate L. F is given to you. Yes. F is given to you as 4. You need to calculate L and you need to calculate critical time. Now how you will calculate critical time? Come on guys. 1 upon KD F minus 1. Be faster. Log 1 minus F minus 1 DO naught L F. So come on, substitute it. Diksha, Swapnil, everybody solve it. KD is how much? 0.11. 4 minus 1 log base 10. 1 minus 4 minus 1. DO naught. DO naught is given to me in the question? No, not given to me in the question directly. Not given to me. Calculate DO naught also. Calculate L also. Everything we have to calculate. Lengthy question. Okay. DO naught is equal to DO saturated minus DO mix. DO saturated, one question, entire thing will be clear. Okay. DO saturated is how much? 9.2 mg per liter. DO mix already calculated how much it was? Where it is gone? 8.098, 8.1. How much it is coming? That DO mix for the previous question was for the previous question. This is different question. That's not what I was thinking. That is for different question. Here I have to calculate. See, in the question, nowhere it is given, it has taken oxygen deficit is occurring. Since nowhere it has mentioned, I will take sewage is heavily polluted. I will take dissolved oxygen of sewage as 0. And in the question it is given DO of river is 9.2. That means there is no oxygen demand in river. So BOD of river is 0. Remember this. So they won't tell you directly, you have to read between the lines. Now calculate DO mix. Come on. Discharge of river into DO of river. Why? Because discharge of sewage is 0. So no need. But fine, I'll write it here. Discharge of river plus discharge of sewage. Come on guys. What is the discharge of river? 1600. DO of river is how much? 9.2. 1600 plus 125. How much it comes out to be? This is 0 by the way. This will come out to be how much? 8.53 mg per liter. So substitute it here 8.53 mg per liter. It will come out to be how much? 0.67 mg per liter. Just check the calculations. So this is the initial DO deficit. Now what you need? You need the value of BO naught. Okay, and ultimate, or basically you call it BODU or you call it L. So ultimate BOD is 125%, or they have generally written it here. BOD ultimate is 1.25 is the BOD 5 of the mixture. So now you have to calculate 5 days BOD also. Calculate BOD of the mix. Come on guys, long things you have to do it. You won't get it easily. So BOD mix, how to calculate? Discharge BOD of discharge river, BOD of river. Now in this case, this will become 0. So this is gone. 125 into BOD of sewage is 300. 125 plus 1600. How much it is coming? This is the 5 days BOD. Just check it out once. 21.739. So 21.739. 73974. And how much it is coming? 1.25 into this. Whew, calculated so many things. Now, substitute it here. How much is DO naught? 0.67. 0.67. And how much is BOD ultimate? 27.173. 27.173. Guys, solve it. Solve it. You will get the critical time as 1.723 days. So, 27.173. F value is 4. 10 raised to power minus KD. KD is 0.11. 1.723. So from here you will get the critical DO deficit in mg per liter. How much you are getting? 4.39. So one thing you got. It is asking you the location. Location means the distance. Distance is what? Velocity into time. So the velocity of river is given to you. Velocity into time. Velocity is 0.12 meters per second. Time is given to you as 1.723 days. So 1 day 86400 seconds. Okay. Divide by 1000. You will get the answer in kilometers. So it will come out to be 17.864 kilometers. This will be the answer. Clear? Understood the whole question? Understood the whole question, everybody fast. Fine. So this was the big question. At max, they can ask you, ma'am, itna detail gate mein expected nahi hoga on your part can be asked. Yes, Girish. So instead of making every question part, I have taken a bigger question for explaining all the concepts. Okay. Now, talking about disposal in NAICS, generally we say we have many things to study. Main things we are studying. Productivity, when you talk about, the productivity means able to support food chain. Food chain means what? What is happening? What is happening? Generally, microorganisms uses oxygen. That oxygen is given by algae. Algae gives that oxygen while preparing this food, while preparing its own food. Okay, so microorganisms is attacks on the organic matter. On its decomposition, aerobic decomposition, microorganisms liberates carbonates, nitrates, sulfates. Okay, these are being used by algae as well as by the fishes and all. So this whole chain is basically the productivity. So more the concentration of algae, more is the productivity. So based on that, you have four types of lakes. One is oligotrophic lake, least productivity. That means you see it in foreign and all. Generally you see it that the lake is so pure, crystal clear. If you look, you can see your face also. Okay, so this is the case of oligotrophic. Okay, this is the case of oligotrophic. Now, mesotropic, algae will be there. Okay, deficiency of oxygen will be there, algae will be there, but intermediate level will be there. Huge quantity will not be there. Okay. First time it is in confusion. Okay, you see this question again. I had been a little fast because I thought you know that. Then you'll understand what I'm saying. Okay. Now, eutrophic lake, high level of productivity, high growth of algae is there. Okay. Generally, when you see the lake, actually there is one layer, epilimnion. This is metacline or thermolimnion, you call it, and then you have hypolimnion. See, if the lake is pure, water can penetrate, sunlight can penetrate up to hypolimnion. That is for the case of oligotrophic. But if the lake has algae and all, so what will happen? The sunlight cannot penetrate. Algae interferes with the penetration of sunlight. So what will happen in this case? The sunlight is limited only to epilimnion. Okay, and since oxygen deficiency is there, you call this eutrophic lakes as anaerobic lakes. These all can be asked in MSQ, that's why you should know. Next, senescent lakes. Lakes of highest productivity. Why? Because now they have converted into marshy land. You guys have seen it in movies and all. Dal dal. You stand there and you try to sink down. So that are the senescent lakes. Because maximum algae is there and you cannot use that water. So higher the presence of algae, poorer is the quality of water. Okay, so these four lakes, if they ask you, you should know. They'll ask you arrange the following four options they will be giving you. Highest productivity is for senescent, lowest is for oligotrophic. Okay, second last, that is eutrophication. Eutrophication, already you know what is happening in a generally the washing powder and all which you use. The prime cause of eutrophication is phosphorus. What will happen when you provide nutrients? When you provide nutrients to algae, it will grow. And moreover, if algae grows over it, the depth of water becomes shallower and shallower. Why? Because the deposition of algae is taking place. So, if you see all those green type of, we say na kai in Hindi, you know that. Kai we see in Hindi. So, पूरा काई जम जाता है, we say ना, because now that lake cannot be used. Why? Because enough quantity of algae is present, the depth has become shallower. Okay, specifically the prime cause for eutrophication is phosphorus. You get it in agricultural fertilizers, you get it in the case of nitrogen, phosphorus, sulfurs, generally phosphorus which comes from the washing powder and detergent. So if you want to that, stop, don't add that water in which phosphorus and all is there, don't allow that water in lakes, or add copper sulfate, add calcium hydroxide. This prevents the growth of algae. Otherwise, eutrophication, when excess quantity of nutrients are there, that land is full of that green algal bloom comes into picture, and that lake you cannot use it for any water supply purpose or recreational purpose at all. Okay, so this is there. Green and sometimes brown, generally green, darkish brown it happens. Okay, just see. Statement wise, they can, if they want, they can ask you. So that's why I've written it for you. Statement wise, if they can ask you, you know, seawater consists of salts. Okay, so generally we don't prefer it. Moreover, if you throw it, it can come back. So you have to go deep, like deep sea, you have to go it. You have to dispose it in low tide. So generally nowadays you don't dispose it into seas. No, it is not permitted. Land, you know that there is a farming which is done, which is known as sewage farming. Two types of thing is there. You can go for effluent irrigation, you can go for sewage farming. Okay, sewage farming, your more important funda is that you want to grow the crops. Okay, and when you talk about the effluent irrigation, you just want to dispose it. Okay, but when you are disposing it, you have to make sure that there shouldn't be a condition of sewage sickness. What is sewage sickness, ma'am? What happens when you dispose the sewage, and here any filter media, any type of media is present, what will happen? Eventually the sewage will have solids also. So this will clog the voids of the filter media or any media which is material which is present. So what will happen? The sewage has clogged the voids. So now the sewage will not able to penetrate and it will able to stand here only. So what will happen? The sewage is not able to penetrate downwards direction. It will create poison. It will create, you can say, unsanitary condition. H2S gas will be there. So it will create unsanitary condition, or you can say it will be aesthetically displeasing. And in that positions, it is very much difficult to stand also. So this is what is sewage sickness. Clear? Okay. So now this is the third last chapter, treatment of sewage. Ready everybody? Ready? After this only air pollution and solid waste management. Okay, fine. So let's talk about sewage treatment plant. Sewage treatment plant. What is happening? What is happening? The raw sewage is there. First, it is passed through the screens. Screens remove large floating matters and all. Then it is passed through commutators, macrators. Now let's go one by one. Screening, already told you, removes large floating matter. Now see, these are the diagrams. If you haven't seen, I told you that they are generally arranged in inclined manner. You guys can see it. Spacing is 50 mm more. Inclination, generally we keep it in the range of 30 to 60 degree. Medium screens, this was not there in the case of raw water. This is there for the case of wastewater. So in that, spacing is 6 to 40 mm. Angle of inclination is 50 degree to 60 degree. Fine screens, more finer than this. This is somewhat coarse medium screens. In that, spacing is 1.5 to 3 mm. And the formula already told you. Okay, this already we have discussed. Now coming to the next is commutators and macrators. Let me tell you, in actual, they does not perform the treatment function. They just reduce the size. Commutators is based on crushing and grinding action. Macrators is based on cutting and tearing action. So it just reduces the size. That's it. Its function is to reduce the size. Now, talking about grit chamber. The function of grit chamber, from here the thing starts. The function of grit chamber is removal of inorganic suspended solids. Inorganic suspended solids. Now what happens? Now what happens is, here we have four types of solids. Basically organic, suspended and dissolved, organic, suspended and dissolved, inorganic, suspended and dissolved. So first thing first which comes is, firstly we removed large suspended solids, floating matter in the case of screens. Then what happens? When we go for grit chamber, we did the removal of inorganic suspended solids. Okay. Now, when this is a chamber, just like your sedimentation time, the thing is you keep it only for 30 to 60 seconds. That is about 1 minute. The velocity of flow is 0.13 to 0.3 meter per second. Now, I'll tell you in Hindi. When you design the grit chamber, firstly make sure that the length everything is properly designed, the velocity is maintained. Why? Because अगर आपने ज़्यादा velocity provide कर दी, जिनको settle होना था वो भी चले गए, और अगर कम velocity provide कर दी तो organic solids भी settle out हो गए. Now I'll tell you in English also. If you have provided a lesser velocity, even organic suspended solids will settle. And remember, that is too much dangerous. You know why? Because we are not going to treat the impurities of grit chamber. We are just going to dispose it. In organic sand-filled particles, there is nothing to treat. But if organic gets also settled, that is a problem. Okay, so that is the reason here you have to maintain the velocity in such a manner that only inorganic suspended solids get settled. Now, here the velocity, the flow here is transitional in nature, and whenever you design it, this is for designing purpose, but you should know it, the length whatsoever you design it, it should be increased to 1.25 to 1.30, because when you enter, the water enters, and when the water goes out from the chamber, turbulence is there. Okay. Flow in grit chamber, this is transitional in nature. Slides. Vamsi, you are not able to understand anything. Let me know, beta. Settling velocity. This is the formula for the settling velocity grit chamber. Who was asking me, Swapnil or anybody asked me, now what is CD? CD is the coefficient of drag. Remember, in the case of rapid sand filter, also I told you that the flow is transitional. This is the formula. And in the shortcut manner, you can use this formula also. RE is Reynolds number, which is rho VD by mu. Okay. Okay. So this is the formula. Now, coming next, skimming tank. You asked me or what, Vamsi? Okay. Now you understand what is CD? Now you understood what is CD? Okay. Now, skimming tank. Whenever oil and grease particles from the motor garages, restaurants, if they are there and you don't treat it, what will happen is, if you go that water to trickling filter and all, they will interfere with the treatment operation. That is the reason, remove it first. Why? Because if oil and grease particle are there, it will inhibit the growth of microorganisms. So treatment will not be complete. Okay. So what happens is, oil and grease particles are there. You supply compressed air from the water. So oil and grease particles will be lifted up, and like जैसे दूध में से मलाई निकालते हो ना, you from the milk you remove the what you call skimmed milk. You skim up the milk on the top. So in that manner only, what you do, you skim up the oil and greasy particles. That's why its name is skimming tank. And how much area to be there, that is being given by this formula. This is empirical in nature. Q is the rate of flow and VR is the minimum rising velocity. Okay. So this is the skimming tank. Whew, everybody needs a break or what? Or let's do it. Tell me yes or no. Otherwise, we'll start trickling filter. Okay. Let's do. Tell me yes or no first. Vamsi, Swapnil, everybody tell me you need a break or what? Trickling filter के बाद. Okay, fine. Let us complete trickling filter, Prashant. Okay, trickling filter is based on aerobic attached growth process. Aerobic means microorganisms will utilize oxygen. Aerobic microorganisms will be functional. Now, there are two things. One is attached growth process and the other one is suspended growth process. Attached growth process, you give the medium for the microorganisms. Okay, you give a medium for the attachment of microorganisms. Since you have given a medium, this is attached growth process. Suspended growth process is organic matter and microorganisms both are in suspension. Like, you might have gone to the party There is a waiter with a starter and you are there. Let us suppose the starter is paneer pakoda and you are there. You are a microorganisms and that paneer pakoda is an organic matter. The party is the wastewater. So you are also moving, means microorganisms is moving, paneer pakoda is also moving, that means organic matter is moving. That is suspended growth process. If I talk about attached growth process, in attached growth process, what is happening? You went to the restaurant. You are the microorganisms. You are basically, you are the microorganisms. You are sitting. A medium is provided to you and the organic matter will come to you. So that is attached growth process. Now I guess you guys won't get confused in attached growth and suspended growth process. So when I talk about attached growth process, here I give a medium for the trickling filter. Okay. Now what will happen here? These are the filter media. Make sure they are clean. They have a high compressive strength. They don't go wear and tear. Okay. Their durability should be high. These all things you should know. Now, when this method, generally when you discharge the sewage, there are two methods. One is spray nozzle, another one is rotary distribution. Ma'am, what we prefer? We prefer rotary distribution. If I am the basic truss here and here. So here is there, so it is rotating like this, like this. So the sewage is fresh. In spray nozzle, like you supply, then you keep it for some time, supply. So the sewage is comparatively not fresh. Okay. In rotary distribution system, generally we opt for it. Okay, see I'm the truss. Here holes are there, so it's moving like this. Okay, so what will happen? This feed pipe is there and it is discharged. It is open to the atmosphere. Now what will happen? I'll take one particle. So initially it is not in operation. First, you give time for the biomass layer to be formed. The moment the biomass layer is that layer, okay, firstly, you give time for the biomass layer to be formed. Biomass layer, how it is formed, what it is biomass layer, what happens? Initially, the water was coming, okay, the wastewater was trickling through the filter media. So, they consist of sticky deposits of organic matter. So, they get sticked to this filter media. So a certain amount of biomass layer is thick, the filter is ready for operation. Now, initially biomass layer means what? Biomass layer means it has microorganisms in it. So whenever I say biomass layer, it means microorganisms is there. Here you have provided a medium for the attachment of biomass. Next, coming further, when the wastewater trickles through this, in this wastewater organic matter is there. So organic matter will come in contact with microorganisms. Microorganisms in the presence of oxygen will carry out the decomposition of biodegradable organic matter. Now the thing which comes out to be next, is that in this process, when organic matter is decomposed, it also lies here. So the thickness increases. Now the microorganisms will rapidly go cell division 2 to 4, 4 to 8 and so on. So the thickness of biomass layer goes on increasing. The thickness, this is the filter media particle and the thickness increases. If the thickness increases, oxygen is limited only to the upper parts and it is not able to penetrate to this portion. So the place where it is not able to penetrate, their anaerobic decomposition will take place. And the place where you can see oxygen is able to penetrate, their aerobic decomposition will take place. Generally, the whole thickness of biomass layer varies from 0.1 mm to 2 mm. The oxygen penetration is 0.1 mm to 0.3 mm. Okay, so maximum part of it will go anaerobic decomposition. Now the dead cell mass, those microorganisms which will not get food, they will die. When they will die, that means they will undergo endogenous respiration and the dead cell mass are not sticky in nature. So what will happen here? The stickiness is gone. Okay, so the detachment takes place. So when the water comes now, heavy turbulence is created and this biomass layer wears off. It is taken off and the process is known as slogging. So ma'am, there are n number of filter media particles. This biomass layer is removed for all the particles at a single time? No beta, it is a continuous process. In some media particles, layer was formed, in some it is removed. So it is a continuous process which goes on. Okay, so this is known as slog. This process is known as slog. Understood? First, you gave time for the attachment of microorganisms. Then you operated the filter. Then the thickness goes on increasing. Those microorganisms which does not got food, they got endogenous respiration. Water came, turbulence, they wear off. And this biomass layer will get settled in the secondary sedimentation tank. Okay. Now, we have two types of trickling filter. First is standard rate trickling filter. Standard rate trickling filter. Now, if you talk about standard rate trickling filter, here you can say the recirculation is not there. You do not recirculate the sewage back. In case of high, or you can say the percentage rate of removal, it takes more time to do the removal of organic matter. While you can see this also, this is how the trickling filter works. Okay. Where it is high rate trickling filter. This is standard rate trickling filter, that is primary sedimentation tank. This is BOD. Influent BOD to PST, influent BOD to trickling filter, and this is the BOD from the trickling filter. So here you are not doing any recirculation. So the efficiency of it is calculated by the formula 1 plus 0.0044 U by F. Okay. Now F here is F. Let me tell you, F is recirculation factor. Okay, and that is 1 plus R upon 1 plus 0.1 R whole square. And R is recirculation ratio, which is QR by Q naught, which is equal to 0 in the case of standard rate, because no recirculation is done. If this is 0, F will become 1. So that's why the formula for standard rate trickling filter comes out to be this. Now what is U? In different books, different thing is written. So I'll tell you, U is organic loading rate in kg per day per hectare meter. Now kg per day is the weight and volume is hectometer. So in some books, instead of U, they write W by V. Okay. So you can go by any manner, whatsoever you want. Now, standard rate trickling filter, no recirculation. Go for high rate trickling filter. Here you do the recirculation. Sewage is recirculated, QR. So exact same formula, but here F will not be 1. F will not be 1. There will be a value of F. And the formula for F and all remains to be same. Since you are doing recirculation once, so you call it as single stage high rate trickling filter. If efficiency F कहाँ गया मैम? Efficiency F कहाँ गया मैम? Efficiency F कहाँ गया मैम? समझी नहीं मैं सनी. F1 है ना? F1 है. Standard rate trickling filter F is 1. Okay, that's why F is not there. Okay, for high rate trickling filter, F is not 1. So that's why F is written here. This is since you are doing it recirculation once, this is single stage. If you do recirculation twice, it becomes two-stage high rate trickling filter. Now, till now in GATE examination, never ever they have asked the question. Thank you, Prashant, for two-stage. But if they can, so let me tell you. Efficiency of first stage. This is U1, this is F1. Okay. Now what is U1? You can write it as W1 by V1. W1 is how much amount is entering, Q0 into S0. That is the BOD which is entering. This is V1. Okay. QR, this recirculation can be same and they can be different also. So F1, this is R1. So 1 plus R1. R1 can be same, can be different. So from here you will get it. Okay. Now the efficiency of second stage. Anybody? How you will calculate efficiency of second stage? Anybody? One more thing will be there. 1 minus two things. Firstly, U2 will be W2 by V2. Volume of the trickling filter can be different also, can be same also. V2 will be how much W1 was there, the efficiency of first V2. So this is actually 1 minus W1 by, okay, and this is first stage, this is second stage. Overall efficiency will come out to be how much efficiency is of first stage, how much efficiency is of second stage. Any doubt? Any doubts anybody has? No doubt. BOD exit. Generally, we don't go by that. No, we don't. This is left. 1 minus theta. That formula is used when you get the value. What you are telling me, na BOD in minus BOD out. I know this is difficult to learn, but this is the formula which has been given. That's what I'm telling you. Okay? Clear? So this is the overall efficiency formula. This is the first stage. Second stage till now never ever asked in your GATE examination. Come on guys. This is the question. Let's do it fast. Thank you Teksha. Come on guys. Solve this. We have to calculate the efficiency. Recirculation ratio is 1. That means it is a high rate trickling filter. One thing which I'll give you advice. Since you have to do it in virtual calculator. When recirculation ratio is 1, F is equal to 1.65. Remember this. Otherwise, you can calculate also 1 plus R upon 1 plus 0.1 R whole square. You calculate, you will get 1.65 only. Okay. Now it is asking me efficiency. Efficiency is 100, 1 plus 0.0044 U by F. F I know, U I want to know. U is the organic loading rate, W by V. Volume, not at all given to me directly. Is it given? Yes. Just check it out. 2, 3, 4 kg per hectare per meter. Directly it is given to me. So 100. Just formula based. How much it is coming? How much it is coming? Efficiency guys. Efficiency 74.5%. This is the efficiency. Now it is asking me BOD of the effluent. Now see the diagram. Another pure efficiency, what Shears was telling me. If S0 is the BOD which is entering and S is the BOD which goes out. So influent minus effluent divided by influent BOD into 100. So this can also be done. Okay. Now see in this question. It is asking me BOD of effluent. Effluent S0 minus S divided by S0 into 100. Now in this question I have already calculated the efficiency. S0 how much BOD is entering? How to calculate? Got stuck. How to calculate guys? How to calculate now? We have to calculate what? We are stuck. We have to calculate BOD mix now. Why? Why we are stuck? Because domestic sewage has different BOD, industrial sewage has different BOD. So what we have to do now? We have to calculate the BOD or basically the BOD mix. So come on, solve this. 30,000 120 liters. Okay. So we have to calculate BOD. Okay. 30,000 is there. 120 liters per day. Okay. This is the discharge. This is the discharge and the BOD is 200 mg per liter. 200 na? Domestic sewage 200. And the industrial sewage is 3 into 10 raised to power 5 liters per day and the BOD is 800 mg per liter. And the total discharge will be 30,000 into 120 liters per day plus 3 into 10 raised to power 5. How much it is coming the BOD value? Just check it out. This will be the BOD which will be entering into the trickling filter. Ma'am, why you did that? Because domestic sewage and industrial sewage combined BOD was entering. Okay, but this is not entering the trickling filter. Why? Because it has told that first it will go into the PSC and 35% is removed. So the BOD which goes into the trickling filter will be how much? 246.15. 35% is gone there. So here it will go how much? 65%. So it will be 246.15 into 0.65. This will come out to be 160 mg per liter. 159.99 it is coming. So the BOD which is entering is 160 minus S 160 into 100. How much is the value of S coming? 40.8 mg. Clear? Okay. So this let us do rotating biological contractor. Then I will give you a break. Huh? See, rotating biological contractor RBC are also aerobic attach growth process. What you do it here? Here circular discs are provided. Now you can see it here. These circular discs are provided and here also you give time for the attachment of the microorganism in this disc. But the problem is here when you see this disc, okay, the disc goes down, it goes up, goes down, goes up. So what is happening? 40% of it is submerged in water, rest 60%, about 60% is exposed to the atmosphere. So it will go up, it will carry out the oxygen, it will take the oxygen, carry out the decomposition. The one which was up, now it will go down. The one which was down, it will go up, it will take out the oxygen, take the oxygen from the atmosphere and carry out the decomposition of biodegradable organic matter. Okay, so here the microorganisms are attached, but you will say, ma'am, the microorganisms are attached, but here they are partially suspended also. Why? Because the microorganisms are also moving, because the disc is moving. But since what is the purpose of disc? I gave the disc for the attachment of biomass. Clear? So that is the reason I will call it as attached growth process. Okay, so this is the process which can also be used, which is mentioned to you here, all the details regarding it. Okay, any doubts still here? Any doubts still here, guys? Okay. Shall we do oxidation bond also? Or you will kill me. Okay. Oxidation. Shall I do this? Prashant? Do this, na? Go, ma'am, from 6. Okay. Oxidation bond is based on symbiotic relationship, that means mutual relationship. Okay, what will happen here? These are the long basins and all where you allow the water. Nothing to do. This you can see long. You have just what you are discharge the water. Now what happens here? Symbiotic relationship, that is give and take. Like I'm here from 10 a.m. working hard for you guys so that you guys can score good marks in your gate examination. When you will top, you will give the credit to me. So that is the reason I'm investing on you. So I'm giving you and I'll take it from you. So that is what mutual relationship, symbiotic relationship. तुम्हारा भी भला हो, मेरा भी भला हो. ठीक है? So symbiotic relationship, when you talk it about, oxidation bond are same thing. How? Just check it out. Algae does what? Algae prepares food, gives oxygen. This oxygen is used by microorganisms and they do the decomposition. And when aerobic decomposition takes place, what is liberated? What is liberated, guys? I'm not going to tell you. Tell me. What is liberated? Aerobic decomposition, what is liberated? Carbonates, sulfates, nitrates. This you have to answer me. So microorganisms decomposition organic matter. Microorganism decomposes organic matter. It releases carbonates, sulfates, nitrates. Now this is used by algae also, and this can be used by anaerobic here aerobic microorganisms are there. So one relationship is between aerobic microorganisms and algae. Second is this is also used by anaerobic microorganisms, and when they make when they do the decomposition and all, they release gases like carbon dioxide and all, which can be used by aerobic microorganisms. So two relations are going on. One is between algae and aerobic microorganisms. Another symbiotic relationship is going on between aerobic microorganisms and anaerobic microorganisms. Okay, these two are going on with the help of which when you take out the water, the only problem is large detention time is there. Ma'am, how much detention time? More than 14 days. A month, approximately it takes a month. So yeah, the main drawback you can say that large amount of time is required, but the positive is you see that much lesser quantity of organic matter is there. So large amount of organic matter has been decomposed in this case. Clear? So this is about oxidation point, and there is a formula also. T is equal to 1 kd log L upon L minus Y. L is the influent BOD if you want to calculate the detention time and oxidation bond. L is the influent BOD, Y is the BOD removed. This is the formula for calculating the detention time in the case of oxidation bonds. Ma'am, move right of you. अब right क्या? Right. अब ठीक है? Knowledge अड्डा. अभी एरोबिक बचा है, स्लज डाइजेशन, सॉलिड वेस्ट मैनेजमेंट, एयर पोल्यूशन. Guys, shall I start or break? Come on, tell me fast. Fast, fast, fast. Tiksha, Shiyash, and you guys will be coming also or after break or not, tell me that also. Okay. Now the subject is not break. We have ASP left, we have sludge digestion tank left, we have numericals left, we have solid waste management, air pollution. Okay. Okay, promise me and go. Break till 6 p.m. Okay, so we'll meet at 6. Ready, everybody? Present. Oxidation ponds are long earthen basins, while the size and the detention time is not much for the case of oxidation ditches. Girish. Okay. So now we'll be talking about activated sludge process, which is aerobic. Here we won't take the atmospheric oxygen, we'll be supplying oxygen. Moreover, this is a suspended growth system like the paneer pakoda and you both are there in the party. Okay. So now you can see this activated sludge process. You can see this activated sludge process. Now what happens is here the efficiency is quite high, but you are the one who will be supplying oxygen. In this, mixing is done. When you do mixing, what you do on the basis of mixing, when you do mixing, the opportunity of contact between microorganisms and organic matter increases. Activated sludge process, remember, in any treatment unit, you don't apply SST, no issues. SST means secondary sedimentation time. But if in the case of activated sludge process, you don't apply SST, this activated sludge process will not at all function. So that is the reason this is the whole system which you will see. This is the whole system of ASP. This is the whole system of activated sludge process. Okay. Now talking further, when you talk about activated sludge process, let's go. This is the aeration tank. This is the SST. From here, what you are doing it? Recycling it, recirculation. This is Q0. This is the BOD which is entering, the BOD which goes. This is the volume of the aeration tank. This is MLSS. MLSS means mixed liquor suspended solids. For reporting microorganisms, you report it in terms of suspended solids, which is you tell it as MLSS. Okay, mixed liquor suspended solids. A part of the sludge here is recirculated. A part of the sludge is wasted. QU is known as useful sludge. Okay. And this is the QE, the discharge, S, and this is XC. Actually, in SST also BOD removals takes place, but you assume that no removal of BOD takes place in the case of secondary sedimentation tank. Okay, we assume whatsoever is the BOD here the BOD is S, here the BOD is S. No removal will take place, but the truth is some amount of BOD gets removed. Now what happens? Here you are recirculating a part of the sludge. Why? Because if microorganisms will be present, the decomposition will take place at a rapid rate, means in lesser amount of time, more amount of organic matter will be decomposed. Now, if you don't provide this SST, there will be no recirculation, no ASP, no activated sludge process. So if you want the function to take place, if you want the ASP to operate, it is very, very mandatory that you need to do the recirculation. Okay. Now coming further, there are some parameters which you should know. First is the hydraulic retention time. So this hydraulic retention time is equal to the volume by discharge. If Q0 is the discharge and V is the volume of the aeration time. So it will become V by Q0. Organic loading rate means the rate at which organic matter is loaded into the aeration tank. If in 1 liter S0 was the BOD, or BOD means BOD organic matter, we report in terms of BOD. Microorganisms we report. If you want to know quantitative analysis of it. So on quantitative basis, microorganisms you report it in terms of MLSs. So if in 1 liter S0 is the BOD, so in Q0 how much will be the BOD? Q0 S0 divided by V. This will be the organic loading rate. Okay. Third is specific food, or you can say BOD utilization rate. So it will tell you how much BOD is removed. Now see, Q0 S0 was the BOD which is coming. And which is the BOD which is going out? Which is going out? One is QW into XU. QW it is going out. Okay, XU suspended solids. This is BOD. So QW into S, this BOD is going out of the system, and you can write it QE or you can write it as Q0 minus QW. Anything you can write into S. This is going out. This is going out. Okay, so this is the BOD which is going out. So the remaining BOD is the one which is removed divided by the microorganisms. If in 1 liter X microorganisms are present, so in total volume, how much microorganisms will be present? V into X. Simple. So this will tell you BOD utilization rate. Sludge, very important. There's another name for it which is mean cell residence time. So it will tell you mass of microorganisms. Biomass means microorganisms. Microorganisms you reported in terms of suspended solid. So mass of microorganisms in the aeration tank, which is V into X, divided by those microorganisms which have left the system. They are no more present. So which are the ones? This is Q0 in minus QW XE, because X you do it for microorganisms, and here QW into XU. This is the system. I'll draw it with other color pen. This is the system. Okay, so this is going out, this is going out. So the microorganisms which are there divided by the microorganisms which has left the system. Okay, so this you should know. This is generally, if in the question they haven't given you the value of XC, takes XC as 0. So you will get theta C as Vx upon QWx. Okay, this. Now, this is very important. Food to microorganisms ratio. Why? Because it inversely governs the efficiency. How come? Let me tell you. See, if food is more, microorganisms is less. Like खाने वाले ज़्यादा हैं and खाना कम है. ठीक है? That means what? Decomposition will not be complete. So efficiency will reduce. Inversely, food by microorganisms is less. Food is more, or food, in this case, food is less, microorganism. Why? When F by M will become less? When F will be less and M will be more. So this whole ratio will become what? Less. So that means खाने वाले कम है, खाने वाले ज़्यादा है. So in this case, what will happen? More efficiency will be there. Ma'am, efficiency you are talking means what you are talking? Efficiency I am talking means I am talking the removal of, or you can say the decomposition of organic matter. So more is the F by M ratio, lesser is the efficiency. Lesser the F by M ratio, more is the efficiency. Clear? So the unit of F by M is day inverse, but technically they write it in terms of kg per day. Food is what? If in 1 liters S0 is the BOD, in the whole discharge how much will be the BOD? Multiplied. If X amount of microorganisms are there in 1 liter, how much microorganisms will be there in the whole volume? Just multiplied. Okay, this is there. This again, recirculation ratio. This is important. Everything is important here. Aeration tank is there. Q0, X0 is the microorganisms. Okay, SST is there. Okay, XU. So when you apply conservation of mass here, what you will see? Q0, X0 is entering into the aeration tank. QR, XU is entering into the aeration tank. How much is going out of the aeration tank? Q0 plus QR into X. Okay. So from here, you just arranged it, you will get the recirculation ratio. They can ask you, so you should know this. QR by Q naught is X. X is the MLS's concentration. XU is the useful sludge minus X, which is the MLS's concentration. Okay, this is the recirculation ratio. Now, sludge volume index. This tells you the volume occupied in ml. How much volume is occupied in ml by 1 gram of suspended solids when allowed to settle for 30 minutes. See, you have taken a sample, you have put it. How much volume it occupies? Let us suppose it occupies Vs volume. 1 liter of the sample you have taken, it occupies Vs volume. Now you take the sample back, mix it. The suspended solids which you have taken, mix it and calculate the weight of it. Okay, calculate the weight of it. You will calculate the weight by the similar process how we calculated suspended solids. Okay, how you calculated suspended solids. So let us suppose the suspended solids comes out to be XS. Remember, the unit of sludge volume index is ml per gram. And here from here you will get it in ml per mg. So that's why you need to multiply by 1000. So this is the formula. Ma'am, you said in ASP, SST is not a function. SST is a function, I said MVS. If in any treatment unit you don't apply SST, no, not an issue. But in the case of ASP, if SST is not there, it will not function only. Okay, I said that. So it is very, very mandatory to have an SST in the case of activated sludge process. Okay. If MLSs and MLVSs both are given, then we will take it MLVSs, mixed liquor volatile suspended solids. Okay, because it is more accurate. In mixed liquor suspended solids, inert organic matter and dead cells are included, while in MLVSs dead cells are not included. That is the reason we go for MLVSs. But MLVSs is time consuming to compute. That is the reason in maximum case they gives you MLSs and we use that only. But if it is given, you will use MLVS. Clear? Okay. Now, solve this question. Here you have to calculate hydraulic retention time, F by M ratio, BOD removal efficiency, sludge. Everything you have to calculate. Come on guys. Wastewater flow, Q naught. Volume, influent BOD S naught, effluent BOD S, MLSS, effluent suspended solids. Wasted sludge suspended solids. Sludge QW. See, I have written everything for you guys. Hydraulic retention time is very simple. V by Q into 24. How much it is coming? How much it is coming? Come on guys, fast. Hydraulic retention time, then food by microorganisms ratio. Q S naught by Vx. Q is 35,000. BOD is 250. Volume is 10,900 into 250. Everything will get cancelled out, so don't worry regarding it. 7.47, that is 7.5 I have taken. This comes out to be how much? 0.32 day inverse. Next is BOD removal efficiency, which she has already told. Influent BOD minus effluent BOD divided by influent BOD into 100. So 250 minus 20 divided by 250 into 100. Simple. How much it is coming? 250 minus 20, 230, 23 into 100, 92%. Fine, 92%. Last is sludge. Remember in this question a sludge age when you do it, volume, how much is going. So in the previous case it is Q0 minus QWXC plus QWXU. In this question XC is given to you, so you cannot take it as 0. You cannot take it as 0. Remember that. Volume is how much? 10,900. X is how much? 2500 mg per liter. Q0 minus QW. Q0 3500 minus 35,000 minus 220. Correct? Into XC. XC is given to you as how much? 30. Plus 220 into XU. XU is given to you as 9700. How much it will come? How much it will come? Fine. So it's not necessary that in every case effluent suspended solids is 0. In some cases they can give you, so make sure you know that. Okay. So this is the sludgeage. Fine. So the last topic, I guess, that is the sludge digestion or the digestion of sludge. Okay. So whatsoever from the primary sedimentation time, whatsoever suspended solids, organic suspended solids settle. Okay. Organic suspended solids settle. You don't throw it directly. Why, ma'am? Because if you throw it in the river, microorganisms will take out the river's dissolved oxygen. Aquatic life survival will be difficult. If you throw it in the land, it will take atmospheric oxygen. So that is the reason you have to treat it. For treating it, you have to go into the sludge digestion chamber. Now, when you digest it, you reduce it. Okay, when you reduce it, it comes into three components: gases, supernatant liquor, digested sludge. Basically, you get solid, liquid, and gas. Now, coming further, in this, you have three stages. One is acid fermentation. What happens here? Acid formers are there. So, what they will do is, aerobic and facultative bacteria are there. They will convert the acids, reduce it into lower molecular weight. Okay, the pH becomes less than 6. After acid fermentation, you have acid regression. The acids which are produced in the first stage are attacked by microorganisms and they convert it into carbonates and ammonia compounds. The pH which was less than 6, now the pH rises up to 6.8. After acid regression, you have alkaline fermentation. In this stage, methane formers comes into action. What they will do? They will take the acids and all which is produced in the previous stage and they will convert it into gases like methane and complex organic matter into simple organic matter. In this stage, you will get the digested sludge at the bottom, then the liquid and the gases at the top based on their density. Okay, this is the last stage. Now, this stage, specifically the sludge which you obtain from the digestion chamber, in that 70% is the volatile solids, 30% is the fixed solids. Out of the 70% which is the volatile solids, 65% is reduced to gases. If you want to know how much gases is produced, you can say 0.6 meter cube per kg of the solids present, or approximately they give you the same answer. 0.9 meter cube per kg of volatile solids reduced to gases. It is that simple as that. Majorly basis, methane is released. You can sell the methane. Okay, it has a high calorific value of 8600 kilocalorie per meter cube. Or the gas which is produced, methane, you can use that for running the plant. So you can use in that manner also. Okay, now coming further, we have two types of digester here. Standard rate sludge digesters. When you say standard rate, actually the time taken is more. Okay, so you feed the sludge here from the primary sedimentation tank. What will happen? No mixing, nothing you are doing. You are totally dependent upon the acid formers and methane formers. Methane formers is pH sensitive. It is like a moody person. I won't eat that, I won't eat that, those things. It is pH sensitive. It works in a narrow pH range of 6.5 to 7.5 generally. Okay, if you increase the pH, it will not function. If you decrease the pH, it will not function. So here what will happen? Here the decomposition will take place. The solids which are formed, which will be deposited here. The liquid supernatant liquor which is here, it has a high BOD value. High BOD means how much? 1500 to 3000 ppm. So it is sent back to the primary sedimentation tank. Then you have gases released. So from the floating chamber is there from which you collect the gases. That's it. So this is the standard rate sludge digester. Now you want to increase the opportunity of contact. This portion of active zone, you take it out and you do mixing. The raw sewage is supplied, you do mixing. When you do mixing, like if in a party, I'm there and paneer pakoda is there, and Prashant will come and say, ma'am, paneer pakoda is this side. He guided me. So what? I'll go there. So my time for searching the paneer pakoda is reduced. Why? Because Prashant helped me for telling ma'am paneer pakoda is this side. Similarly, if I have to search, it will take time. So if microorganisms has to search organic matter, it will take time. But if by some external means I am able to get that, it will reduce the time. So here external way is, my external way was Prashant. He told me, ma'am, paneer pakoda is this side, don't search in this large acre or party. Okay. Similarly, if you do the mixing, opportunity of contact will increase and so the time required will be less. So once it is done, you will feed it. Again, here you will get all the three components: digested sludge, supernatant liquor. It has a high BOD. Don't throw it. It is very, very harmful. Okay. So supernatant liquor will go into the PST and you will have gases. So this is the high rate sludge digestion. If you want to calculate the volume, how much sludge is coming and how much digested sludge is going, because the volume of raw sludge is reduced. Gases, you are collecting it in the gas chamber. So this is when you are assuming linear variation. If in the question nothing is given to you, you will use what? You will use parabolic assumption. DT is the detention time for the time you have kept the sludge in the sludge digestion tank. Now let us suppose monsoon came during that period. So you cannot dispose that. Okay. So you have to maintain an extra space so that the already digested sludge can also be there. So this is V2 into T. Capital T is the monsoon period. Till that time monsoon period is there, you cannot dispose the digested sludge. Okay. So this is the volume formula. Any doubts? Okay, and there is one prominent relationship. If Va is the volume of raw sludge and initially the moisture content is Pa, so ma'am, once repeat why supernatant, I'll repeat that. Vb is the volume of the digested sludge and the moisture content of the digested sludge. The aim of the sludge digestion tank is to reduce the moisture content, okay, to reduce the quantity of the sewage. Supernatant liquor has high BOD 1500 to 3000. That means in 1 liters 1500 to 3000 is the demand of oxygen for the decomposition of biodegradable organic matter. So large quantity of organic matter is present. That is the reason you cannot dispose it and it is recirculated back. Clear? Come on guys. This is the design for digestion chambers. Then we have septic tank as well. Okay, fine. Guys, come on guys. We have to design it fast. Fastly solve this. Solve this fast. Digestion period is given to you. Suspended solids, all things are given to you. How you will solve this? Are you going to solve it or I'll be the one who will be solving it? Tell me that also. Fastly, fastly. You will be solving it or I? See, here moisture content in digested sludge is given to me. Digested sludge. VB is not given to me. I'll take it the volume of the digested sludge VA by 3. So this is VA by 3, 100 minus 85, and this is VA 100 minus PA. Can you tell me how much is the moisture content? Calculate and tell me. I think it is 95%. Just check it out. 95% is the moisture content. Just check it out once. Now it is asking me design the digestion tank. So if it is asking me to design, I need to calculate the volume. So design, I need to calculate the volume. Then I have to calculate the dia. Now in the question, I don't know VA, I don't know VB. If I am able to calculate the volume of raw sludge, I will get the answer. How will I calculate volume of raw sludge? Come on guys. See, 20 into 10 raised to power 6 liters was the flow. The solids which were present, suspended solids which is given. So the suspended solids which are present was 300 mg per liter. Out of this, 60% was reduced in PST. So this 60% will be the one which will be producing sludge, mg converted into kg. How much it is coming? 3600 kg per day. This is the sludge produced. This is the sludge produced. I need to calculate the volume. How will I calculate the volume? Anybody? Come on guys, fast. How can I calculate the volume? Fastly. I know the weight. How can I calculate the volume? Come on guys, fast, fast. Moisture content is 95%. That means 5 kg of solid and 95 kg. If I want to write, it will be like 5 kg solid and 95 kg of water makes 100 kg of sludge. This is the meaning of it. So, if 3600 kg per day of solid is there, how much sludge will be made? Can I calculate in this manner? I don't think so. Use specific gravity. Okay. If I take specific gravity, then also I won't get the answer properly. Fast. This is kg per day. How much will I get from here? How much will I get from here? How much sludge is produced? Guys, how much sludge is produced? No, we don't go by that method, beta. 72,000 kg of sludge is produced. I need to calculate the volume. I need to calculate the volume. What I will do? 72,000 divided by the specific gravity. How much it is? 1.02. And the specific gravity of water comes out to be 1000. So this manner I will do it. 70.588 meter. Clear, shears? This manner we will do it. It's like, you know the formula, I guess. 100 minus PA kg of solid is there and PA kg of water is there. So it will make, water means moisture, 100 kg of sludge. So if WA kg of solid is there, how much it will make? WA into 100 upon 100 minus PA. So if you want to get volume, volume will be WA into 100 divided by 100 minus PA into the unit weight. So that's what I have done. That's what I have done. What, Kishalya? See, if it is written 95% moisture content, moisture means water. Percentage means 100. If 100, you know what, sludge and sewage are same. Only difference is the amount of solid content is more in the sludge. So if 95% is the moisture content, that means 95 kg is water, rest 5 kg is solid. So if 3600, which is given to you, this is the solids, how much sludge will this solid generate? So it will generate 72,000 kg per day of sludge. Okay, so this will be the generated sludge. So volume will come out to be what? Weight divided by the specific gravity into the density of water. So generally this is what? Weight by gamma you take, unit weight. Density is equal to mass by volume. You can go in that manner also. Okay, VB is equal to VA by 3. How much it will come? 23.529 meters. So from here what you will get? The substituted here only. Oh, I wrote the formula there. Detention time. So in this manner we go. Yes, you were telling na that manner we don't go beta. 30 days is the detention time. 30 days. 70.588 minus 2 by 3. 70.588 minus 23.529. How much meter cube is the volume coming? How much meter cube is the volume coming? Now you will do pi by 4 d square h. In the question it has given you the height as 6 meter. So do it 6, from here you will get it, and they can ask you in GATE examination. It's not that tough that they can't ask you. This will be the diagram. This will be the diagram. Clear? This will be the diagram. They can ask you. Okay? So this is the volume part, and the last I think. Okay, fine. Then we'll go to the solid waste management part. So the last one is the septic tank. This is anaerobic. Those places, anaerobic suspended growth mechanism. Those places like hospitals and all, initially when the sewer pipeline was not laid and they were out of the city. Now also you guys have seen the septic tank. Those places where the sewer facility and all is not there, they go for septic tank. This is anaerobic suspended growth mechanism. Normal, no brain, just a sedimentation tank. Here you don't do screening anything. Why? You just take connection is there, from there the sewage comes. It is being there for 24 to 48 hours. In PST you keep it for 2 to 2.5 hours. Here, since you haven't done screening, there no be any further treatment which will be given. You just directly feed it here. Okay, now it takes time for digestion, everything it takes time. Now when it is digested, that means digestion means what? The decomposition of organic matter takes place, because the sewage which comes out from your homes consists of a large amount of organic matter. So what will happen? This sewage is fed. Eventually you will see the sludge is formed at bottom. You give time for the digestion of this, and eventually you reduce it, and the gases will go out on the top. Vent cover is provided. So technically it functions three things. What? First, it functions like primary sedimentation tank. Secondly, it functions like biological treatment. Why? Because suspended organic matter is removed, dissolved organic matter is removed. Third, it functions like sludge digestion tank. Why? Because the digestion of sludge is also carried out. Moreover, the efficiency is not that much, and you can see this. All those washrooms from there, the sewage comes, it goes into this septic tank. This is the process which you can see. And underground pipes is there. So whatsoever is the treated sewage, it is dumped. Moreover, make sure that no amount of water table should be should be there near to it. Otherwise, what will happen? Pollution of that water will take place. Clear? So this is the whole schematic diagram. Hand wash is also there. You can see it here. Okay. Fine. So marathon series tomorrow for geotech. Now let's talk about air pollution. After this, we have solid waste management. What? Let me check it out. Okay, fine. Let's do solid waste management first. Then we'll talk about air pollution. Right now we were talking about liquids and liquids. Now let us talk about solids and solids. Solids waste management. This is quite simple. It will be easy. We'll do it fastly. Solids and semi-solids which are generated due to domestic activities, industrial activities, they are known as what? Solid waste. Domestic solid waste, municipal solid waste or refuse, all the three means the same. Domestic solid waste is further divided into three things: garbage, rubbish, ashes. Till now in your GATE examination, they haven't asked database questions, but in your state level examinations and ESC, they ask you, so the garbage density, garbage is biodegradable waste, okay? That waste, biodegradable waste means that waste which can be easily decomposed by the action of microorganisms. So, it varies from 450 to 900. Rubbish, non-biodegradable waste also it is there. So its density is 50 to 400. Ashes, ashes like चूल्हा जब आप जलाते हो तो जो आपको मिलता है incombustible when you basically use furnaces and all. So that is ashes which is 700 to 850 kg per meter cube. Now this is the solid waste. Already told you domestic solid waste, municipal solid waste, or you call it as refuse. Okay, so this is garbage, then you have rubbish, then you have ashes. So you can see the percentage, 45% is of domestic solid waste is garbage, then rubbish, and rest 1.5% is ashes. Street sweepings also corresponds to 25% जो आपको road में दिखता है कचड़ा and all. That also corresponds to 15% about 15 to 25%. So that is street sweepings. Okay, now you know what? I'll tell you one thing before we move towards sanitary landfilling method. The calorific value in the case in India is very less. Why? Because you know we don't throw anything very easily. If toothbrush is there, firstly, after 1 to 2 months, we should change it. But we keep on doing it until जब तक उसके सांसें ना निकल जाए. Means that toothbrush also says leave me. Then we leave that toothbrush. After that, that is used for cleaning purpose. After that, it is used for dyeing purpose. And after that, used for any purpose. After, I think, 4, 5, 7 years, that toothbrush is gone into the wastage part. So that's the reason here you don't get that much value. The truth. Because we are Indians and we are proud of it and we do these things. Okay? Everybody knows that. Have I said wrong? You guys are laughing. Have I said anything wrong? Tell me. Relatable. Yeah, that's true. That's true. That happens, right? Nowadays, Indian things. Now, initially what happens when your jeans used to get torn off, you used to throw it. Now that is also a fashion. Okay, there's no need to do rafu also. Okay, now why to go anywhere else? When this cup handle, my maid will break this, I will paint this and then I will use it as a flower pot. After that, I will might use it for some other purpose, but that's for sure that I am not going to throw it at a single stretch until it is shattered into pieces. So that's the fact. I'm using old toothbrush for bleeding BYJU'S. हाँ, very good गिरीश. अगर नहीं किया तो हम इंडियंस कैसे? Very good. That's the fact. So that is intelligence. Yeah. All these bottles and all I'll use for that purpose. Okay. So this is the thing I'll do it. And otherwise I can use it as a pen stand also. So there are n number of things which I can do it. So that is the reason you know it. So that's the reason if you compare it from foreign countries and here you won't get that much value. Okay, the energy you won't get that much. ओके, नाउ व्हाट इज हैपनिंग, पीसेस होने से भी डेकोरेशन पर्पस, बिल्कुल सही बोल रहे हो, पीसेस होंगे, मैं उनको कलरफुल क्या बोलते हैं, कलरफुल पेबल्स के साथ मिक्स कर दूंगी, कुछ भी कर दूंगी, तोड़ के चिपका दूंगी और बोल दूंगी मॉडर्न आर्ट है. आई कैन डू एनीथिंग दैट इज मॉडर्न आर्ट, आई कैन डू दैट, राइट? सो या, दैट्स द फैक्ट. So this you know it, right? So that's the reason the energy kilojoule per kg value which you get in India is very less as compared to what you get in other countries. So if you bring their code and compare it, I have already told you, भाई साहब नहीं हो पाएगा, अलग है. Clear? Difference it is there. Now, let's talking about the methods of treatment or basically methods of disposal. Now talking about the sanitary landfilling method. सैनिटरी लैंडफिलिंग मेथड, तुम लोग भी बताना क्या क्या करते हो, मैं क्या करती हूँ. और ये तो मैंने ये टूटे वाले का एग्जांपल दे दिया, और मैंने क्या किया है अब मैं सोच के बताऊंगी, मुझे इंस्टेंट में याद नहीं आ रहा है कि मैंने कौन सी चीज का यूटिलाइजेशन किया. हाँ, वो जो मग हैंडल विच वी यूज फॉर बाथिंग, इफ इट ब्रेक्स आउट, जस्ट थ्रो इट, कलर इट, उसमें पौधे लगा देते हैं. So that work I have done. You guys can also comment and tell me what is the good thing which you have done being an Indian. Okay, so these are the things which I do it. And I collect the cutleries of the hotels and all also. I collect that also. I collect those cutleries and all. And what do I do with that cutleries? फिर कोई और आता है उसको दे देती हूँ. ठीक है, खाना देना है तो फिर अपने स्टील के डब्बे ना देके वो cutleries दे देते हैं. So these are the things which I do. Indian things, right? And I'm proud of it. So, Son Papdi, Dibba, we parcel it. All these things we do it, right? So, Apnil हंस क्यों रहे यार, तुम नहीं करते क्या? So, this we do it. So, now let's talk about sanitary landfilling method. This is a proper engineered mechanism of disposing the solid waste. और सॉलिड वेस्ट, मैरिज कार्ड कन्वर्ट इनटू समथिंग. मैरिज कार्ड का तो वो पहले छोटे थे तो गणेश जी आते थे ना चिपक के, उसको मैंने फाड़ के यूज कर लेते थे. हाँ, जोमेटो वाले बाउल को धो के यूज. करेक्ट करेक्ट. तुम लोग भी मेरे टाइप के यो बॉटल से आवाज बना देते हो. वेरी गुड. चलो, मतलब मैं अकेले ही पागल नहीं हूँ, मेरी गैंग भी पागल है. चलो, तो सैनिटरी अब ये सब काम करेंगे. अब एग्जाम्पल इज वी हैव टेकन अ टूथब्रश, वी आर नॉट थ्रोइंग इट, सो दिस विल हैपन लाइक टूथपेस्ट को अंतिम सांस तक हम निकालेंगे, उसके बाद भी मैं क्या करती हूँ, उसको काटते हैं. बताऊं, क्योंकि आप उसको निकालोगे उसके बाद भी उसमें टूथपेस्ट रहता है. सो व्हाट यू डू, यू कट इट एंड you take it out it from the inside. Steamer bowl as fish tank. See, so creative people are there. So this all things we do it, right? So कहाँ से मिलेगी एनर्जी, किलो जूल पर केजी वैल्यू तो कम ही निकल के आएगी ना. Now, sanitary landfilling, what you do it, you dump it. You can see it here. 0.5 meter dump it, compact it. 0.5 meter dump it, compact it. 0.5 meter dump it, compact it. Then spray a good earth soil over it. Now what happens is technically in a single day you should do 1.5 meter of compaction, and then you shouldn't compact for 7 days. Why? Should not basically add any amount of more solid waste there for 7 days. But practically in India, they don't wait for a day also. Lao bhai lao, bring it, dispose it off. They do like this. So what they do, they're doing it like this, but we say no, it is a proper engineered mechanism. Kitabon mein, books, it is written like this. But when you go, ma'am, you told wait for 7 days, they're doing it in a single day. That is the bitter truth. That happens. And you know what? 0.5 meter compact, 0.5 meter compact, they don't do all these things also. So we are studying it, but I told you the ground reality also. So 1.5 meter compaction, you leave it for 7 days. Why? Example, BOD, maximum amount of BOD value, biochemical oxygen demand is satisfied. How? I'll tell you here also, just wait. 7 days, BOD ultimate 1 minus e to the power, let us take 0.23 into 7. How much it is coming? 1 minus e to the power 0.8. See, 80% value of BOD is satisfied, but you don't do it. Okay, then again you compact it, you put good earth soil over it. So what you are doing it, you are throwing the solid waste, compacting it, and allowing the aerobic microorganisms, the acid formers, the methane formers to attack on this. First, initially oxygen will be there, so aerobic microorganisms will be there. Eventually, acid formers will become, which are facultative also in nature. After that, methane forwards will become, which are strictly anaerobic. It functions in a narrow pH range and they will reduce the solid waste further. Ma'am, how come we will know that the solid waste is reduced? You will reduce the height. This height will be reduced to 20 to 40%. Simple, economical, you are not doing anything, microorganisms is doing it. Okay? And for this, the moisture content should be greater than 60%. Okay? Same. Same shears is done by my father-in-law. Same, ditto same. Now we don't have space in our home to keep anything. I am living, that is more than sufficient now. So this is the method for sanitary landfilling. Now, incineration and thermal pyrolysis. Incineration, you burn it. This question has been asked. Incineration, abundant supply of oxygen. Pyrolysis in the limited supply of oxygen. When you burn it in the limited supply of oxygen, specifically you burn only those solid waste which gives you which are combustible, and they will give you a high calorific value. Okay, so that you can use that for selling, and it will be like paisa hi paisa hoga babu bhaiya. So like that you will get money, more money, and then more money, then rich, then super rich, then iPhone, then Audi, then a bungalow, many things you can have. So not that much amount you get, but when you burn it, you'll get that much amount of value that you can run the plant. So that is incineration. Thermal pyrolysis, you burn it in a limited supply of oxygen. The byproducts, you get charcoal, you get tar, which you can sell it also. Okay. Shredding and pulverization, basically this is not any method. The basically higher solids, or the heavyweight solids, or the larger solids are reduced into the shorter forms. Pulverization and all means you grind it, you convert it into powdered form. That's it, what you do. Disposal in seas and all, dispose it in the seas. Nowadays you don't do it. Reason for that is it comes back. Okay, unsanitary conditions are there. You have to dispose it, and low tides conditions, you have to go deep away from the seashore and dispose it. So it is a costly process. Now, composting, which somebody was telling na, that chilke wilke fruit pills and all, they used it for creating a compost. That's a good thing. Those things, those biodegradable waste, we go for composting. Very popular is two things. One is Bangalore method of composting, and another one is Indore method of composting. Developed in those cities, so name as, that's a blunder. That's a blunder. Which is the blunder? Which is the blunder, Vamsi? Bangalore method of composting, Indore method of composting. Bangalore method is an anaerobic method. You break it, just dump it. Now you won't turn it and all. Indore method, what you do, you properly turn it after a suitable intervals, so that aerobic condition is maintained. So Indore method, practically going it and turning it is something which is like, it smells, right? So that is the reason in many of the municipal corporation, if you will go, they will prefer what? They will prefer what? Bangalore method, because it is anaerobic. You just keep it, you don't have to turn it off. So for maintaining aerobic conditions, but the decomposition will take place. How you will see? You will see the decomposition in terms of height. Disposal, when you do by composting, there will be a thing which is which you will get is humus, manure, which you call it as khad also. Okay. Okay, so this humus, you guys might knowing it, you go and purchase this also, because when you use it in your crops and all for sowing it, it gives a higher productivity. So you get it from Bangalore method, Indore method. Okay, yeah, Bangalore method is the preferable. Okay, now These are the two questions. Where is that question gone? Where is one more question was there? No? Just a minute. Okay, fine. This is the question. Oh, that was for air pollution. Okay. This is an MSQ question. मैंने banana plant से बनाया. MSQ question. MSQ question. Come on, guys. A solid waste is there whose this is given to you. Chemical reaction is given to you. Oxidation equation. Oxidation equation is missing for this one. It will be like CaHbOcNd plus. Just a minute. I'll check it out. The oxidation equation should also be there. Give me 2-3 minutes. Not 2-3 minutes. Just let me check it out. The blue is not proper. There will be a reaction also for this. Just a minute. Just a minute. I'm sorry. Should be there. ऐप में इतने ऐड क्यों आते हैं यार? चुपचाप खुलता भी नहीं है. CHPOC. अच्छा, जब तक इसका मॉलिक्यूलर वेट निकालो. Calculate the molecular weight of C60, H100, O30N. 60 carbon is 12, hydrogen is 1, oxygen is 16, nitrogen is 14. Come on, guys, calculate. Calculate the molecular weight by that time. सबको खोल रही हूँ, उसमें निकल ही नहीं रहा. वन थ्री वन फोर kg. यार इसमें तो मिल जाएगा, क्वेश्चन ही नहीं है. बताओ. मिला. Got it. So this is the formula is 4a plus b minus 2c minus 2d by 4. This is O2. This will give you ACO2 plus b minus 3d by 2 H2O plus DNH3. This is the formula, and it is given you NH3 plus 2O2 is H2O plus HNO3. This is the whole question, and it is an MSQ question. It is asking you two things. First, contribution of CaHbOcNd in oxidizing 1 kg of waste and the total oxygen requirement. How you will do? Now, calculate first the value of 4a plus b. This is a good question. Calculate 4a plus b minus 2c minus 2d by 4. A, B, C, D, you can compare it and you know it. A is 60, B is 100, C is 30 and D is 1. So 4 into 60 plus 100 minus 2 into 30 minus 2 divided by 4. How much it is coming? How much it is coming? Where it is gone? How much it is coming? kg. It's not mentioned. You can take parts also. No issues. Take parts, write kg, whatsoever it is. Tell me fast. 69.5? Just check it again. 4 into 1600 minus 100. 60. D is 2D is there, na? So 2 divided by 4. 559.5 it is coming. How come you are getting 69.5? Which one you are getting? This is 60. 69.5. O2 is there. Multiply by 32. Multiply by 32. I did that mistake. Multiply by 32. How much you are getting? Just a minute. 360 H 100. 230 T1 divided by 4. 4A minus B minus 2C. That is what I am also thinking. कुछ तो गलत है इस क्वेश्चन में. This question is not correct. प्लस बी क्वेश्चन के हिसाब से तो ये आ रहा है बट ये गलत लग रहा है मुझे. एक सेकेंड. What is Devanshu is telling? Let me do it. 4A 4 into 60 4A. Question is wrong, huh? Minus B is 100 minus 2C. तो और ही गलत लग रहा है क्या? Plus 3D. This is not there. This is not there. Oh, this question there is something wrong with the values. This is not coming correct. Not coming correct. Just do it 50 once. 50. Take it 50 once. C50. Take 58. Just do it once. C50. C50. A value take it 50. 4 into 50 plus 100 minus 60 minus 2 divided by 4 into 04. Comes out to be 1904. Just a minute, huh? And if I do it here, 50 into 12. 16. There's mistake with the question. There's a mistake with the question. There's mistake in the question. I'll check out this question. This is a good question, but there is some mistake with this formula which is given here. Otherwise, it's not coming in this manner. So I'll check out the question and in the practice session I'll do it. Yeah, that's coming, but it is for 50 na. It's not coming correctly. So I'll check it out this question. Okay, this is a good question, but the values which they have done some mistakes in this. I have to check it out. Okay, so who keep it this question and hold. We'll do this question. Simple question is there. Only the thing is the balancing is not proper. So you have to balance it. Other question that it became wrong. Last is the air pollution. So guys, air pollution जो हम सब बहुत करते हैं. What we do in the air pollution is those pollutants. Firstly, what is air pollution? Those pollutants which are present in such concentration and in such amounts, which are present in such concentration for a certain time that the life in the biosphere is there where we are living, where the life persists. Okay, it's affected is termed as air pollution. Okay. Now, when you talk about जल्दी करो मैम, सुबह पनवेल निकलना है. क्यों जाना है पनवेल? चुपचाप बैठ के पढ़ाई करो. और सुबह निकलना है, 1 घंटे से पहले हो जाएगा. Okay. Now, when you talk about pollutants, there are two types of pollutants. I don't know which exam is left where they haven't asked this. Primary pollutants, secondary pollutants. Okay. So the combination when two or more primary pollutants or in the primary pollutants like example, primary pollutants like one mistake which you do, suspended particulate matter is the primary pollutant. Then oxides of nitrogen. Ma'am, energy on dry basis and as free basis. Buffering to me or for everyone? I don't know. Is it buffering, guys? Uh, Prashant, that I will take it in that midnight session will happen. Most probably Saturday or Sunday I will take that session. In that I will take it. The questions. Questions are only there for dry bases and ash-free bases. Okay, so don't worry. I won't leave that. Okay. Secondary pollutants we have like oxides of sulfur. बफर कैसे हो रहा है यार? Oxides of nitrogen. Then secondary pollutants we have peroxyl acetyl nitrite. We have all these things. Ozone. For me it is not buffering. I'm checking it. So this is the secondary pollutants. एक बारी बंद करके फिर से चालू करो. Okay, so these are the secondary pollutants: peroxyl acetyl nitrate and ozone. They give the combination there and they ask you which is the primary pollutant, which is the secondary pollutant. So 1 marks, they ask these type of questions. Now types of environment. First is unstable environment or the super adiabatic environment. What happens before you study this? You should know two things. One is environmental lapse state and the other one is adiabatic lapse state. Is it happening now also? O3 secondary, huh? O3 is secondary also. Is it buffering now also, guys? See, I have a good connection. I have checked it out also. Just check it out once. Is it happening now also, Alec? Okay. So first is ELR, environmental lapse rate. What happens? Environment means the surrounding air. You talk about only troposphere. Troposphere is situated, this is the earth and this is the troposphere layer. To 11 kilometers, and we will, all the discussion which I'll be doing it, I'll be talking only about troposphere. Temperature of air decreases with increase in height. That is known as what? Environmental lapse rate. How can you know? Take a balloon. Okay, insert a thermometer is there and a recording mechanism is there, and Arun is standing here. Arun is standing this. So the rate at means it does not transfer it heat. Environmental lapse rate, you use it for the surrounding air. Adiabatic lapse rate is for the air parcel or you can say for the pollutant. चलो अब मैं एक गाड़ी बनाती हूँ. This is my car. Nobody will laugh. Yeah, ये तो boat बन गया. This is my car. This is my car. Buffering. Is it okay now? Fine. Now is it okay? Let us check it. YouTube की आज हालत खराब हो गई भाई, हो गई. Okay. So now what happens? अब होगा तो बताना. यार शालिन, अब इसमें किसकी गलती हो जाता है कभी कभी, टेक्निकल ग्लिच. ओके, नॉट ओके. यार ये एयर पोल्यूशन चैप्टर में इसको होना था. जस्ट अ मिनट। मैं भी देख रही हूँ, कुछ तो ग्लिच हो रहा है। यस, नेट खत्म क्या? नेट तो नहीं खत्म है यार। जस्ट अ मिनट, 2 मिनट, थिंग इज ओके एवरीथिंग। अरे शालिन, you are little bit frustrated. Nothing will happen. Wait, just let me check it out. Why it is happening? I'll ask the technical team. Just a minute. Wait यार, 10-20 मिनट का टॉपिक बचा है और ये अभी लास्ट में इसको होना था। अभी भी हो रहा है क्या? नेट लिमिट? अरे मेरा तो अनलिमिटेड है। Now also it is happening or what? Just check it out. रुको जरा, सब्र करो। कौन बोला ठीक नहीं होगा? इज इट ओके? ठीक हो गया? हे यूट्यूब, ठीक कर दिया। चलो लेट्स सी, 1 घंटे तक बस ठीक रह जाए। बट आप जब पढ़ा रहे होते हो तभी तभी होता है। कौन है वो शत्रु? जाओ गिरीश, उस शत्रु को हटाओ। एलेक्सा को बैठाए हो क्या? मैं तो एलेक्सा यूज ही नहीं करती यार, फिर आदत पड़ जाएगी करके। चलो, so what happens here is basically this is a car and the pollutants are released. The air parcel is there. That is the pollutant. So this air parcel, when the height increases, the air parcel's temperature also decreases. The rate at which the temperature of pollutant also decreases with increase in altitude, that is known as adiabatic lapse rate. You guys would have studied in your chemistry, PV gamma is constant. Okay, so what happens here? It is not exchanging its heats, but as the air parcel goes up, it tries to expand. And if volume has to expand, it will use its internal energy. If it will use its internal energy, volume is expanding, PV to the power gamma is constant, pressure has to reduce. Pressure is directly proportional to temperature. So, temperature will also reduce. Prashant, I said that there is a parcel of air, the pollutant is there. When you go up, this pollutant temperature also decreases with increase in altitude. This is an adiabatic process, that means PV to the power gamma is constant. As the pollutant goes up, it tries to expand. The volume increases. How can it increase its volume? By using its own internal energy. The pressure will decrease, and you know the formula, PV is equal to nRT. So if the pressure is decreasing, the temperature is decreasing. So what we say is that both the surrounding air and the pollutant temperature decreases with increase in altitude. When it decreases for surrounding air, it is environmental lapse rate. When it decreases for air parcel, that is adiabatic lapse rate. Now, unstable environment is that where environmental lapse rate is more than the adiabatic lapse rate. Why you call it unstable? See, environmental lapse rate is more. Now, for pollutant, I will use P, and for air, I will use A. Now, environmental lapse rate is more. That means for both air and pollutant, the temperature is decreasing, but the temperature is decreasing more rapidly for environmental lapse rate. So temperature is less. Temperature of air is less. Temperature is less. So density will be what? Density will be what? More or less? Forgot to drink it all. Garam hawa, warm air. Which is warmer? Pollutant is warmer. Pollutant temperature is more. जिसका temperature ज़्यादा, more the temperature, it is lesser in weight. गरम हवा हल्की होती है. Okay, so the density of it will be less. The temperature of air is less, the density will be more. So what will be happening in this case? Rapid mixing of pollutants will take place. Rapid mixing of pollutants will take place. So it creates an unstable environment. Now, since ELR is more than ALR, so it is like super se upar, so that's why in place of ELR, you call it as super adiabatic lapse rate also. So in some books, instead of ALR, they write it as SALR. So it is trying to say super adiabatic lapse rate. Okay. While in the case of stable environment, or you call it sub-adiabatic environment. Why? Because in this case, ALR is more than ELR. ALR, ELR. See, here the height is there, here temperature is there. So if you calculate the slope here theta 1 and you calculate the slope here theta 2, you will see that the theta 1 will be more than theta 2. So what will be happening? Both temperature will be decreasing, but the temperature will be decreasing rapidly in the case of adiabatic lapse rate. If temperature of pollutant is less, so the density will be more and the temperature of air will be less. So what will happen here? A stable environment will be there. A stable environment will be there. So there will be no mixing which will be induced here. Okay. So this is the stable environment, or you can say the sub-adiabatic environment which you will get it. Now, talking further, neutral environment. Both are decreasing. The rate is same. ELR is equal to ALR. That is known as what? Neutral environment. Coming further is inversion. Inversion means अभी तक हम decrease को क्या बोल रहे थे? Positive. Decrease was termed as positive. Now if increasing is taking place, you will call it as negative. So ALR, remember, pollutants temperature will always decrease with increase in altitude. But if the surrounding air temperature increases with increase in altitude, you call it as inversion, or you call it as negative lapse rate. Now, inversion is of two types: radiation inversion, subsidence inversion. Radiation inversion, you call it as surface inversion also, because you see it on the surface. Like, वो गाना सुना है ना, वो राता लंबिया लंबिया रे, तो वो रेडिएशन इन्वर्जन के लिए. बता, मैं अच्छा नहीं गाती हूँ, बट थोड़ा सा सुन लो. क्यों? रातें लंबी होंगी, सर्दियां, विंटर नाइट्स, रातें लंबी हो जाती है ना. 7 PM you see darkness, 6 PM, 5 PM. So what is there? Darkness is there. Darkness is there. Winter season is there. So what happens is, the surface near to it, you will see, यहाँ पे ठंडी हवा आ जाती है. ठीक है, लैंड ठंडा हो जाता है, और सराउंडिंग टू इट यू विल गेट अ कोल्डर एयर एज कंपेयर टू हियर वेयर यू गेट वार्मर एयर. सो दैट इज द रीजन what happens here in radiation inversion. That will happens when long winter nights are there. जैसे सुबह होगी खत्म, टाटा बाय बाय गुड बाय, रेडिएशन इन्वर्जन कॉन्स. So it happens on long winter nights. अगर आप इसको, if you want to see it on prominent basis, so then you will see it in the case of polar regions and all. You can say this radiation inversions. So near to the ground, you will see that the temperature is less as compared to the temperature present above it. रात बाकी. दास जी को बहुत गाने बन रहे हैं, मेरे साथ मेलोडी खेल रहे हैं. चलो एक दिन बैठते हैं. So this is the radiation inversion. Okay. Why? Because as we go up, the temperature is increasing. Okay. Subsidence inversion, this you don't get it in the surface. What happens? Due to cyclones and all, what will happen? The wind subsides. Okay. So the wind, what does it goes? It goes subsidence. So what you will see, that as you go up, the temperature increases. So that is subsidence inversion. Generally, it happens in the case of cyclonic conditions and all. Okay, so this happens in those conditions. Radiation inversion, you will see it near the surface. As I told you, right now you will be seeing radiation inversion, subsidence inversion during the case when air moves from high pressure to low pressure. There you will see subsidence inversion. Okay, now देखो मैंने कितनी अच्छी गाड़ी बनाई है. टाइपिस्ट बोलेगा बनाया मैंने, मैम क्रेडिट ले रही है. ओके, धन्यवाद अरुण. ओके, so what happens here? This is a car which you can see it. बोलोगे मैम बैलगाड़ी से कम नहीं दिख रही है, कार है. So what is happening? The gas which is released, it is known as plume, and the source of their origin is known as stack. Because right now we'll be studying about plume behavior. So first is the looping plume. Highly unstable because here ELR is more than ALR. Here what will happen, as I told you, rapid mixing will take place. So if anybody is living near to it, uske घरों में चला जाएगा चिमनी का पानी. Okay, so this is what looping plume. See, this loops are formed. So that's why its name is looping plume. Okay. Coning plume. When the wind velocity, it depends upon the wind velocity. Here, this is a stable environment. The plume which is generated, it is in the shape of cone. So you can see this is a coning plume. Next, talking about is the neutral plume. Neutral plume, what will happen? ELR is equal to ALR. Vertical upward movement will take place. Simple. See, one time question has been asked in GATE examination regarding match the following. Now, what they can give you right now is like they can tell you vertical upward mixing takes place, identify the type of plume, and they will give you 4 options. So you should be able to tell that which is the correct option. Okay, so that's why the features of that plume also you should know. Next coming is the fanning plume. Fanning plume नाम से समझ में आ रहा है. It will spread horizontally. How it will happen? How fanning plume will function? Fanning. See, ALR always decreases. ALR will always decrease and always decrease. But here inversion condition will take place. ELR. This is what? This is fanning plume. Fan, horizontal. Okay. Next coming to lofting plume. Out of all the types of plume, the best is lofting. The worst is fumigating. Lofting plume. So see it here. पहले surface inversion हो रहा है कि बाद में? First surface inversion is taking place or afterward surface inversion is taking place? First inversion, then ELR is greater than ALR. So here it is inversion. Since it is taking place from the surface, this is surface inversion. वो राता लंबिया वाला. ठीक है, वो वाला inversion नहीं है. ठीक है? So this is surface inversion or you call it as radiation inversion. Okay, this is the best. Pollutant super है, हमें धरती वासियों को कोई problem नहीं. We don't have any problem. The pollutants is up, going there, no issues. Okay. Fumigating plume. Fumigating plume. Fumigating plume worst है, just opposite है. कैसे opposite? इसमें पहले surface inversion हो रहा था. ELR को वैसे ही रख लेती हूँ. इसमें बाद में होगा. Here ELR is greater than ALR and then surface inversion. Okay, ये pollutants troposphere में ही रहेंगे. Problem है हमारे लिए. G कैसे पाएंगे? Worst. Lofting the best, fumigating the worst. Okay. Now last is trapping. Trap कर दिया. First surface inversion, afterwards surface inversion, so trapping is being done. एक और होगा, trap कर दिया. Okay, so trapping is done. And this inversion अभी पहले भी, बाद में भी और बीच में trap कर दिया, super adiabatic condition. So this is the trapping plume. Simple types of plumes are there. Now let me tell you one thing. बहुत simple questions आते हैं. Let me tell you one thing. ELR there are 2 dry adiabatic lapse rate. एक होता है ड्राई एडियाबेटिक लैप्स रेट और एक होता है वेट एडियाबेटिक लैप्स रेट. वेट इज 6 डिग्री सेल्सियस पर किलोमीटर. जब हम बोलते हैं क्लाउड लेवल्स के ऊपर जो होता है वो वेट होता है और क्लाउड लेवल के नीचे जो होता है वो ड्राई होता है. बाकी ये झूठी कहानी है, क्योंकि क्लाउड लेवल के नीचे, बिलो द क्लाउड लेवल ऑल्सो यू गेट partial. It is not completely dry, it is not completely wet, it is partially saturated, but in the books it is written, it is followed, so we use it. For wet we use 6 degrees Celsius per kilometer. For dry what we use? For dry what we use? 9.8. dry के लिए बता दो. What we use for dry? Tell fast, Dinesh, Girish, everybody. So simple questions have been asked. Let us suppose ground temperature was 40 degrees Celsius. Okay, so what will be the temperature? What will be the temperature at a height of 0.5 kilometer? So if not anything, nothing is mentioned, take dry. Until and unless they mention wet adiabatic, then only take that. Otherwise, don't take. ELR value varies from place to place. I am living in Bhilai, Dinesh is living in Jalandhar, Dasji is living in Kolkata. Everywhere what is happening, ELR will change. But ALR value will remain same. So 40 degrees Celsius, let us suppose this is there. And if it is talking about ALR, so 9.8 degrees Celsius reduction is taking place. That's the minus side for 1 kilometer. So half kilometer, how much will be there? 40 minus 4.9 degrees Celsius. So this will be the temperature. 40 minus 4.9, 35.1. This will be the. So such sort of questions are being asked. Okay. Now, one more type is that asked, that also I'll deal it. Now, stack means chimney. So if in the question right now they haven't asked, but they can ask you in 1 marks questions. If they ask you to calculate the height of the chimney, there are two formulas. One is 74 QP to the power 0.27. Another one is 14 QS to the power 1 by 3. QP formula you will use when in the question it is given you particulate matter. But remember, this is an empirical formula. You have to take care of the units. Particulate matter in tons per hour and QS is sulfur dioxide emission in kg per hour. Okay, so you have to use this. Now, last is control of particulate pollutants. So first is gravity settling chamber. Nothing to apply, no brain to apply. Bring the gas, whatsoever pollutants are there, whose weight will be more, they will settle. Simple. Simple design, no brain, nothing is there. But the problem is efficiency is less than 50%. Large space is required and only those large particles will get settled. So smaller particles will not settle. This is for gravitational settling. Centrifugal collectors, centrifugal case. What is that? Here closed chamber is there. What you can see, vortex motion, so they will strike to the walls and whatsoever particulate matter, thoom, 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 and it will have like I'm doing the breakdance dance, thoom, thoom. It will get settled down and the clean gas I will get out. Okay, clean gas will be out. Where it is, clean gas is out and the dust will be collected from water. So if you want to calculate it, this is mv square by r. Just simply write mv square by r. That's it. Okay. So this you can use. Considerable efficiency you will get around 50 to 90%. This is for घुमा कर झूम बराबर. It is झूम बराबर झूम बराबर. गाना का मेलोडी चल रहा बताओ. This is centrifugal collector. Okay. Now दिमाग नहीं, inexpensive, lesser area is there. Efficiency भी ठीक ठाक मिल जाती है, अच्छा बंदा है. Okay. Now talking about disadvantages, already told you. Dust and all are there. Now 3 things which function almost equally: spray tower, wet cyclonic scrubber, venturi scrubber. What happens here? यहाँ हम use करेंगे पानी, but the only difference which you will get is in the efficiency and their method of operation. You use spray tower particle. This is important because they can ask you once a question, if I am not wrong, 2020. A question regarding this sort of asked, bag house followed by electrostatic precipitator, this question was asked, like this question. So they can ask question, remember one question for sure they will be asking for air pollution. So you cannot leave it. Okay, wet cyclonic scrubber. What a mistake. Venturi scrubber. Okay. This is different. This is not there. 95 micrometer is very big and 9.5 will be there. I'll check it out once. Okay. Venturi scrubber is there. Now, talking legs, Venturi scrubber, if I talk about, next is what is being done. So first I'll show you. This is the spray tower. You can see. The water, dirty gas goes here, clean water we will take. So what will happen here? Absorption technique has been followed. Dirty gas goes, whatsoever particulate matter, dust is there, water will absorb it. So clean gas will go out and the dirty water will go out from here. Same thing which will happen in wet cyclonic scrubber. The method is different but the thing is same. What will happen? Here the dirty gas will go and here the water will go, but here perforations are there. Small holes are there from which the water goes. Okay. And now what we'll do? Again here absorption principle. Whatsoever pollutants are there, they will get absorbed and the clean gas will go out. Okay. So this is wet cyclonic scrubber. Now the most important is the Venturi scrubber because you are doing the same operation 2 times. If you do the same times, बाप रे मैम आपके गेट में कितने नंबर आए, तो तुम एक बार ही लिख देते, इतने नंबर इतनी बार क्यों लिखे? मेरे को तो ना एनआईटी और आईआईटी ने बोला कि आप ठीक ठाक दिखते हो तो आप आ जाओ. ठीक, ऐसे हो गया था मेरा एडमिशन. ठीक है. अरे यार, अब एक दिन ना यश मैं सब गोल्ड मेडल लेके बैठूंगी पहनकर, गोल्ड मेडल लेके बैठूंगी पहनकर, और फिर वो अपनी कॉन्वोकेशन सेरेमनी एनआईटी और सब जगह की मैं लाके दिखाऊंगी. फिर आईआईटी में मैं नहीं गई, उसका एडमिशन लेटर भी दिखाऊंगी. फिर उसके बाद विश्वास हो जाएगा न्यू ब्लॉग जी को. चलो वेंचुरी स्क्रबर की बात करते हैं. लेट्स टॉक अबाउट वेंचुरी स्क्रबर. So what will be happening is dirty gas will be here. In the first chamber, you will be providing water. So what will be happening? What will be happening here? Absorption principle. Second, you are doing what? ये एक तरीके से cyclonic की तरह behave करेगा. So that whatsoever or gravitational basically. So what will happen? You have provided a settling chamber. So those impurities which are heavy, they will settle down. So actually the operation is done twice. So comparatively greater efficiency is obtained for the case of Venturi scrubber. That's why if you see it, Venturi scrubber, you get 99% of the efficiency. Okay, as compared to any other. Now, talking about one more thing important. This is very important. The spray tower and Venturi scrubber, they not only remove gaseous pollutants, they remove particulate matter also. Both. Right now, every removal we were talking about particulate matter. Venturi scrubber and spray tower remove particulate matter, but they also remove gaseous pollutants also. Okay. Now, this is the best one. कपड़ा है but हाँ गीली हवा नहीं ले सकते, सूखी हवा चाहिए, dry air. So what will happen? Dry, dirty air will pass through it. Whatsoever is the clean air will go out, and that particulate matters and all will get trapped. So this is, it has shown you one fabric filter, multiple number of filter bags are here. Okay, so this is big house filter. You can see less than 1 micrometer particles are also removed, highest efficiency, and even the smallest particle size is being removed. Okay, but the thing is it has to be in dry state, that you have to maintain, and the high temperature gases से कहीं कपड़ा ही ना जल जाए. So that is the reason temperature is also to be maintained. Okay, Millo, electrostatic precipitator. In every power plant you go, you will see this electrostatic precipitator, ESP. What we do it here, you pass the gas, they gain the charges, then you will pass it through the plates, so the charges attract and eventually those particles are removed. As simple as that. So what is happening? The flue gas is made to pass through this highly ionized plates is there. So they get the charges, they go through the plates, okay, the dirty gas will go in, they will attach to the respective electrodes and you will get the clean gas out. So this happens in the case of electrostatic precipitator. There is the one formula which is used. This is the formula 1 minus e to the power minus w a by q. Very important. Remember this because questions has been asked twice. सबसे बेस्ट पेड़ पौधे लगाने से होगा होगा भाई, पढ़ने से और पेड़ पौधे लगाने से ही होगा. So efficiency is 1 minus e to the power minus w a by q. Eta is the efficiency, A is the collector area, Q is the discharge and W is the migration velocity. Okay. Simple questions are being asked from this. Efficiencies, let us suppose example questions. It's a lallu questions. If 96% is the efficiency, collector area is this much. If 97% is the efficiency, collector area is this much. What will be the collector area if 99% efficiency is there? This is given, and this is asked. Two equations not needed also. From any one equation, calculate what? W by Q. Substitute it here, you will get the answer. Such simple questions आए थे. वाह भाई रोहित दिल जीत लिया यार. मतलब क्या दे दूं मैं तुम्हें, क्या दूं बताओ. मैं अपना टाइटन आई प्लस का चश्मा तुम्हें गिफ्ट कर देती हूँ. आ जाओ. क्या गजब की बात कर दिया रोहित कुमार, दिल जीत लिया. तालियां हो जाए इनके लिए. चलो. Okay, fine. This is an MSQ question, guys. Solve it. इतना पढ़ा दिया. Tomorrow is my hydrology paper. How can I take class today? Which class you want? Come on, guys. MSQ question. Drift will drift velocity. See, electrostatic precipitators, you are charging the particles. You are passing it through a highly ionized plate where they get charges. So the velocity which those charged particles attain, that is known as the drift velocity. Okay? A and D. See, this is wrong. Environmental lab state changes. Looping flume occurs during a super adiabatic. This is correct. With increase in height, temperature of ambient air means the surrounding air changes. Okay. This when you say na ambience अच्छा है. When we go to the hotels and all, मेरी selfie click करो, ambience अच्छा है means surrounding अच्छी है. So that is ambient is the surrounding air changes. So when the temperature decreases, so this is environmental lab state. Correct. C is also correct. Lofting plume occurs when above the surface inversion, a strong adiabatic condition. This is also true. Who said not? Tiksha, you forgot C1. Lofting and fumigating, beta. Where it is, guys? Where it is? Lofting first inversion, then super adiabatic. Fumigating opposite. So that is only written here. Just check it out. Above the surface inversion. Above the surface inversion, strong super adiabatic condition. Order is mentioned na. When above the surface inversion के ऊपर. Surface inversion के ऊपर. Got the Girish? Fine. The last question. So, I'll tell you the formula first. Total suspended particulate matter in microgram per meter cube if you need. the concentration of that total suspended particulate matter particle in ppm into the mass, technically it is molecular mass, into 1000 divided by volume of gas. This is the formula. Now, volume of gas at standard temperature and pressure condition. Which one is above, which one is below? दिया तो है. देखो ना, गिरीश. Above surface inversion के ऊपर. It's mentioned बेटा. Fine. चला गया मेरा. So, the volume of gas at standard temperature and pressure. Pressure is 1 atmospheric. Temperature 273 Kelvin. Okay. So, the volume occupied will be 22.4 liters. If any one of the thing changes, if pressure changes, temperature changes, if any one of the thing changes, the volume will not remain same. Then you have to calculate the volume. There is a relationship once upon a time in chemistry you would have studied P1 V1 by T1 is equal to P2 V2 by T2. So from this relation you can calculate it. Now see this question. It is asking me in parts per billion. 1 parts per million is equal to 10 raised to power 3 parts per billion. Is it correct? गलत भी लिख सकते. So now the concentration it has asked. First calculate the weight of CHCl3. CHCl3 weight is carbon is 12, hydrogen is 1, chlorine is 35.5 into 3. How much is the weight coming? This is the weight. This is coming. Okay. Now this is the 119.5 grams. It is the waste coming. Now this TSP will be how much? TSP is given to me directly 0.4. 0.4 value it is given to me directly. Concentration in ppm first I will calculate. Molecular weight I know 119.5 divided by 1000. Volume I have to calculate. I cannot put 22.4 liters. Why? Because pressure is standard but temperature is 293 Kelvin. So first what I need to do, I need to calculate the volume. So here the pressure was 1. Here the volume is 22.4. Temperature is 273 Kelvin. Here the pressure is 1. Volume I have to calculate. Temperature is 293. Come on guys. What is the volume? Come on guys. What is the volume? How much is the volume coming? Bas, khatam. Tata, bye bye. From here what you will get 8.047 into 10 raised to power minus 5 ppm. So multiply by 10 raised to power 3 for ये क्या जादू हो जाता है यार इस मैजिक पेंसिल है अपने आप स्लाइड आगे बढ़ जाती है. So parts per million multiply by 10 raised to power 3 you will get 0.08. That's it. So this completes your entire environment marathon. Any doubts? Now we will take a midnight session tomorrow. Today I think you guys are exhausted also. So we will take it on Sunday I guess. Salute है जितनी लंबी क्लास लेने के लिए. Thank you knowledge अड्डा. आपसे ही नॉलेज ले रहे हैं. आपका प्यार ही है. स्टार्ट किया 90 देखो. थैंक यू अरुण थैंक यू. अपनी ESC की प्रिपरेशन के साथ साथ आपने मुझे देखा. थैंक यू एवरीबॉडी. सो एनी डाउट्स you can ask to me in my telegram group. PB related calculation problem आती है. Girish, this is a gate problem only beta. This is gate problem only. कैलकुलेशंस आती है और आई भी है गेट में क्वेश्चंस. ओके So this type of questions they ask, and one more type questions are being asked here. I thought of telling. Just one more type question are being asked. Where is that PDF? Mm, just a minute. This is a patent question asked 2-3 times in your gate examination. Last इसको भी कर लेते हैं, अब छोड़े क्यों? Air pollution. Elevation in meters, it is given to you as how much? 10, 60, 130, and temperature is given to you as 15.5, 15 and 14.3, and it is asking you the atmosphere is classified as stable, unstable, neutral, inverse. 2017 IIT Roorkee. See, if this thing comes, always remember ALR is 9.8 degrees Celsius. But one thing, if in the question it is telling you to take ALR as 10 degrees Celsius, in that case you have to take ALR as 10 degrees Celsius. Okay, so you calculate ELR for first this condition. ELR you will calculate, you know, delta T by delta Z. So how much is the change in temperature? 15.5 minus 15. I know decrease is taking place. 16 minus 10 divided by 1000. How much it is coming? God break 9 hours. Thank you, thank you. हाँ करवा दूंगी, इसको बस कर लो जल्दी. 0.5 into 1050. 10 degree Celsius per kilometer. Okay, you can do it for 15 minus 14.3, 130 minus 60 divided by 1000. So this will 15 minus 14.3 to 10 degrees Celsius. So ELR is 10 degrees Celsius, which is greater than ALR. So this is an unstable environment. वाह अरुण, थैंक यू. मेरे को प्रॉब्लम आती है ऐसा. थैंक यू. 95 आवर्स, बहुत अच्छा मैम. थैंक यू वामसी. इसकी पीडीएफ मिल जाएगी. अभी मैं इसको पीडीएफ में ध्यान से मैं कन्वर्ट कर दूंगी, तो मैं आपको दे दूंगी. इसकी पीडीएफ आपको मेरे यू विल गेट द पीडीएफ इन माय टेलीग्राम ग्रुप ऑल्सो. एवरीवेयर यू विल गेट इट. Okay, and I guess you guys know my telegram group, so you can join me. Tag me wherever somebody asked me doubts also, but I was in the class. So I'll give you my telegram group also. In case you want to join, you can join it. Okay. Okay, so any more thing कि फिर टाटा बाय बाय करे यार. अब दिल नहीं कर रहा जाने का, अच्छा नहीं लग रहा. ऐसा लग रहा है कि बस चलो. एनीथिंग मोर तो बता दो, नहीं तो फिर अलविदा. कृष्णा दास की शायला दास गाना बताएंगे. अच्छा चलता हूँ दुआओं में याद रखना, ऐसा कुछ. अच्छा, yes, tomorrow Abhinav sir's, good evening sir. Tomorrow Abhinav sir's geotech soil plus foundation is there. Sir, I'll also come to attend, then I'll also learn soil. So 10 a.m. session is there guys. Link already बन चुकी है. Set a reminder. Okay. Zero hardness method एक बार. Girish Sharma's zeolite method gives you zero hardness. In that you take salts like Na2O.Al2O3.X SiO2.YH2O. That method gives you zero hardness, but use only sodium zeolite. Regeneration can also takes place in that. Okay, of sodium zeolite. Calcium and magnesium hardness are completely removed. Okay. Okay. अच्छा, तो हम चलते हैं कि शायला एक दिन हम लोग ना मेलोडी क्रिएट करते हैं. 14 minutes remaining to complete 10 hours. Oh my god. Fine. मैम, environment का small question state easy करवा दीजिएगा next section. Okay, fine. I'll take a midnight session and Girish, I will include question of 1 minute. I'll write it down first. Otherwise, I'll forget. इतने सारे पेन है पर फिर भी पेन नहीं मिल रहा लिखने को. देख रहे हो विनोद. जस्ट अ मिनट. टेल मी क्या क्या चीज इंक्लूड करना है. चलो पेन को सही लिख लेते. कुछ बताओ. What the things I need? Firstly, solid waste, ash-free basis wale questions, and what else? Zero hardness wale questions. What else? Be fast. Up to 8 so that we can make 10. Continue up to 8. 10-hour sessions. Okay. What else, guys? Tell me fast. What else you want in the question series? I will prepare questions. Ash-free basis, zero hardness. What else you want? Fast, fast, fast. Microgram to PV meter conversion in BOD questions. Okay. वो Streeter Phelps equations के भी questions चाहिए क्या? You want Streeter Phelps equation questions also? Streeter Phelps BOD done. Okay. Fine. So this questions and Girish told me regarding zero hardness. Okay, fine. Mentioned. So we'll take all these questions into account, more number of questions for you, and there will be a question series also coming. So don't worry, maximum questions. We know सभी engineers के दिल में बस गया है. Okay. SLR plane area में we take L into B और B into H. SLR मतलब क्या? SLR means क्या बोलना चाह रहे हो अरुण? Shear speak more clear बेटा. If you talk about velocity overflow rate, the plan area or the surface area is B into L. Cross sectional area is B into H. अगर आप sedimentation tank की बात करो, plane area is B into L. Noise pollution भी करवा दीजिए. Gate में नहीं है but करवा दूंगी. Okay, Prashant. I will do short questions. 1 marks questions. No? Okay. Any more doubts? चलो फिर चलते हैं. कुछ और क्रिएटिविटी करते हैं. इंडियंस का पता है क्या? एक बार कोई चीज टूट जाती है ना तो अगली बार बहुत संभाल के रखते हैं. देखो अभी मेरा एक चश्मा मैंने तोड़ दिया है तो अब मैं दूसरे चश्मे को कितना संभाल के रख रही हूँ. डेली डोज कंटिन्यू है लर्नर. टाइम चेंज हो गया. अब टाइम डेली डोज का 8 PM हो गया अभी. ठीक है. भेल का भी करा दूं, सब करा देती हूँ. अब बस जीएस पढ़ना है. चलो तो मिलते हैं अब. अरे बहुत टाइम हो गया. टाइम पास नहीं करना अपन को. ठीक है. कभी अलविदा ना कहना. ठीक है. अलविदा नहीं बोल रही हूँ. You will get the PDF of this class. Okay. And the calculation mistakes and all check कर लेना. थोड़ा बहुत अगर होगा तो कहीं पे तुम ही लोग ने बताए आंसर्स. मेरे उसमें कुछ नहीं है. Okay. Thank you so much everybody. I didn't felt like I'll be able to take such a long class. But Prashant, Ayushi, Sachin, there are n number of names. Devanshu, Swapnil, Arun and everybody. Okay, Das ji, thank you so much for being with me patiently and listening to me. Arun का तो खून भी निकल गया था कान से, फिर भी उसने मुझे सुना. Okay. So guys, knowledge adda, thank you everybody. Lots of love to you. Similarly, I'll be coming on Wednesday with hydrology and irrigation marathon. You have to be there with me. Promise me. Love you everybody, and promise me you'll be there. Okay, hydrology first, then we'll go for irrigation. Okay. Okay, you have to rock it in gate. See, I was there with you. You know, I woke up in the morning because of you guys. So you have to crack gate at any cost. Okay, fine. So we'll meet you. Thank you so much, guys. अब रुलाओगे क्या पगले? चलो रखो अब. Okay, guys. Sachin, everybody, thank you so much, guys. Good night. Take care of yourself. Bye bye and study hard.